join me welcome our esteemed dignitaries, Dr. Jitendra Singh, Honorable Minister of State, Minister of Earth Sciences, Dr. M. Ravichandran, Secretary MOES, Dr. P.S. Goyel, Dr. Shailesh Nayak, Dr. Kamal Lochan Mishra. I request the dignitaries to please be seated on dais. Good morning, distinguished guests and my dear colleagues. I welcome you all on this momentous day. I am Sunanda, and it is my honor to welcome you all to this conclave to commemorate 20 years of the 2004 Indian Ocean tsunami. To honor our esteemed guest, I request Director INCOIS to kindly present bouquets to the dignitaries on the dais as a gesture of our respect and gratitude. I request Ms. Suhasini to kindly support. Now, let us seek blessings and positivity through an invocation. I request Ms. Sandhya to kindly lead us. I request kindly to rise, please.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुदैत्यकलच्चेत्रे गुरुधर्मसदाराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डखण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि. Thank you.
I now request our dignitaries to join for the lighting of the lamp, a tradition symbolizing the dispelling of darkness and the ushering of knowledge and hope. Ladies and gentlemen, 2004 Indian Ocean tsunami left a scar that time may soften, but the memories and the pain still endure in the hearts of those who lived through it. So I now request everyone to rise and observe a minute of silence in solemn memory of the thousands who lost their lives in this devastating event. Thank you. Kindly be seated. I now invite Dr. T.M. Balakrishnan Nair, Director of INCOIS, to deliver the welcome address. So please.
It is my privilege to welcome our chief guest, Dr. Jitendra Singh, Honorable Minister of State, Independent Charge of Ministry of Earth Sciences. Welcome, sir. Dr. M. Ravichandran, Honorable Secretary, Ministry of Earth Sciences. Dr. P.S. Goyel, Distinguished Professor, ISRO and former Secretary, MOES. Dr. Sailesh Nayak, Director, NIAS, as former Secretary, Ministry of Earth Sciences. Dr. Srinivas Kumar, Head IoT WMS and former Director INCOIS, and Ms. Tiziana Bonapes, Director ICT UNESCAP, Dr. SSC Shenai, MOES Chair Professor and former Director INCOIS, Dr. Kamal Lojan Mishra, IAS, Executive Director Odisha State Disaster Management Authority, Dr. J. Radhakrishnan, Additional Chief Secretary, Tamil Nadu, to this conclave to commemorate 20 years of 2004 Indian Ocean tsunami. I also extend my warm welcome to Director of MOES Institute, NIOT, NCS and NCCR, BGRL, and the Director of ISRO, NRSC, NGRI, all national and state disaster management authorities are present here. The esteemed partners from the Navy, Coast Guard, Marine Industries, and our dedicated colleagues from INCOIS. And not the least, I am very happy that we have the presence of village leaders who has actually got the tsunami ready recognition certificate. I welcome all of you for this multi-stakeholders conclave. So as you know that 24 years, INCOIS has evolved as a oceanographic data center, actually one-stop stop solution for all data, information, early warning for the entire India and Indian Ocean countries. So we provide the early warnings for tsunamis, ocean forecast, potential fishing zone, and it has a lot of socio-economic significance for the India and the blue economy. So INCOIS, as you know, sir, actually it serves as a bridge between ocean science, disaster management, and the blue economy stakeholders. And INCOIS utilize all the advanced technologies to deliver innovative and impactful services to society, as we have you have seen in our Synops lab. Actually, this devastating tsunami event exposed the immense socio-economic impact of tsunami and highlighted the urgent need for the advanced warning system and preparedness, not just for India and across the region. So this, in response to this, Government of India enacted the Disaster Management Act 2005, and following that, India established its own tsunami early warning center in by the Ministry of Earth Sciences in collaboration with the ISRO, DST, and CSIR. So this is actually a center which give early warnings for the tsunamis, and as of now we have given 103 tsunami Geminic events, and most importantly we are not given any false alarm to that. I am very confident that we will prepare to tackle any tsunamis coming in future. So not only that, INCOIS is not stopped by the only setting up a operational tsunami warning system, and also it gone to the community. It made a community resilience program. It is called the Tsunami Ready Communities in collaboration with IOC UNESCO. I'm very proud to say, sir, India is the first country having this Tsunami Ready Community, and India is the highest number of Tsunami Ready Community in the world. So, and we are also in collaboration with many NDMA as well as many disaster management, state disaster management authorities to make entire India as tsunami ready, multi-hazard ready, and climate resilience. This is our Amritakal vision. With this, actually, I once again welcome all the dignitaries. I'm very happy to see all the stakeholders here, from the scientists to the disaster managers, to the administrators, to the village leaders, and all other dignitaries. Also, I invite the media and media persons and all the dignitaries present here. Once again, thank you, sir. Thank you very much. Jai Hind.
I now invite Dr. P.S. Goyel, Honorary Distinguished Professor, ISRO, and former Secretary, Ministry of Earth Sciences, to podium to share his opening remarks.
Good morning to you all. Honorable Minister Dr. Jitendra Singh Ji, Ministry of Earth Sciences, Dr. Ravichandran, Dr. Shailesh Nayak, all invited guests, experts. When I came here as a secretary, Dr. Harsh Gupta handed over a concept note on tsunami warning system to be set up here. This word I had probably read in my school, tsunami, but neither I understood that time or later, till on this day, 20 years back, this really happened. I think the whole country had forgotten about tsunami because the previous time we had in 1942. So in between there was nothing. But this was a really kind of earth-shaking event for this country. When this came to set up the tsunami warning system, converting that concept note to a cabinet note was an easy task. But the difficult tasks or challenges we had in our, that time, ocean development was a sort of resolving internally a fight within, let's say, INCOIS versus NIOT and all that. Because I just went back to 70s when in ISRO, when we started, we used to have inter-center, okay, who will do what. Exactly that was happening at that time. So it took some time to resolve. Maybe that experience of ISRO helped me in making sure that, okay, INCOIS will be the service center and it will be set up here. The second challenge was how to set up a system which actually does the right thing and does not give a false alarm. Dr. Mishra mentioned, Dr. Nayak mentioned rightly that we have not issued a sort of warning or false alarm. The reason is that we are not like Japanese, where you can raise a false alarm and still people listen to you. Here, if you have a false alarm, people don't listen to you next time. So how to do that? You know, when I came here from ISRO Satellite Center, my place was taken over by Dr. Shankara, and the kind of a musical chair that SAC director got vacated. Then Naval Gun moved from NRSA to SAC, so got chair vacated. And Radhakrishnan from Inquest went to NRSA, so this got chair. So there was a director post was not here. So finally, I had to find a solution, not only for the director, but also to have a Tsunami. So I requested Dr. Shailesh Nayak, and very reluctantly, for very valid reasons, he accepted that offer. And once Shailesh came here, then I had not much to worry. He took all the responsibility, and we had the Tsunami Warning Center. Now, the main thing that's important is that we have really not had any false alarm. And that's one part. Secondly, when we had the inauguration after 1 year, this center, Tsunami Warning Center, was announced as the world's best tsunami center by nothing but the UN body itself. So we are proud that we have really got one of the best centers in the world as a Tsunami Warning Center. And even today, normally in the routine things, it happens that you lose a focus. But whenever I have come, I found that the people here are so committed, so devoted, that they will not miss this event. Because this is something, tsunami warning has to be issued. We hardly had 1 hour. If the really earthquake happens somewhere in the region, we just have 1 hour. If we lose that 1 hour, that means the precious time is lost. So the alertness with this center is working is something I think we are all can be proud of it. And personally, I feel that, yes, I'm proud of this team. So you have to keep this alertness all along. And with this, I wish you all the best in the future. Thank you.
I now invite Dr. Shailesh Nayak, Director, National Institute of Advanced Studies, and former Secretary, Ministry of Earth Sciences, to podium to deliver his opening remarks.
Good morning to everybody. Honorable Minister Dr. Jitendra Singh ji, Dr. Goyel, Dr. Ravichandran, Mishra ji, Dr. Nayak, my colleagues here, distinguished guests, ladies and gentlemen. Sometimes, the certain hazards or disaster also leads to certain good things. If you see 25 years back, we had 1999, it's called Paradip cyclone. That time, cyclones were not named. 2002, Bhuj earthquake. And 2004, the tsunami. And the government at that time, NDA-1 government, started discussion about how do we manage such disasters. And 2005, the Disaster Management Act came, and NDMA and all that came. And the rest is a history. You could see that today, we are one of the best prepared country to address any disaster. Now, the tsunami warning system which came, of course, in INCOIS, as Dr. Goyel and Dr. Bala mentioned, it also transformed the INCOIS as a whole. The excellence which was achieved in INCOIS, in the tsunami warning system, percolated in all other fields, and Bala mentioned that today we are one of the best in Indian Ocean. The second, which is a very important thing which happened, is the scientific knowledge which was used up to fullest, but the response of the government and the infrastructure which was created along the coast was also exemplary. And the last thing which was took a little longer, which is obviously, is to bring awareness and consciousness of the people to address such a disaster. And I'm very happy that Orissa has taken the lead, and 25 villages has been made tsunami ready. I think this also needs to percolate all along the coast, and I'm sure it will scale up to the different levels. And not only for tsunami, but I think all kinds of disasters. Because as we are entering the climate change, we are seeing the various kind of hazards which were earlier not that severe has become very intense. This year, Tamil Nadu got almost 3 cyclones. And also continuing to have some depressions and that. Actually, Tamil Nadu, which used to be rain deficient, now become rain surplus. So you need to find out ways and means to extra water as well. So this, I think it is good that after 20 years we are looking back and trying to find out, but I think we also need to look ahead, what we have not been able to do. I think there are still issues about tsunami which can come due to landslide or a volcano or very near-field tsunami. How do we address these issues? And since both the Honorable Minister and Secretary is here, I would suggest that the issue of tsunami geology, which was started earlier but has not taken real, the research on the subduction zone, both on the Makran coast and on the Andaman coast, is very crucial, as well as also to locate the paleo tsunami, which can tell us about what happened in the past. As of now, we know that there is about 300 years recurrence for a smaller tsunami and about 1,000 years for the large tsunami, what we had in 2004. But this, I think, is very critical, and we should continue to find ways and means to understand these aspects, especially the subduction zone. The Burma and India, Andaman plate, has not ruptured for a very, very long time. And if it ruptures, something like what happened in Indonesia, there could be devastation. So we must understand the subduction zone geology, both in Andaman and Makran coast. With this, I wish very best to INCOIS and hope that this event will further improve our understanding of various hazards, and we will be prepared for this. Thank you very much.
I now request our guest of honor, Dr. Kamalochan Mishra, IAS, Executive Director, Odisha State Disaster Management Authority, to address the gathering.
Thank you. Honorable Minister, Ministry of Earth Sciences, Government of India, Dr. Jitendra Singh, respected Secretary, Minister of Earth Sciences, Dr. M. Ravichandranji, respected Director INCOIS, Dr. T.M. Balkrishnan Nayarji, respected Director NIS, Dr. Sailesh Naikji, and Honorary Distinguished Professor of ISRO, Dr. P.S. Goyelji. Distinguished delegates to this commemorative program, the 20th anniversary of the devastating Indian Ocean tsunami, the achievers of tsunami-ready villages from Odisha, and ladies and gentlemen, on behalf of Odisha State Disaster Management Authority and Government of Odisha, extend a very warm welcome to all of you. Friends, the benchmarking of disaster management in our country started from 1999, when the super cyclone struck Odisha, where we lost about 10,000 precious human lives. We were prepared, but we were not prepared for a super cyclone. Our preparedness was moderate, but not up to facing a calamitous situation like a super cyclone. But we have learned from the lesson, and we have started benchmarking it. India is one of the few countries in the world which has benchmarked disaster preparedness. And you must have heard that the Vulnerability Atlas of India, prepared by Bureau of Indian Standards, which has been published by Building Material Technology Promotion Council, and where the vulnerability of houses, depending on the materials used in the construction of the roofs and walls of the houses, subject to 3 particular disasters, have been defined. In OSDMA, which is the first disaster management authority of our country, we were constituted in 1999. We took this publication as the Bible of disaster preparedness, and we started building on it. So India is one of those countries which has actually benchmarked disaster preparedness and its management through this. Indian National Center for Ocean Information Services is one of its kind institutions in our country, which has not kept the scientific knowledge within its premises. It has expanded that knowledge to the grassroots level, and in every tsunami-ready village, the people who are here to receive the award from Honorable Minister, they know the top scientists of an Indian INCOIS. That is the another benchmark we have created, because the scientific institutions, knowledge institutions of our country, they have come out of their campuses to the administrative decision-making process onto the field functionaries where the knowledge is translated into action. Friends, we have come a long way from 1999 to 2024. This year we celebrated our 25 years of existence. But you must have seen that Honorable Prime Minister of India, he has given us a mandate of Vision 2047 to make India a really advanced and developed nation. Disaster management cannot fall behind. So we have been sitting with the McKinsey team appointed by Niti Aayog to prepare vision document for our state for 2047, where disaster management has been given a full chapter and with elaborate plan of action, achievable parameters and measurable indicators, what to be achieved in next 5 years, what to be achieved in next 10 years, and what we will achieve till 2047. To make the dream of our Honorable Prime Minister a reality on the occasion of the 100 years of our independence. Odisha got its special status as a state in 1936. So 2036 is another benchmark we have given to ourselves. So we have collaborated with the knowledge institutions across this country. INCOIS is one of them. And I will definitely extend my thanks to the National Disaster Management Authority for extending their cooperation, and the National Cyclone Risk Mitigation Project, which was implemented after the super cyclone. There, the cyclone warning system was converted into a tsunami warning system, which is existing in Odisha, where 122 alert siren towers are standing to alert the people about an approaching tsunami in the dead of night. So we need technology, we need knowledge, we need cooperation, guidance from the national government as well as the elected representative to go ahead with this. With all my profound thanks to the INCOIS team and Government of India, NDM and others, I extend my warmest thank you to all for actually hand-holding this, because benchmarking is disaster management is no longer confined to the national capitals or national standards. It has to be international. It is a global village. So this UNESCO IOC Tsunami Ready Community Program is an international benchmarking, which we have accepted, spearheaded by INCOIS. Thank you, INCOIS. Thank you all. Thank you very much.
Our honorary guest, Vidar Helgesen, Executive Secretary, Intergovernmental Oceanography Commission, IOC, UNESCO, couldn't join us today, but we are grateful to him for providing his video for recording. I request our ICT team to play the video.
Your Excellency, Dr. Jitendra Singh, Honorable Minister of State for the Ministry of Earth Sciences of the Government of India. Dr. Ravichandran, Secretary to the Government of India, Ministry of Earth Sciences. Dr. Radhakrishnan Nayak, in charge Director of INCOIS. Former Secretaries of the Ministry of Earth Sciences. Former Directors of INCOIS. Heads of the National Disaster Management Authority and Odisha State Disaster Management Authority. ladies and gentlemen, esteemed colleagues and honored guests. Good morning to all of you. Today, we gather to commemorate a profound moment in our recent history, the 20th anniversary of the 2004 Indian Ocean tsunami. I want to extend my congratulations to the Ministry of Earth Sciences of the Government of India for organizing this important conclave, and my gratitude to Dr. Ravichandran for inviting me to speak, even virtually. On this day, 2 decades ago, the world witnessed one of the largest and the most devastating tsunami ever recorded, claiming approximately 230,000 lives across many countries, 15 countries directly affected from Indonesia to India to East Africa, but several countries around the world also experiencing the loss of their citizens, therefore being a tremendously global disaster with global impact. This tragic event served as a global wake-up call, prompting nations to collaborate in creating the Indian Ocean Tsunami Warning and Mitigation System under the Intergovernmental Oceanographic Commission of UNESCO. This was an example of how, in the wake of a tremendous disaster, the world community can come together to make improvements. After 8 years of dedicated international efforts, the IOTWMS became fully operational on March 31st, 2013. This network, supported by tsunami service providers from Australia, India, and Indonesia, now delivers real-time tsunami forecasts to 25 Indian Ocean countries operating around the clock. Additionally, the IOC UNESCO Tsunami Ready Recognition Program has been implemented in 48 communities in the Indian Ocean, including 26 in Odisha. Reflecting on our collective progress, we have made significant strides in enhancing public safety through tsunami early warning systems. However, we must recognize that events such as the 2018 Palu and Anak Krakatoa tsunamis and the 2022 Hunga Tonga Hunga Apai event have challenged our existing protocols, especially for non-seismic tsunamis. These incidents remind us that our work is far from over. Moving forward, IOC UNESCO will continue to collaborate with all stakeholders to ensure timely and accurate tsunami information reaches our vulnerable coastal communities. The UN Ocean Decade Tsunami Programme has catalyzed new collaborative actions that are vital to this mission. India's role, particularly through INCOIS as a tsunami service provider, a UN Ocean Decade Collaborative Centre, a UNESCO Category 2 training centre in operational oceanography, amongst others, exemplifies our commitment to this partnership. As we acknowledge our collective accomplishments, we must also recognise the challenges ahead. I invite all member states, civil society and partner organizations to step up their investments and their efforts. Our goal should be to strengthen early warning systems and achieve 100% tsunami-ready communities across the globe in 2030. In conclusion, the best way to honor those who lost their lives in the 2004 tragedy is to recommit ourselves to the safety of coastal communities and our collective striving for a safe ocean. I thank you.
I now request our guest of honor, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to address the gathering.
Respected Honorable Union Minister of Earth Sciences, Science and Technology, Prime Minister's Office, Department of Personnel and Training, Department of Space, and the Department of Atomic Energy, Dr. Jitendra Singh Ji, Dr. Goyel Saab, former Secretary, Dr. Sailesh Nayak, former Director, former Secretary, and presently Director of National Institute of Advanced Studies, Dr. Kamal Mishra, Odisha Disaster Management Authority, Dr. Balakrishnan Nayak, Director INCOIS, Dr. Srinivas Kumar, Dr. Shenoy, Dr. Prakash Chavan, and various other directors of MOES Center. And also I could see that Dr. Radhakrishnan also is there. And distinguished invitees and colleagues and friends. Very good morning to all of you. Indeed, it is a great pleasure to be here. I remember maybe 20 years back, we were in this campus. That time, we were about 15 scientists, maximum 12 to 15 scientists. We all don't know what is the tsunami. We heard about it, but what is the intricacies, what is the meaning of tsunami signs, or maybe what is to be observed, what is to be modeled, nothing, we don't know anything. So that is the stage we were there. And that time, I think because of we have young nuclear team, the government entrusted the job to us, not only because of the leaders of Dr. Silas Nayak and Goyel ji. And very important thing is that time, even though now we are talking about many things in, don't do each ministry in silos, we have to work together. That time, immediately we brought together as a, all the ministries, Ministerial, like ISRO for communication purpose, for CSIR for understanding the tsunamis and various aspects, as well as Department of Atomic Energy for tsunami model and other things, and our MOS institutions like NIOT and various other institutions, NCCR and other people work together, and we brought in 18 months, in 12 months we set up the Tsunami Warning Center, because unlike other Tsunami Warning Center in Pacific, in USA as and other people are having, they can have a risk, but here we cannot take risk. Once we have given warning means evacuation and other things, it is very, very, very difficult task for us. So we need to be doubly ensured. So that is why our Tsunami Warning Center, when we started, we have three type of things. One is seismic, then water level confirmation, then also modeling. Modeling, we don't have computer that time, so we made a scenarios generated and put up. So that is very unique that time we started. Everybody was astonished that time. So then later on we started with the tsunami model online. Now it is a real-time modeling and other things. So there are many things which we have able to do it, and now it is one of the best center in the world. And also, as many pointed out, we have not even single occasion there is no false alarm. That itself shows that how it is proved. And every then and there is a trend, what is called various trainings and other things has been given to the various users. So that is why we keep on going on this. Because of Tsunami Warning Center, we got many other opportunities. Now, INCAS is an international center for training, ITCO Ocean, that is training center. Also, we have a decadal coordination center. All these things has come because of this. Though tsunami is bad, but INCAS, it is an opportunity to have more and work so that we are able to deliver much more. There are many things I want to say, but at the same time, due to the want of time, of course, tsunami, it is impossible to, we cannot prevent, but we need to have how to prevent. So that is what we are working towards. That so we are trying to do various technologies and innovations we are trying to put in place. I just to already, some of the people have mentioned already, 1 or 2 points in the future directions. Number one, already as IOC Executive Secretary Vidar has mentioned, we need to worry about also non-seismic tsunamis. Either it is volcanoes or landslides, or it is submarine ridges, maybe ocean ridges if it is false, or maybe meteoroids. All these things we need to take care. If it is happen, what is our methodology to understand the process and how to monitor and how to model them and how to predict. So that we need to make some more effort, and also we need to have observation technology, not only tsunami buoys and seismic, and we have better bathymetry and topography, all these things is fine, but also we need to improve our observations, especially in the Andaman Sea. We need to go for a smart cables or cable-based observatory so that we can continuously monitor in various places. And finally, we need to develop not only Tsunami Warning Center, we need to go for multi-hazard warning center. I think NCCR and other people are making coastal marine spatial planning. In coast, what are the infrastructure has to be placed, and what is to be, what is called alert system and other things we need to set up, that we are planning for coastal marine spatial planning. And that marine spatial planning and this disaster warning system, especially multi-hazard warning system for the coast, we need to develop so that this will be one stop for entire warning system, especially oceanic disasters as well as coastal zones. And also there are many other, we have to improve our mitigation strategies, and we need to make awareness and education campaign, and public engagement is important. Not only that, we have to have an involvement of community and preparedness. And also we need to strengthen various other means of dissemination mechanism, whether it is a phone or it is SMS or various social media. All these things we need to use so that the information reaches the people, and also we need to make a 3D, of course, GIS evacuation map and of the coastal belt, various infrastructure we need to develop. And for that we need to work together, understanding, monitoring, everything. We need a collaboration within the ministry and inter-ministry, and also international collaboration. Not only scientific collaboration, but also various stakeholders we need to discuss and understand their requirement, so that we can set up, still further improve our tsunami warning center, multi-hazard warning center. Of course, once the setup is, yes, it is a Herculean task we have set up, but to maintain and manage and sustain and improvement, it is a big task. I am sure that INCAS will be, definitely will be doing this job too in the coming years. And I wish you all the best for the making the wonderful Tsunami Warning Center, and also to continue to monitor the various disasters in this area. Thank you very much.
Thank you, sir. The UNESCO IOC Tsunami Ready program is a community-based initiative aimed at enhancing tsunami preparedness and mitigating risk. In recognition of Odisha State Disaster Management Authority's efforts to make community tsunami resilient, we are proud to celebrate their achievement of IOC UNESCO Tsunami Ready recognition. I now invite our Honorable Minister, Dr. Jitendra Singh Ji, to present the appreciation certificates to OSDMS Executive Director, Dr. Kamal Lochan Mishra. Yes, we now proceed to the inauguration of significant initiatives that mark milestones in advancing tsunami early warning system of INCOAS. I request Honorable Minister to launch the products of request and Dr. Radhakrishnan Nayak to assist. This initiative establishes a structured framework for monitoring and responding to volcanic-induced tsunamis. This SOP aims to enhance detection and provide clear guidance for timely and effective responses to tsunamis generated by the volcanoes. Sir, just one more. The next one, please. Recognizing the critical role of maritime stakeholders, this initiative that tsunami warnings are promptly communicated to the blue economy stakeholders for reducing risk. Thank you, sir. It is my great honor to invite our chief guest, Dr. Jitendra Singh, Honorable Minister of State, Minister of Earth Sciences, to address the gathering. Sir.
Look taller than you. She said, do I need to remove it? I said, no, I want to look taller than you. Secretary, Department of the Ministry of Earth Sciences, Government of India, Dr. M. Ravichandranji, Dr. Shailesh Nayak, Dr. Mishra, Dr. Goyel, Director Dr. Radhakrishnan Rao, seeing all the seniors, Dr. Chennai, the former director, also senior members of the scientific fraternity, ladies and gentlemen. At the outset, I have to congratulate you and also congratulate myself for being here. because I'm sure this is going to be a learning experience for me as well. So I look forward to learn at least one new thing every day, and think I'm going back richer and wiser this evening. So thanks for the persuasion by Dr. Ravichandran, because I was so hard pressed, but he managed to get me here, and I think he did good in doing so. And since I usually don't oblige him by reading his talking points, so I was asking him while sitting there, what else you think is different about this institute? And he said that out of the 5 directors, 4 have become secretaries in the Ministry of Earth Sciences. So I said a wonderful strike rate of 80%, which means very soon there will be a lot of lobbying for this report. And I'm sure what I'm saying is music to the ears of Dr. Radhakrishnan Rao. But having said that, I think it's a proud moment for all of us, as has been said one after the other by each speaker, and it's been recognized that India today is in a position to provide a world-class facility for the benefit of the entire planet, in fact. And as was being mentioned by Dr. Shailesh Nayak, the disaster of Gujarat happened in 2002, and then after this, and the Disaster Act actually came earlier in Gujarat when the present Prime Minister was the Chief Minister over there. And then, of course, it was realized that it had to happen at the central level as well. And the entire idea was envisaged when Mr. Vajpayee was the Prime Minister. And I'm glad that it's been carried forward very illustriously by Prime Minister Modi. So usually it sounds boisterous for a political functionary to talk, but when you have a scientific evidence, you should not lose the opportunity. So having said that, we are all here, as been said, to commemorate the story, the saga, and the lessons learnt from, I think, the greatest human tragedy of the 21st century so far, and one of the greatest, as Shailesh mentioned, is once in 1,000 years. So I don't know whether it's a good fortune or bad fortune that we have been witness to an event which happens only but once in 1,000 years. So many generations after us will be deprived of seeing this event. But as was being mentioned, I think this also, I was telling Dr. Ravichandran, just as pandemic, though being an adversity, brought in many good things. It motivated us to come out with the first DNA vaccine. It gave a quantum jump to our biotechnology department. So also to an extent you should thank Tsunami for having given birth to this institute. Not that you would now wish to have it again and again. That of course would be taken care of. But yes, when we are here to commemorate, and as was being said by Mr. Vidar also, we lost 230,000 lives worldwide and 10,749 in India itself. But I think today what we have, and of course this is a continuous endeavor and a dynamic one, but I think a matter of satisfaction also, because we have the space scientists also here, is that we have today a political dispensation which is very forthcoming and very sportive about such endeavors. Which of course is very visible in the space sector, the way the space was unlocked for the private sector, which nobody ever imagined, nobody ever thought, nobody ever even demanded, because you stop demanding when you think you can't expect it anymore. And still, when we put it across to the Honorable Prime Minister, it was so forthcoming. And there's been quantum leap in the last 4 years. From just 1 digit, we've gone to almost 300-400 space startups, and the first generation of them are the world-class entrepreneurs now. And now the world is looking up to us. So which means that as far as the scientific human is concerned, we were less to none. But maybe some more enabling milieu was required from the level of the policymakers, the political dispensation. And luckily that is happening now. I think it's one of the better times for the scientific fraternity of India. And you would bear me out when we are talking about oceans and in an institute of the Ministry of Earth Sciences, as far as the deep sea mission is concerned, of which of course many of the ingredients are being incorporated over here. Prime Minister Modi spoke about it not once but twice consecutively in his Independence Day address in 2023 and 2022. Now, I don't know how far this is realized by the close observers of the political discourses would bear me out that the country was not much used to prime ministers talking about such missions from the ramparts of Red Fort, which are not very easily comprehensible also across the country. But still, I think that was one way of emphasizing, on the one hand, the priorities of the government led by him, and also at the same time awakening some kind of awareness among the people about what it is all going to be, because when Prime Minister speaks from the Red Fort, at least, if not else, the television anchors would start talking about it. So this has been so much of boost, both in terms of physical support, as in terms of moral support, and then of course we are planning to have a human in the deep sea. I was telling Dr. Ravichandran it's going to be a very strange coincidence. We'll have one human being in space and one deep sea. That's going to happen almost simultaneously. Incidentally, the human mission, space mission got delayed for COVID or whatever. I think we had planned for 25, it may not happen, it may happen early 26. So you could also time it accordingly, so that we could start 26 with one Indian up there and one Indian deep sea. And that's going to be again a record of sorts. And for the first time, I think we have started looking into our marine resources. Why I'm saying so is that the kind of expectation that is required from the dispensation is now forthcoming in a measure which was more than what it is expected. Because when we talk of 2047 India, the Viksit Bharat India, as Prime Minister keeps saying, and we also very fondly keep reiterating, I think as far as we are concerned, the members of the scientific fraternity, our responsibility is to scientifically actually try to understand how actually we will be able to reach 2047. It's easier said than done. So if you try to scientifically analyze it, we would have to look into those resources which were either not explored or remain underexplored. And one of the richest unexplored resources for us in India is the ocean resource, the marine resource, 7,500 long kilometer coastal area. And we have started looking into that. And if we are able to succeed, and then as Dr. Ravichandran was mentioning, we are also trying to create an ecosystem to facilitate that. When we get richer through biodiversity, through minerals, through metals from the seabed, we would also have a biotechnology policy in place. Only 2 months back, we came out with Bio E3, the biotechnology for environment, for employment, for economy. And therefore, you will have a supplementation from there. And coupled with that, what the DST came out with, the National Research Foundation. So a whole lot of ecosystem is being sought to be created to explore these underexplored resources. And most of them, I think, the other two resources which I often keep thinking is possibly the Himalayan resources. Of course, we started a Roma mission, CSI, which we didn't actually adequately explore. And third, of course, the space. But our marine resources, we have certain natural advantages over others. And therefore, coming back to the tragedy of 2004, today Indian Tsunami early warning system is being held with a great amount of credibility across the world. And as was being mentioned by Secretary of Sciences, it's also a reiteration of the whole of government approach that's being sought to be followed. We have the MHA with us, we have the state governments with us, we have the NDMA, and we have gone beyond that also, engaging in international collaborations with UNESCO, and also I saw the brochure mentioning the workshop training going to be scheduled for March 2025 with UNESCO, and the Tsunami Ready Initiative Program, and the UNESCO IOC for the communities, because ultimately if the ultimate goal of every scientific endeavor is to bring ease of living, of course the safety of living we are planning, but the ease of living, then of course the 24 communities being recognized not only for tsunami ready, but also for fisheries and various other aspects. So there's a community-centric approach also at the same time, which is happening, which we may not realize as scientific researchers sometimes, but we are doing much more than what we think we are doing. And therefore, I'm glad to learn that more and more states are coming on board. I was asking Dr. Ravichandran, he says Gujarat, Tamil Nadu, etc. are also now looking forward. And then they, as he mentioned, the non-cyclone tsunamis, and therefore the multi-hazard early warning system is what he was telling me is, being envisaged. And therefore, I think to be brief, as we move on and we plan ourselves for India 2047, of course, we'll have to utilize to the maximum the resources which were not utilized, because how else is going to be the value added? We were fragile 5, now first 5, then we have to move on to 3, of course, which will happen in next few years when we are 5 trillion economy. But then to move on to 1, we'll have to add substantial value. So as I said, these are some of the resources. But at the same time, while exploring these resources, equally important would be to preserve the resources that are already existing. And therefore, your role becomes bidimensional. You are, on the one hand, helping India to explore the unexplored resources through a wider mandate of the Ministry of Earth Sciences and the Ocean Science. And at the same time, you are also helping India to preserve the resources by preparedness. If not possible to predict, as Dr. Ravichandran said, they say forewarning is half a warning. So at least you are indulging in that. So you are actually serving the cause of Viksit Bharat 2047 more than one level. And as has been mentioned repeatedly by Prime Minister also, that each and every citizen should be contributing to the making of that century India. I would say every citizen, every asset, and every resource ought to contribute. And to that extent, I think you will have the satisfaction that INCO has also contributed to the making of India 2047. Thank you very much.
Thank you, sir. On behalf of all present, I request Dr. M. Ravichandran, Secretary, Minister of Earth Sciences, to felicitate our Honorable Minister as a token of our appreciation for his gracious presence. Thank you, sir. To formally conclude the inaugural session, I invite Mr. E. Pattabi Ramarao, Group Director, Audit, INCOIS, to deliver the vote of thanks.
Honorable Chief Guest, distinguished dignitaries on the dais, esteemed guests, colleagues, press and media, and ladies and gentlemen, good morning. On behalf of the organizing committee, I'm honored to express our heartfelt gratitude to all those who have contributed to the success of this momentous event. Firstly, I would like to express our heartfelt gratitude to Honorable Minister of State, Ministry of Earth Sciences, for gracing this conclave as a chief guest despite his demanding schedule. Sir, your remarks in highlighting the lessons we have learned over the years, as well as the ongoing initiatives to strengthen our early warning system, serve as a great source of inspiration to all of us. Sir, we are grateful to you for launching 2 crucial new products that significantly enhance our services. I sincerely thank Dr. Ravichandran, Secretary, Ministry of Earth Sciences, for his visionary leadership and guidance in advancing our services. Sir, we are deeply grateful for your unstinted support to INCOIS, which has been instrumental in enhancing quality and impact of our services, particularly in multi-hazard scenario. I take this opportunity to acknowledge the architects of the Indian Tsunami Early Warning System, whose foresight and leadership laid the foundation to build a robust system that we rely on today. On this special occasion, we express our profound gratitude to former Secretaries, Ministry of Earth Sciences, Dr. Harsh Gupta, Dr. P.S. Goyel, Dr. Shailesh Nayak. Their contributions have not only helped the nation to safeguard from the impending tsunamis, but have also inspired the other nations in the region to strengthen their tsunami disaster preparedness and response capabilities. Our heartfelt thanks to former directors of INCOIS, Dr. Radhakrishnan, Dr. Shanai, Dr. Srinivas Kumar, whose dedication and tireless efforts have ensured that INCOIS remains at the forefront of addressing science and technological challenges in tsunami early warning centers. We also owe our sincere gratitude to all collaborating institutions, organizations, whose partnerships have been crucial in the development of establishment of state-of-the-art Indian tsunami early warning system. These institutions include NCCR, NIOT, NCS, NRSC, SOI, NHO, NDMA, and SDMA. Special thanks goes to the Coast Guard, Indian Navy, and NDRF for their continued support and involvement, particularly in our operational exercises. We are also grateful to Mr. Vidar, Executive Secretary of IOC, for his insightful video message highlighting the IoTWMS initiatives, the challenges, and the way forward. I also thank Ms. Tijiana, Director UNESCAP, for joining us today to share UNESCAP initiatives in tsunami preparedness in this report. In this event. We are grateful to Dr. Kamalochan Mishra, Managing Director, OSDMA, and his colleagues as well as community leaders for joining this event and sharing their experience in developing tsunami-ready communities. Congratulations to all, and we are confident that OSDMA will serve as an exemplary model for the other coastal states to implement the tsunami-ready recognition program. I also thank the colleagues from NDMA, SDMA, and eyewitnesses for joining this event. Our special thanks goes to all our colleagues at the Ministry of Earth Sciences for their continued support in advancing tsunami early warning system and related program. I would also like to express my sincere gratitude to Balkrishnan Nair, Director, for his commitment to improve early warning services and for his invaluable support in guidance and the planning the execution of this conclave. A special mention goes to the dedicated colleagues of INCOIS, whose unwavering commitment over the years has ensured that no event has ever been overlooked and no false alarm has ever been issued. Last but certainly not the least, I would like to express my heartfelt gratitude to all my colleagues working behind the scenes for their exceptional support and dedication in successfully organizing this conclave. As we reflect on devastating tragedy of 2004 tsunami, the progress made in the tsunami early warning system, and the resilience built by the coastal communities, we are reminded of the emerging challenges. While we have made significant strides both upstream through S&T advancements and downstream through preparedness and response initiatives, much work remains to be done. Let us stay united in our efforts to ensure that the lessons learned will guide and strengthen our collective commitment to mitigate the tsunami disaster risk. Once again, thank you all for joining here. Thank you.
Ladies and gentlemen, now we will take a short tea break. Refreshments are arranged in the foyer of the auditorium. We will gather here back at the 12:15 to hear the reflections of our esteemed guest. Please rejoin us promptly on time to manage this time schedule. Thank you and enjoy the break. చేయలేదు ఇంకా చేయలేదు. Welcome back. Sir, we will now proceed to the session, Reflections on National and Regional Tsunami Warning System, chaired by Dr. Shailesh Nayak. I request Dr. Shailesh Nayak, Ms. Tijiana Boniface, Dr. S.C. Shenoy, Dr. Srinivasa Kumar, Dr. Radhakrishnan to kindly take their seats on dais. Yes, sir. Yes, yes. I now invite Dr. Shailesh Nayak, Director of UNEAS, former Secretary of Ministry of Earth Sciences, and former Director of INCOIS, to deliver his presentation titled Building from Scratch, the Tsunami Warning System.
It's becoming a little problem for me. Good afternoon to everybody. It's a real pleasure to stand before you and talk about the tsunami warning system. I'm not going to talk about the technical aspects of the tsunami warning system. Many of you must have seen and be experiencing about how useful it is. So what I thought is I will talk about the lessons we learned from the tsunami warning system. And the most important thing was, when nothing is known, how do you move forward in a project? So that's why I have given a title, Building from Scratch. Many in the morning has said that we were not knowing what is tsunami or what it does and all that. So let's see. Now this is the picture on December 26, Marina Beach. It's something which is, we have never experienced. The kind of water, the tsunami wave which came and created devastation. Now, this happened because of the very huge earthquake, 9.2, many of you all know. But the most important thing, it was lasted for 10 minutes. It was one of the longest time when any earthquake, and that is the main reason for the damage which it done. It displays about 20 cubic kilometer of water. You can't imagine the kind of water it displaced. And of course, the lot of death, the damage was 10 billion. But why this happened? Because our knowledge was not sufficient about what is tsunami, how it propagates, what it likely impact. There is no tsunami warning system anywhere in Indian Ocean. And because we were not seeing, there was no preparedness on the government side or the people side. So this is the scenario. And what was the response? The government of India announced that they will be setting up the tsunami warning system, and the interim warning was set up in INCOIS. Similarly, from the support from Germany, and the Indonesia set up its station, and Australia from the support from US. They also decided that we will be setting up the stations. But the most important thing, the IOC under UNESCO came up with an idea that we will be having Indian Ocean tsunami warning system. This was completely different concept at that time than the Pacific tsunami warning system. Though the Japan and US both were giving, there was no harmony between those bulletins or anything. It was acting as two separate centers. So this system was envisaged as a system of all national systems. So all the countries came together to have the agreement that we will all receive the tsunami warning system. And meanwhile, the Pacific Tsunami Warning System was giving support to this Indian Ocean as well. So under this condition, when we started thinking about tsunami warning system, the most important thing, what is our goal? So the goal, we know that Andaman, it takes only 20 minutes. So we should be able to do within 10 minutes. And this was, at that particular time, looked as if it is just not possible. Then we thought that what we should have, one, of course, we should be able to forecast the tsunami. We should also set up the response to this forecast, and of course, the capacity building, as well as the community awareness. But the most challenging task which was set, probably first time in the government of India, was that the warning center should be ready by 15 October 2007. I don't think any time this kind of a target is given. But this helped us because we could set very challenging tasks and which could bring out the best from the team. Also, when you set up such a goal, which will ensure that you have a leadership position in the Indian Ocean. So these are the two main things came up. Now, when we tried to identify what are the different tasks, it was realized that it's a quite complex task. So we thought that all the institutes which has the expertise in the particular task should be bring together. Of course, Dr. Goyel said the INCOIS was managing the entire project and the coordination. Now, the identification of tsunami-genic zones itself, the one task, but the more important was the seismic station. One of the major issues which we had at that time, that IMD has suggested they will set up 17 stations on Indian. Now, as you know, that if you want to identify tsunami earthquakes, you need stations which are surrounding that particular zone, not on the one side. So this was sorted out by having the support of IOC and the international seismic stations data we started receiving. The second, which was not to have a false warning, so you need to monitor the water levels and tide stations and the bottom pressure recorders. Survey of India had tide stations, but there was no system of real-time receiving. So INCOIS said they will set up this kind of a system. So INCOIS took over tidal stables and they set it up that system. The bottom pressure recorders, initially we imported, but of course later on the NIOT indigenized that. And there also the support of ISRO was very critical because Dr. Goyel knows that they use pressure sensor for the launch vehicle. And those were modified to be used in the bottom pressure recorders. The communication system, because we realized that Inmarsat, which was supposed to provide the data, didn't work for the seal bottom pressure recorders. Because when the data starts coming every minute, there was a complete breakdown because it was not able to process data that fast. So we went to the inset system. Then, of course, the computation of various parameters. And this is one of the most important thing which happened. There was no real-time seismology at that time in the country. The real-time seismology came by INCOIS to set up the whole system, how to process data within 10 minutes. That was the major task. And some of my colleagues here did a fantastic job, Sunanda, Srinivas, and Ajay, and I think a few more. So this was the first time we could provide the real-time data. The models need very high-resolution bathymetry and topography, which with Dr. Raman Murthy and, of course, NRSC. Now NRSC is that time NRSA. We did high resolution topographic data. And the most important was that we realized that this can happen anytime, so you needed completely automated system, so you need to build decision support system. And there we took support of the industry because your codes have to be written in such a way it doesn't fail, and I understand till today it never failed. So this way, we tried to bring all the expertise available and identified and empowered them to do particular tasks. Now, the team building was one of the very critical aspects. It's variety of topics. I'm not going to read all that. But we had 17 young people, which all these aspects, geophysics, geology, communication, electronics, civil mechanics, and computer science, they were very young, fresh, who came to INCOIS at that time, apart from the other institutes which are involved. Now, this team was motivated to work on a shared vision, that what is the total vision, and this was achieved. The most important thing which we did for each team, that the complete authority was given to them to work, but the responsibility of delivering still remained with the project leader. So this distinction was made for the first time, that the authority given, but the responsibility was still of whether anything goes wrong, the responsibility will remain with the project leader. This, of course, I learned from Professor Dhawan, and very famous example with Professor Dhawan in Kalam. That's what we intimated. So we motivated the team to innovate and find solutions. Now, since it was such a vast and a lot of international collaboration was one of the most important things. And of course, the Intergovernmental Coordination Group, IGC, IOTWS, India participated very actively. But more important thing which they did, apart from these few things which I mentioned, that how the indicator, what are the performance which you will find with the indicators. The first time coastal forecast zone concept came and was done through this IGC. Earlier, the warning which was given by US, and it was basin-wide warning, not the specific every 50 kilometers. This concept came under discussion with IGC. So INCOIS started giving forecast of 1,800 forecast points, not one or two. Of course, the standardization of bulletins, the communication test, the drills, the workshops, all this happened under the IGC, which was extremely useful. And the one which is the another TOWSW, other hazards, there was a global harmonization also planned at the same time. So the international collaboration was very critical. Of course, this is the standard operating process which was done so there is no mistake. And the bulletin, some of the earliest bulletin you can see, and we used to write how much time it took. This was done within 6 minutes. So this is the kind of level of preparation which was done, which include many other things. I'm putting it very simply, but it involved where the earthquake has occurred, processing the earthquake information, finding out the magnitude, and then also communicate this information to all the countries. This all happened within 6 minutes. This is something, a great achievement. And this bulletin gets generated automatically without any manual intervention. After second bulletin, the experts come and then they do it. And these were the performance indicator which was set by the IGC after a lot of discussion that these are the things which we should be doing. And you can see that INCOIS started performing extremely well as far as the earthquake parameters were concerned. Initially, of course, the standard was that we should be able to compare with USGS, which is considered the gold standard. But then INCOIS started doing much better than even USGS. The model also performed extremely well. This happened in 12th September 2007. And we got a lot of confidence in our models that the estimated arrival and estimated water level matched pretty well. You can see for Port Blair and Chennai, it is quite close to the actuals. Also the bottom pressure recorders. So everywhere the performance was pretty good. And the real test came in 2012 when 2 earthquakes happened, which never thought when the system was designed. It was 8.5 earthquake, and we were going. Meanwhile, another earthquake took place. The same, more or less, same region, but the system performed extremely well. And you can see that during such a complex situation, how the other system performed. You can see that INCOIs gave very specific warnings for a specific areas. PTWC and JMA gave very warning which was very basin-wide. So this proved that this system is very robust and performed some of the situation which was not envisaged. Of course, the excellent work done on the workshops by building the capacity, tsunami ready, I'm sure that there will be much more discussion on that. But the mock drills, we learned many things. We found that the most states on the East Coast are more responsive to any information given compared to the West Coast. The reason was their experience, because East Coast is mostly cyclones and all there, so they are more prepared to respond compared to the West Coast, where at that time, the cyclones were also very rare. But now, of course, situation has changed. Now, a lot of innovation done during this period. One, of course, is the near real-time detection of earthquake parameters. This is, I think, the most important contribution of the tsunami warning system. Near-time analysis of tides and sea level. The tides were never analyzed in real time before that. Creating a large database, Dr. Ravi mentioned that we created a model database. But to create this database of 15 terabytes in 2007, when each model run used to take 90 minutes, it is impossible to create 50,000 scenarios and put it in a system, in a database which you can detect within a short time. So there was a lot of innovation done. I don't have time to explain all this, but this was done. And 15 terabytes data was handled in 2007 with a very nominal kind of a workstations. We talk a lot about Internet of Things now. It was done in 2007 when all machines used to talk machine. There was no human intervention. Analysis, everything was done accordingly. The decision support system, which is extremely good, and I must compliment the support provided by NRSC and the TCS. Almost 40 people worked for more than 15 months to build this complete coding and decision support system. And that is why it has never, everybody has said that no false warning till date. This is the main reason. So as we inaugurated this on 15 October 2007, though we were ready on September 12, 2007. The first time we tested the system, and the 15 October 2007, we were the first to declare the system ready in 2007. Of course, the original system came much later in 2013, but we were ready to provide and providing the services to all countries in the Indian Ocean. So what are the lessons we leave? The one is we have to ignite the passion. There were a lot of passionate young people here in INCOIS at that time. And I have a lot of trust. They found a solution to very tough problems. And some of them were such that there were issues about the seismic parameters. Even in German scientists, they all come here and we had a lot of discussion. and we could resolve. So there were a lot of issues, but these are all solved. Other thing I learned was you have to trust your team. You have to put a faith in them, and they will deliver. We took a lot of risk. A lot of risk we took. At the end, everything worked, so it looks very good. But we realized that if you don't take a risk, you can't innovate. If somebody has done and you want to follow, then there is nothing. So, but you have to take the risk based on your knowledge. You have to be firm. There were a lot of issues. Dr. Goyel mentioned within the institutes and all. But, we took very firm decision, even if somebody personally unhappy, happy. But for the system, I think we have to do this. And of course, the firmness and conflict, these are two related. There are a lot of conflicts within each. But I think the important thing is that the decisions which were taken with a clear consciousness. And I think that is why we were successful. And the persistence, that is something which we have decided, we went ahead with it. There was no need to keep on changing your decisions because somebody has said something or somebody else. So overall success which you see is a small thing which large number of team members which you provided. That is why this was a great success. And both prime ministers, Mr. Manmohan Singh and the Narendra Modi ji, both at appropriate time, they said, the one thing which Dr. Manmohan Singh said is that this has established our leadership in Indian Ocean region, which was the goal, as I told you, we have set up. And Modi ji said during disaster reduction that this regional, because actual IOC came in 2013 only, but so these two were the major appreciation coming from the Prime Minister, I think is a great recognition which INCOIS got. But that's not the over. This was the excellent performance, no doubt about it. But then INCOIS has to become eminent. It also has to build the high performance organization which you see today. This success led to a very high performance because all other groups wanted to excel as the same as the tsunami warning system. And that became a very important thing. And the Encyclopedia of Solid Earth Geophysics, the Tsunami Watch and Warning Centers chapter is written primarily by INCOIS. So this is, I think, the global recognition came to this. Of course, there are many challenges. We had discussed about the landslides, and I was very happy to see volcano is already been done. Near-field tsunami is another area which we need to do. The underestimation of a magnitude, which is now we are trying with the GPS, and there are other methods, the sound and all this being thought of. But I think the most important thing is the understanding the fault mechanism. I think we still need to do a lot of work on that, and the subduction zone research. I think these are the two main things which we need a handle on. And this improvement has been done. Already I have to add the volcano thing also in this recent improvement. And overall today, if you see, it is not only Indian Ocean, but also for South China Sea, INCOIS can give a tsunami warning. So basically what I would like to say, that forecasting and providing advisory is a one very important thing, but that is not only thing which can mitigate the risk. We need supporting social system, that means political environment, the infrastructure, industrial structures, all that are required to make this happen. And the local administration ability to respond, which is very important actually. Very happy that you are here. Some of the best response system which we have seen in our mock drills is from Tamil Nadu. So this is, I think, very important for the local administration But the important thing is that if we continue to build this kind of a system, we also need an education system where you prepare this kind of a managers and leaders. And I think that is why the training centers which has come up here is one very major contribution, that you build the capacity in the country, in the region to achieve this. So this is what I think is most important. Thank you very much for this opportunity. Thank you.
The next presentation, Professor Harsh K. Gupta, member, Atomic Energy Regulatory Board and former Secretary, Ministry of Earth Sciences, couldn't join us today, but we are grateful to him for providing his video recording. I request our IT team to play this.
Claimed over 250,000 lives in South and South Asia. And there were unprecedented financial loss. At that time, tsunamis were not commonly known in India. You see, 26th December was a Sunday. People were walking on the Marina Beach in Chennai around 9 o'clock in the morning, and they saw the sea receding. And people unaware of anything, they went into the opened up sea to pick up shells and fish without realizing that a big wave is going to come and they are going to suffer. And this is exactly what happened. That was a time that there was no tsunami warning system available for the Indian Ocean. When you come to the Indian Ocean, there are only two regions. The region stretching from Java, Sumatra to Andaman Nicobar, a stretch of 4,000 kilometers, and a small area of about 1,000 kilometer diameter in Arabian Sea off Makran coast, which can host tsunami-genic earthquake. Our process, and one thing which we did, you see, once a earthquake occurs, it is located within 2 or 3 minutes time very well. Whether it has generated a tsunami is not known till the tsunami reaches a tide gauge or any other measuring device. And that may take a long time. So to overcome that problem, we planted ocean bottom pressure recorders in the immediate vicinity of these two tsunami zones. So that gave us a capability of knowing whether an earthquake which has occurred, which is large enough to create a tsunami, has indeed generated or not. So this has been working beautifully, and it was a very major program which we completed by 12th September of 2007. And there was an earthquake on that day of magnitude 8.4, which occurred very close to the 2004 Sumatra earthquake, and there was all the chances of a tsunami to be generated. And NCOIS gave an advisory, and I'm showing only a part of the advisory, which shows that at Padang, the estimated time of arrival and when it came, Cocos Islands. So this advisory was given for the entire Indian Ocean Rim countries, and we found it to be quite true. So over the years, this system has worked beautifully. It has worked very well since 2007. And in these 17 years, there have been more than 700 earthquakes, which could have generated tsunamis. But only 7 of these earthquakes were found capable of generating tsunamis. And out of these 7 also, there was only 1 earthquake which really required a issue of advisory. So I must say it is very timely and accurate advisories given by ITEWs have saved the entire Indian Ocean Rim countries from false alarms and subsequent evacuation, as had been the case before the installation of Indian Tsunami Early Warning System. In true sense, ITEWs has served the purpose of its creation. And I must say that India completed indigenously a very ambitious project to set up a state-of-the-art tsunami warning capability for the entire Indian Ocean, warning in a short time of 30 months. This was achieved by the end of August 2007, and tested by the 12th September 2000 earthquake of magnitude 8.4. Over the last 17 years, the system has worked very efficiently. It is now assessed among the best in the world. With outstanding contributions over the years, INCOIS is identified as one of the key tsunami service providers for the Indian Ocean Warning and Mitigation System, IOTWMS. The credit goes to Ministry of Earth Sciences, particularly INCOIS, for this extraordinary achievement. And I would also like to put on record the continuously good work done by INCOIS. Thank you very much for your patience.
Dr. K. Radhakrishnan, Honorary Distinguished Advisor and former Secretary, Department of Space, former Director in COIS, also couldn't join us today, but we are having his video. I request our team to play this.
It was 20 years ago, on a calm Sunday after Christmas. Tsunami hurled the Indian Ocean, and that day became a fateful day for the entire humanity of the Indian Ocean region. That is a maiden experience of an academic jargon, tsunami. We had handled that. We, the novices at the nascent INCOIS, had fire in our belly to be useful for the nation. We had the urge to learn and be of use for the humanity. We stopped everything and started learning about, understanding tsunami. And we had a pole star in Delhi, Dr. Harsha Gupta, a globally renowned seismologist and the Secretary of the Department of Ocean Development. He guided us. Within a fortnight, we were able to get the entire scientific community, all the science departments of the country aligned to this thought process that in India we should develop a tsunami early warning system. The rest is history. By the third week of January, India was able to present in the World Conference on Disaster Reduction at Kobe a proposal for tsunami warning system, not only for India, but for the entire region. Those involved in this activity in the Pacific said, your system will work. And all the major nations in this region rallied around this proposal. And the government of India supported us. The government of India declared that tsunami warning system is going to be handled by the Department of Ocean Development at INCOIS. And the India Meteorology Department graciously agreed to put a real-time seismic network station at INCOIS. And today, we have a world-class system which is useful for the entire region. Dr. Harsha Gupta signed off in 2005 from the department. And then came a new leader, Dr. P.S. Goyel. I was the first project director. I moved back into ISRO a few months later. And then came Dr. Shailesh Nayak. This leadership was a seamless transition. and they did it. Kudos to them for meeting the timeline that was promised and doing the system at the cost that was promised and making it a vibrant system working for the whole country and for the whole region. The bubbling youngsters of those days, Dr. Ravichandran, Dr. Srinivas Kumar, Dr. Balakrishnan Nayak, Dr. Patabhi, Uday Kumar, Nagaraja, all are in defining positions at different levels nationally, internationally. Thanks to all of them. And thanks to Dr. Satish Shenoy, who sustained the entire effort over a decade. Thank you very much for this satisfying moment. God bless you for the good work that you are doing for the purpose of humanity. And you proved that if an organization has to exist, it must make a difference. And you have made it. Thank you.
I now invite Ms. Tiziana Bonapes, Director, ICT and Disaster Risk Reduction, the United Nations Economic and Social Commission for Asia and the Pacific, to share her thoughts.
I can give in the afternoon. Okay. I'll talk about lessons learned now.
Okay.
Okay.
5 minutes.
Okay. Okay, so Honorable Minister Jitendra Singh, Dr. Ravichandra, Secretary, MOES, Dr. Bala Nair, Dr. Srinivas Kumar, Dr. Nayak, and all colleagues and friends. It is a real honor and privilege for me to join you today. And I'd like to extend a very warm appreciation and thanks for having invited ESCAP to be represented here today. So I have 2 interventions today. So I think in the morning session I will talk a little bit more about lessons learned. And then I'll say a little bit about the strategic direction that ESCAP plans to go into. And then in the afternoon, I will present a little bit more about the Tsunami Climate and Disaster Preparedness Trust Fund that ESCAP operates. I think we are really here today. It's a solemn occasion because we are commemorating the 20th anniversary of 235,000 people who lost their lives. But we are also celebrating 20 years of achievement. And I think there's a lot to celebrate when we look back to where we started. But it's not enough to celebrate. We also need to think forward. We need to be prepared for more to come. And unfortunately, what happened in the past is probably not a good enough guide on what is going to happen in the future. And this is a little bit the story of disasters. Disasters are on the increase in frequency. They are more intensive, as we all know, and a seismic tsunami in the Indian Ocean is probably not a good enough guide for what's going to happen in the future. And I very much share the views of Dr. Nayak earlier. The non-seismic tsunamis, the Andaman Plate, the Makran subduction region. These are all flashpoints that are likely to be the next hotspots and where our attention should be focused. We may be wrong, but as far as we can tell from the data, this is where we are more likely to need to focus our energies. So I think then the second lesson is a lesson of sustainability. After a disaster, there's a great outpouring of grief, of human solidarity, a great outpouring of financial contributions by governments, by private sector, by philanthropic organizations, and then slowly but surely, people tend to forget. These are expensive systems to set up. I think time and again they have been shown to be vulnerable to vandalism, to various forms of operational malfunctions. And so sustainability, continuing to invest in the systems. And because they are expensive, that's when the multi-hazard approach becomes important. Using the same system for multiple purposes can then increase the cost effectiveness of the investments. Then I think a third point is that disasters know no borders. And so inter-country collaboration is crucial for cost effectiveness and for maximizing benefits. And this is where the UN steps into the picture. UNESCAP is a regional intergovernmental commission. UNESCO IOC is an intergovernmental oceanic commission. We work across borders, we work across boundaries. And it's not only, well, the inner circle of cooperation has to be among the countries that share the common borders, that are geographically contiguous to each other. But as the Indian Ocean tsunami showed us, all countries were affected. The second highest death toll was among Swedish tourists. So Sweden, close to the North Pole, had the highest second death toll in the Indian Ocean, given the large number of tourists that were there on 26 December 2024. So international cooperation is key. And then there I would put in a pitch for UNESCAP. I wear an UNESCAP hat, so I have to defend my organization. We're an intergovernmental organization. And so being an intergovernmental organization, we set the norms at the intergovernmental level, so almost at the legislative level, if you want. And then that is very useful for countries to anchor their national processes. So anchoring national processes, planning process, policy planning processes to norms and standards that have been developed at the regional level and that are developed by my good friend Dr. Kumar from IOC, UNESCO. So I think it was Dr. Nayak, if I'm not mistaken, this morning, who said, who talked a little bit about the difficulty of converting concept notes to cabinet notes, to legislation. International norms, UN-supported norms and guidelines and practices can lend, I think, the credibility, can also promote the good policy making and the good partnerships. So maybe I will leave it at this. I guess my 5 minutes are over. I was going to say a few more things about strategic direction, but I got caught up in lessons learned. I will come back to strategic direction of our work in the afternoon. Thank you.
Thank you, Tijiana. I now invite Dr. S.S. Shanai, Minister of Earth Sciences Chair Professor and former Director in COES.
A very good morning to all the dignitaries on the dais and off the dais. And it's a privilege to be part of this conclave, which is basically reflecting on what happened 20 years back, and be part of inquiries which developed the tsunami early warning system. When we look back 20 years back, not only many of us, none of us knew what is tsunami. In spite of being a physical oceanography student, just a small short note, that's all it was to be attended in the exams, and we studied only that much. And tsunami is a harbor wave, and we left it to the Japanese and the Pacific Ocean. And we are 100% sure that such an event will not occur in our Indian Ocean region. So when this tsunami occurred on 26th December 2004, I was not watching the TV. Then one of my colleagues called me and asked me first to switch on your TV. And he asked, if I ask you, a tsunami has struck the Indian coast, what would be your reaction? I told, are you kidding? How tsunami can struck our coast? So this is the kind of situation. But today, tsunami has become a household term. Every child knows what is tsunami. Even politicians use tsunami of our party. Modi ka tsunami aata hai. This is what we use. So now the tsunami is, we need not tell anyone else. Because this session is to reflect on, first thing comes to my mind is, as Dr. Nayak as well as Dr. Ravichandran and previous speakers told, it was decided that a tsunami warning system has to be established by India and in India. And I really appreciate the leadership that time, including Dr. Nayak, Gupta, Dr. Radhakrishnan, and whoever it was involved, because I was not involved at that time. I was a scientist at NIO Goa. This all happened previous to my joining. I think it was a wonderful decision not to mimic something, or I was told that because only 2 tsunami early warning centers were existing at that time. One was Pacific Tsunami Early Warning Center in Hawaii, and the other one was JMA in Japan. So if we had accepted that, I think now we would have, nobody would have appreciated us. We would have been laughing stocks, because the existing practice was to depend on the earthquake magnitude and give a ocean-wide tsunami or whatever it is. And if we had done that, today I don't think any of inquiries person could have walked in the street with his head high, because in our condition, if we give one false alarm, next time nobody will believe that. So this idea emerged that it should be more of location-specific tsunami warning, and of course IOC chipped in and decided to build a tsunami early warning system for the entire Indian Ocean, and many countries came forward. And this idea emerged. But what we could do, I think we should be proud of that. We could implement that idea on the system and demonstrate that to the IOC as well as other countries that yes, we could do this and we can provide the location-specific tsunami early warnings. Now, almost at the district level or a 50-kilometer resolution coastal forecast points, we are able to provide arrival time as well as the expected wave height. Not only that, we have now the LTM data which has been collected by INCOIS with the help of NRSC, and we are able to provide the information to the disaster management agencies, how far the tsunami inundation will take place and what will be the level of inundation as well. I think all that helped because one incident always live in my mind because I was a director at that time here. On 11th April 2012, there was a large earthquake which Dr. Nayak also mentioned that it was 8.6 magnitude earthquake, almost a similar location of 2004 earthquake, and it was a very high potential. And when all other centers and all international media was flashing the messages that Indian Ocean-wide tsunami is predicted and blah, blah, all these things, we put only 3 islands in the southern Nicobar Islands as the tsunami warning, and the entire east coast and the rest of the Andaman Nicobar Islands we kept under tsunami watch. Of course, this made everyone so tense, from the Home Secretary in Delhi to Tamil Nadu Chief Secretary and everyone. And phone calls are pouring every 10 minutes or 15 minutes. How you can say this because when all others are doing this, the messages are like this. So we checked our calculation, the model results, whatever it is, and luckily we could also get the observations, sea level observations, and build that confidence. So the message is that with great risk and confidence, the earlier leadership decided to build a tsunami warning center of our requirement rather than asking somebody to provide that. And second, when we do the things, we should have that confidence. I think that confidence, if we have what today's Prime Minister says, Atmanirbharta, that is not a difficult thing. And in fact, actually, INCOIS has demonstrated that we can be Atmanirbhar provided we have that confidence. And we are going much ahead. The things are, so far we have not issued any false warning, and it is being improved. Today I saw that the SOPs have been developed for non-seismic tsunami when like volcanoes, tsunamis due to volcanoes. Of course, there are a few other issues like Dr. Nayak has listed out. I'm sure that in the coming years, we will be able to develop the techniques and procedures for them as well. So with this, let me wish INCOIS, and when I was working, I used to say that when we go out of the institute, every day we should be proud of telling that I worked in that institute. At least I can say that, and I am saying that in every forum that I worked in INCOIS, and that should be kept alive by the coming generations. I wish you all the best, and looking forward for more and more progress in every sector which INCOIS is venturing. Thank you very much.
I now invite Dr. T. Srinivasa Kumar, Head ICG IoT WMS, Secretariat of IOC UNESCO, and former Director of INCOIS, to share his thoughts.
Thank you, Sunanda. Secretary Dr. Ravichandran, Dr. Sailesh Nayak, Dr. Shenoy, Dr. Radhakrishnan, and my colleague Tiziana. And all colleagues and friends in the audience. So it's really difficult to, speak and not to repeat any points, especially when you're towards the end of the session and so many, important people who have actually been involved in development of this system have already spoken. But I'll try to actually be brief, but then try to mention some things in that milestones, different milestones of a journey that has actually brought us here since the 2004 tsunami. And one of the rare privileges me as an individual, as a scientist working at INCOIS had, is actually being involved with more or less my entire career at INCOIS, being involved with the development and then contributing to the establishment of the tsunami early warning system. And then also I've had the privilege of actually being nominated by the directors, the former directors of INCOIS and the government of India to represent the country in some of those international kind of collaborative activities which were actually happening as part of the UNESCO IOC, when this dreadful tsunami happened. So that was a great privilege and opportunity I've had. And in 2004, when this tsunami actually happened, since this session is on the reflections, I thought I'd actually, put some personal touch to, where I was at that time. So that was again the morning of, the Sunday on 26th, and then I was actually in Kochi. I was undergoing a training of the Nippon Foundation POGO training program on ocean color remote sensing in Kochi. And then, we have started seeing these reports on the TV, which others also mentioned, with the water receding and then the, wave already hitting Marina Beach and so on. And then all of us wondering in this training, this was an international training, and all of us wondering, is this really even possible? Because, we never thought such an event could really strike, Indian Ocean or the Indian shores for that matter. And then suddenly we receive a call. I received a call from the director saying, okay, enough of your training, now actually get back to INCOIS. And then in the next couple of days, I was back at INCOIS, huddled together with all the other colleagues, Dr. Ravichandran, Bala, Patabi, and Satya, and all the people, here, huddling together with Dr. Radhakrishnan, who spoke before, who has been asked by the Secretary of the Department of Ocean Development at that time, Dr. Gupta, to come up with a proposal. And then he has actually spoken to all the directors of all the institutions, Secretary, and then NIOT, and then all the institutions were working together and putting up a proposal, which had to be submitted to the government, like not that day, yesterday. That means that was the kind of urgency, because it was so many lives lost, and then it was so, devastating. Everybody wanted to do something about it, actually. And then, so this team of young scientists sitting together, a proposal was made, which was actually presented to Professor Gupta then. And then we have actually then decided, on the international front, parallelly, I'll try to explain what was happening. The UN has actually given at the same time mandate to the UNESCO IOC to collaborate, coordinate with the countries in the region, and then to set up a regional warning system, while the countries themselves were working on their national systems within the region. And again, those meetings were attended in Kobe, then the next one was in Paris, then Phuket and Mauritius. All of these meetings happening within a very short span of time. I'm sure Tiziana is aware of these meetings which happened in the beginning. Dr. Sailesh Nayak, and then all of them were part of those initial meetings. When it was decided, the proposal that, the Indian Ocean will be subject to tsunamis from only two sources, unlike the Pacific, which has the Pacific Ring of Fire. I think that kind of idea was put forward and accepted, globally by all the seismologists and scientists who were working on. I think that was actually kind of a game changer, in the sense that that provided a basis for us to technically design the system in a way that it could detect tsunamis from these two sources. You don't need to put sensors everywhere, seismometers everywhere. You don't need to put bottom pressure recorders everywhere. So that was a source that was known, of course, and then the seismic system that is operating today is actually built around that basis, I think, which I would say is a major contribution from the Indian kind of scientists to there. And then immediately proceed after that, an interim tsunami warning system was set up at INCOIS in this same building in a small room upstairs, 2 or 3 computers which could connect to some global, USGS and so on and so forth, and get this information. And then we have started working on the real-time, processing, which Dr. Nayak has also mentioned, on a CISCOM kind of a system, the preliminary system. And then at the same time, interim advisory services, JMA and PTWC, were identified for the region. So the progress was after that pretty kind of fast in the Indian system, I would say. Then Dr. Nayak was actually our director, and then we started working on the real-time seismic monitoring system by the IMD, on the tsunami buoys, by the NIOT, modeling part, which again Dr. Nayak mentioned, on the, by the CMLRE at that, ICMAM at that time, which is NCCR, then ISRO working on the communications. It was kind of rapid progress. And then the idea, the technical design of the system was itself was very unique. Like Dr. Ravichandran mentioned today morning, why or how we actually, managed not to give kind of, false alarms. So that was actually built around those decision support tools, the standard operational procedures, the warning detection systems, the modeling systems, they are actually very, the modeling process, the idea of modeling pre-run scenarios itself is very unique. And then putting all of that into a decision support system that can mimic, the knowledge of scientists and then give out a warning. So that was kind of very unique. And then, so that was something which was set up. And then globally, again, the way the things were moving was actually, how can we actually learn from systems that are operating, or countries that are setting up these things like India, Australia, and Indonesia, were other countries, and then how can we actually, learn best practices and then make it, a kind of a global system. So Northeast Atlantic, Mediterranean, Caribbean, PTWS were all being set up, and then the global service definition document was built, what was based on what was happening in the Indian Ocean region. So it was a kind of, nationally what things were going on, internationally what things were going on, and then cross-fertilization of ideas, learning from each other, and then trying to build a system that actually can, that can provide warnings to the whole humanity. So all of these, I think, has been great progress. Then, you have heard from others how things have, improved from there. Now, actually, in the Indian warning system, recently there has been several progress moving towards multi-hazard warnings, not any longer only tsunami warnings, CAP protocols, and then community preparedness and awareness, all of this going hand in hand, and then coming up with, the synopsis and then what all you have seen today. And on the regional front, again, there is a lot of, discussion now around something called the Ocean Decade Tsunami Program, which I'll be presenting later today, which actually talks about how you can improve the accuracies of your warning, timeliness of your warnings to actually detect non-seismic events and very complex source events, and then also make sure that 100% of the communities which are vulnerable to tsunamis are prepared and ready to respond. So I think a lot of amount of work is going on. 20 years down the line from 2004, we have made huge progress, but what we need to really remember, bear it at the back of our mind, like others spoke before me, is actually the nature of this hazard is so uncertain. Nature always throws new challenges to us, to all of us as scientists, administrators, practitioners. So we need to actually keep this at the back of our mind, and then make sure our research efforts, our development efforts, detection, what are the new sensors that you could use. Dr. Ravi was mentioning about AI, ML, whether you can use some of these new techniques into improving our systems. So all of these things, there is a huge conversation going on currently in India as well as in the international community globally. So I think this is something we need to continue to pursue and make sure that our warnings become, more accurate, less uncertain, and then are delivered in a way that are very people-centric. So I really thank you all for giving this opportunity, and then look forward to working with all of you.
So you have been hearing the reflections on the technical part of the 2004 tsunami. Now it would be a different perspective as we invite Dr. J. Radhakrishnan, IAS, Additional Chief Secretary, Tamil Nadu, to share his experience during this 2004 tsunami. Presentations
The videos is also there in the same folder, sir.
What's that?
The videos are in the same folder.
Okay.
If you want to go back, then we.
Good afternoon, everybody. Most respected Dr. M. Ravichandran sir, Dr. Shailesh Nayak sir, and all the distinguished panelists, whether those who addressed Harsh K. Gupta and Dr. K. Radhakrishnan sir, who addressed our thing, and Tiziana Vanpes, who addressed us now, and Dr. Shenoy and Dr. Srinivas Kumar. So my condition is like a 2020 match, last 5 balls. So before lunch, everybody is interested in lunch. And like he said, already everybody has spoken about technical thing. So first I will assure you that I will not show all the slides. I will keep it on record because it's a important thing that, just now people cover. Honorable Minister was mentioning 10,700 odd people died. So you must remember, because not many people remember. Even to me they ask, are you Kadalur collector? Or they will say, are you Kanchipuram collector? Many don't remember that 6,065 people died in only one spot. So that is the story. And the first few slides will show why this was so important. And how do you push this? This is then how? Which one? Yeah, come, just. Because battery is running low, na? The battery is low. So as I continue, what is the relevance of that tsunami? This one. See. Why inquest is relevant? That is the day when tsunami is coming, water has receded, and unfortunately in Kanyakumari you have all the people going towards water. So you can imagine that, that's the pace with which it is coming. It's not coming there. Huh? Okay, I think I to. Anyway, see, the relevance, of the video is not the video. That if it is Japan, people would have by that time made good their escape. Here people are going towards the sea, and they are not even aware that the tsunami is This Tamil word is Ullaporen, that I am just being dragged in. goes on. Next. No, regular presentation. I can. And then this one. This is the. So this is why we take these lessons as important. And how do you move it further? Next one.
Next slide you can put this.
Here. This is not. Next slide is not. See, now you can see the devastation. Why I just wanted this dramatic presentation is you should understand what is the. See, already Nagapattinam had these kind of serious disasters. Subsequently, also like our Shailesh Nayak ji mentioned, the kind of deaths which were happening. Subsequently, also cyclones are happening. Then again, if you look. What happens in disaster is previous October 2004, again it was flooded. So everybody was tired and totally beleaguered by the time tsunami came. Again cyclone Fanos came in October, November 2005. So why I am giving this field perspective, that is the kind of situation which we worked. And like all of them mentioned, if you see the time top, almost 2 hour time was there from the time it came. And like all these seniors have mentioned here, unknown to India, stealthy and ferocious, resulted in loss of life. If you ask them, if today inquest is there, if somebody tells, in very honestly, everybody, this 10,700 all have been alive. That is why inquest is important. So that is what I want you all to register. Remaining things, slides, I'll just be quickly going through. What is this slide we need not play. And
there is another mode, presentation mode or something.
So we can go to the next slide itself.
Okay. So this maybe.
See, the next video which was there was to show you the condition of the GH. Disaster happens, 10 minutes earthquake, so many waves. That time what do? You go to GH. And GH up to first floor, more than half water was there. That slide actually I'll leave the video for you to do. So, up to first floor, this is recording whatever I am saying. Unprecedented disaster. Okay. Then the biggest challenge was all roads were cut. We have had cyclones, we have had floods, but we never knew that, this was the first site. I was Tanjavur collector, I was sent to Nagapattinam, I reached at 12:30. By that time, almost lakhs of people are coming out of Nagapattinam. Velanganni is a very big church, 25th December, this was there. Then if you look at, this is a condition of the boats. So entire coastline, 187.9 habitation, 6,068 deaths, or this many people evacuated. I will not focus so much on relief. I leave it because, we had an initial response. The last line is that challenge of dignified disease management. There was large scale, chaotic thing. But this is a kind of bridges. Karaikal bridge had washed away. So Nagapattinam was only peculiar district which had Mailaduthurai, another thing away. In between Karaikal, this side, south of Nagapattinam. Now they have made a separate district. So how do we reach places? And this is the kind of road conditions immediately after tsunami. This not many people will show. But why I am showing is, you should realize this is the way bodies were piling up. You see the next condition. This is behind is my vehicle. So if you go there and people bring this body, many of them today, 20 years later, they speak so many things, but they never realize the scale of the tragedy which that day country witnessed. Again, this I will leave. This is the kind of, 100, 150. We say we are all prepared, but, 100, 150 odd people, 1,000 people each were there. So I'll quickly say, by third day, these are all, I'll just leave it. The only significant thing in Nagapattinam, before I come back to lessons learned, was we decided that every 7 villages will have a mini collectorate kind of thing. We'll give them physical and financial freedom. And like that, it was divided and we handled it. So obviously after that, I just don't want to waste much. Same thing, within 3-4 days, we started doing a very organized kind of disposal. Missing persons are digitally photographed, uploaded in a new website which was created. And it happened that, by 31st, we were able to restore basic thing. Initial turning point was we started making, foods were coming from outside, Kumbakonam, Tiruchi. We decided that let these people start cooking themselves, we'll support them. So that and restoration of education and all started. Second turning point, second is after this disaster, very easy to treat disaster as numbers. I request all of you that today, I have actually put out an open-ed article in Hindu center page, which has captured what happens. Very easy, after a disaster, how many people died, whether we have paid compensation, how many houses lost. That is not the issue. Then we had to do all this complex disaster management. This I'll just know how it was organized. I'll just quickly go through because that is the kind of scale which we did. This is literally we had used Akrapete is a panchayat with 3 square kilometers where 1,800 of these 6,065 bodies were there. It is just like from Banda Ache, if you look at Nagapattinam, if you see it is like a nose. South is covered by Sri Lanka. Sri Lankan east coast was affected. Directly Nagapattinam. Of course, Kadalur 620 deaths. Kanyakumari 826 deaths. But Nagapattinam 6,060 deaths was because of these kind of things. So this again, Army, Navy, all people had to do. Second important thing which I would like to record, I think some people would be seeing it live, some people here. In disaster, we should have a complementary approach. I should not look, he is a scientist, he is an NGO, I am government, I should get name. Here, so much of tragedy is there, so very effectively, this is the first time there is a formal government order. We gave NGOs presence in collectorate, 419 NGOs. Control was by NGOs. We used to participate in the meeting. So next I will say, medical, these are all, everybody knows. So again, most important is medical management is apart from emergency response, psychosocial support is a very important issue. I will come back to the lessons learned because it is more for inquiries oriented presentation. See, epidemic control, medical welfare support, animal welfare, sanitation, everything has to be done. Otherwise that becomes a secondary disaster. So again, UNESCO, I think you, madam is here, UNESCO and all, they came to us. So I said, what you want to do? Sir, we would like to check up the needs assessment. Please do it. Then they came back and said that these things have to be done. Who will do? We will do it. We said we would do it. So that kind of joint effort was needed to handle this. Then again, 6,065 bodies, can we wait in the queue in the mortuary? So we created new burial grounds. And we, from Gujarat earthquake, people who had worked came back and said that, we can cell rich decomposing agents are good because it was just, the water in Nagapattinam will come if you dig more than 1.5 feet. So that those kind of innovative things were done. Slowly we went back to temporary shelters because all people had lost house. And then special focus on vulnerable group is a very sensitive issue. Later it found roots. Suddenly we found young girls 14 to 18 without parents, they know the tragedy. Then young children, we found one girl below a bridge, nobody is claimed till today. She doesn't have any claimants, Meena. So like that, these are issues, then differently abled, widows, widowers, all were addressed. 1,251 orphan children, out of which around 100 had to be given. Social support, these all took place. And this all happened. I'll come back to the lessons learned. Again, when we come back with a recovery, one is relief, response, recovery. When we come back to recovery, that is the time the focus went on build back better, but more importantly, preparedness. Escape routes were not there. Every road was parallel, cut off, so nobody can come out. Now when you look at so many perpendicular roads are there, high-level bridges are there. So the disaster risk reduction became part and parcel of the thing. Various funding agencies you get, but for them we should have a sensible project. Again, people-oriented projects. I will tell back, multi-hazard resident homes, healthcare, newer hospitals came, livelihoods were lost. What we found is if he's a fisherman, he knows fishing. If he's a farmer, he knows farming. If he's a laborer, he knows laborer. So next suddenly when tsunami came, they became zero. So we decided to focus on alternative livelihood, proper planned housing, disaster-friendly, disaster-resistant housing, earthquake escape routes, then high-level bridges. Now the lower-level bridges has been removed. Fish landing center. Then again, so many shelter belt plantations. We found the weakest casuarina tree surviving tsunami. Some strong houses falling. So we have shelter belt plantation. Saving of sand dunes are there. Then in some very crucial area like Akarapete, where 2,000 people died, sea wall. This is not a good solution, sustainable solution, but like Pondicherry, this we did it. And I'll come back. I am not interested in my milestone and all. I am more interested in lessons learned. These are the 3 or 4 slides. Swift induction of resources. Many a times we hesitate to take search capacity. I am so happy that all the seniors are also here. So somebody who has contributed their contribution, like UN does it. I was working with UNDP for 3 years. There again, search capacity is there. They know list of people who can come in. Role of armed forces, now NDRF, that should be done. And corporate and industries should be made to participate. And we should continuously assess what are the requirements. Engagement of stakeholders, victim, this thing. Then adopt proven model, regularly update disaster preparedness at all levels, inspired by the Japanese model of efficiency and reliance. Institutionalize independent documentation. If I document myself, 99%, I don't do that. 99%, I'll say the greatest work. It was not great. If you look the slide, I leave back the slides, beginning chaotic. So much of problem is there. If I don't record for posterity, I'll be cheating people. I'll be cheating the souls who died. So independent documentation is more important than this. Government orders were quickly issued, attention to vulnerable people, and humanitarian aid should be based on local needs. Many times now everybody decides I have given my old cloth. They'll come even now and tell, sir, we sent a entire old cloths, nobody wanted. The fishermen did not want old cloths. They need immediately livelihood. They need agriculture, farmer needs scientific methods of removing sand dunes. So these kind of things are there. What subsequently happened was that we had the institutional within, just like I say, our Pradeep Jana sir used to be there in Orissa. Orissa brought in community-based disaster risk reduction to the management first. Bhuj earthquake brought Build Back Better. National disaster framework came after 2003 or 4, after earthquake. Then 2005, before the first tsunami anniversary, they quickly passed the DM Act. Though it had lot of improvement, even now they have amended it to make it more effective, but it institutionalized it. Otherwise, we are just response-centric. Nobody will invest in inquiries. Everybody will say, "Arey, kitna relief diya yaar, sabko de diya, band diya." That is not our goal. How to prevent it? Today, inquiries is going to save lives not only in India, in many other places and many other countries. It's going to be a basis. That time it was only Pacific Tsunami Warning Center, and they don't also have interagency coordination, how to communicate. So this has changed. If a tsunami happens, within 10 minutes, you are able to tell everybody. Finally, learning. Nagapattinam flood circum with minimal death. But 2004 tsunami, suddenness, ferocity, catching district administration by off guard was the issue. Here, I am very happy that, the robust early warning system, I'll take the next 3 more minutes I'll take. Robust early warning systems are very, very important. I'll tell the reason. And regular response mechanism, we are good. But unknown, unpredictable disasters, totally we are caught by surprise. That is why I'm complimenting you that you are talking about volcano, talking about underwater changes. Because tsunami means they'll say, "Arey yaar, udhar aayega, Karnivobar is my first early warning. Udhar tsunami aaya to I'll take care." That is not the way we should work. Today, an earthquake, tsunami can happen. Why? Localized tsunami can happen in a lake also, suddenly some big mountain falls. Leher, not many people say a big chunk of mountain falls. We talk of landslides. Should we not talk of leher? Disaster managers, stakeholders, we all should be made aware of everything. I am very honest, I did not know tsunami on the day. So these are the things. Iceland volcano eruption, uncontrollable oil spills, so many challenges are there. Potential future, the example like again here they mentioned, suddenly a meteor falls. That also we should plan. So these are the times when we should reflect on these things. DRM the future, but what we must face the reality. Many continue to live. Very easy to tell, ecosystem-based DRR I am following. Every disaster, all the development programs are with DRR we have incorporated. But somebody, because of economic reasons, wants to live in 2 kilometers by the coast. For him, early warning system is the only solution. That is why INCOIS or whether CWC for flood, they are very relevant, and we should know that the grassroots people are given distilled information, cutting edge level. With this, I will end saying that, Japan, which was so well prepared, March 11, 2011, earthquake happened. The earthquake always leads to fire accidents within the house and all in other places. Tsunami generated. Then on the other hand, Fukushima. So such a country so well prepared had to check. But we need to know that if you compare Haiti and Chile, similar countries, far severe earthquake in Chile during 2010, 700 people died. In Haiti, far lesser earthquake, 210,000 people died, 220,000 people died in tsunami. So why? Chile was much better prepared. So today country is much better prepared in every other thing, and we have actually way forward is practical sustainable plans and all. We are all doing so many things. Only thing is we should remember that we have a humanitarian approach, but preparedness just gets forgotten in non-disaster period. So this is the message. I am extremely grateful. This is the way that India, these are all a group of Sardaji who stayed for 1 month in Nagapattinam and cooked food, started with chapati and ended with idli. But that shows the compassion of people after disasters. Bill Clinton claim, appreciate the resilience of people. I feel good about what we have come. Then more importantly, Abdul Kalam ji, who is we call him as a people's president, he came and told the press. They suddenly asked that, collector, why you could not build 18,000 houses in 6 months? He said, stop. Collector will not answer, I will answer. This is a habitation redevelopment program. It is not a construction program. He stayed for 1.5 days. These are all things. This is where we owe to the people. This is 1 year after tsunami. A World Bank had taken picture on the same Akkarapeta where 1,800 of the 6,065 people died. This is the way they have come back, the resilience. And 6,065 souls have died. So it is the duty of all of us. We are very thankful that INCOIS has come forward and it has given state-of-art thing. And this is again the same old small Meena who is now about to get married on February 5th. They are symbols that they believe in the humanity, and it is our duty as disaster managers to ensure that we serve. I end by saying that today being tsunami anniversary, normally I would have gone to Nagapattinam. I went back 2 days back. I regularly go to Nagapattinam. But the moment INCOIS called, I know that the future and the future protection for the entire Indian Ocean is with them. So it will be more meaningful for me. I told Chief Secretary to go here, then spend time. I spent a lot of time, I spent regularly, but hats off to INCOIS for putting such a state of, I know how it developed and how it has become such a state-of-art thing, and hats off for organizing this commemorative meeting. I leave back my slides, videos and all for people, those who are academically oriented, and my mail is also there. You feel free, you can share it also. Thank you.
Thank you so much, sir. I think everybody has more with his presentation. Thank you so much for that. Now I invite a tsunami survivor, Mr. Kuldeep Singh from Andaman Nicobar Islands, to share his experience.
मंच पर उपस्थित सभी का नमस्कार, और सामने बैठे हुए सभी जितने लोग हैं सबको नमस्कार। इनके 26 दिसंबर 2004 को जब सुनामी आया था सुबह 6:30 बजे, यानी कि अंडमान निकोबार में उस समय ग्रेट निकोबार में कैम्बल वे में था। सुबह सुबह पूजा कर रहा था, उठकर पूजा करते में 6:30 बजे 6:30 बजे भूकंप आया। यानी कि भूकंप इतना जोर था कि वो सीधा खड़ा नहीं जा सकता था। तो वो यानी कि अपने जो टांग से दोनों टांगों को चौड़ा करके खड़ा होना पड़ा मुझको। यानी कि इस तरह से भूकंप आ रहा था, ऐसे ऐसे करके लगातार आ रहा था। उसके बाद बाहर निकल के खड़ा गया, पूजा रूम से बाहर निकल के खड़ा हो गया। तो बाहर निकल खड़ा हुआ तो रोड की तरफ देखता कि लिंक रोड की तरफ तो गाय जो आवारा गाय जो दूध नहीं देता था सब समुद्र किनारे में जाके बैठ जाता था। तो सुबह सुबह सब गाय एकदम जंगल की तरफ भाग के जा रहा है, पूरा गाय लाइन लगा के भाग रहा है। यानी कि इतना कि जानवर जो है, जानवरों को आदमियों से ज़्यादा सेंस है। वो हम लोगों को पता नहीं था कि सुनामी आने वाला है, वो गायों को सबको मालूम था, पहले से सब जंगल की तरफ भाग भाग के जा रहा था। और हम बाहर खड़े होकर देख रहा है कि एकदम सी सी का आवाज़ आ रहा है। तो पहले क्या गाड़ी आता था, गाड़ी का आवाज़ आता था रोड से, उस समय बिल्कुल पता नहीं, समझ नहीं आता कि आवाज़ क्या आ रहा। तो उस समय क्या हुआ था कि जब भूकंप आया तो सबसे पहली बात है कि सुनामी आता क्यों है, अभी तक कोई बताया नहीं। सुनामी आने का मेन कारण है जब समुंदर के अंदर ज्वालामुखी फटता है, यानी कि समुंदर के अंदर फटेगा तभी सुनामी आएगा। अगर ज़मीन के अंदर भूकंप आता, ज़मीन के अंदर आता तो सुनामी आने का कोई खतरा नहीं। समुंदर के अंदर ही जब फटेगा ज्वालामुखी और जिसकी जो मैग्नीट्यूड है 8 से ज़्यादा होगा तभी सुनामी आएगा। यानी कि 2004 में भी इंडोनेशिया में समुंदर के अंदर ज्वालामुखी फटा था और एक दरार फट के चेन्नई तक आ गया था। यानी कि कैम्बल में ग्रेट निकोबार और निकोबार के बीच में से जो दरार फट के चेन्नई तक आया, इसीलिए चेन्नई तक सुनामी आया। और फट के नहीं आता चेन्नई तक तो सुनामी चेन्नई में नहीं आता था, श्रीलंका तक नहीं पहुंचता था, अंडमान में रहता था। तो अंडमान में तो उस समय जब आया तो फिर रोड के किनारे यानी कि पूर्व की तरफ से 15 मीटर ऊंचा लहर उठा। तो हमें रोड से जाके लहर को देखा अच्छा से, यानी कि उसकी कि हमारा घर जो था रोड से इस तरफ था, तो लहर बड़ा 15 मीटर उठ के एकदम रोड का साथ साथ बह के चला गया। आगे वो साइड में एक झोंपड़ी था, उसको उठा के लेके जाके 1-2 किलोमीटर दूर फेंक दिया आदमी को। तो उसके बाद फिर दूसरा लहर उठा, वो भी उसी तरह से गया। तो वो एकदम जाके लहर को हम लोगों ने देखा, उसके बाद दिमाग में आया कि अगर ये लहर रोड क्रॉस करके हमारा घर आ गया तो हम लोग सब मारे जाएंगे। तो उसमें सब बच्चों को अपने जितने से सबको लेके अपना खेती में चलेगा, वहाँ पे लेबर था, वो खाना पीना सब था उधर। तो खेती में जाने के बाद अपनी बीबी से पूछा, फिर हम चाबी लेके आई, अपना अलमारी बंद करके, बोली नहीं। तो हम फिर चाबी वापस लेने के लिए आया, क्योंकि मेरा केस था, हमको निकोबार जाना था, हेलीकॉप्टर का टिकट बुक करके रखा था। तो देखा चाबी लेने वापस आया, मोटरसाइकिल लेके वापस आ गया, तो उससे पहले घूम गया था पानी, 2 राउंड घूम गया था। लिंक रोड के ऊपर सब नारियल का छिलका फैला हुआ था, मोटरसाइकिल भी नहीं आ रहा था। मोटरसाइकिल को पीछा कटा किया, फिर आया घर में। जैसे ही घर के अंदर घुसा सामने दरवाजे से, तो तीसरा जो सबसे पावरफुल लहर था वो उसी समय घर के अंदर पानी भरना शुरू हो गया। सामने का दरवाज़ा बंद किया, अंदर गया, अलमारी खोला, पैसा निकाला और जो सोना का जेवर वो सब निकाला। और ऐसे ही यानी कि हम घर के अंदर का जितना सोफ़ा वूफा था, सब फर्नीचर सब इधर उधर होके पड़ा था। अच्छा हुआ कि हम घर से बाहर निकल गए फटाफट। और जैसे ही बाहर निकला तो मेरा जो चाबी, पैसा, सोना फोना सब वहीं छूट गया। और जो लहर से एकदम राउंड जा रहा था घूम घूम के ऐसे ही। तो उसके बाद सबसे पहले जब सुनामी आया था, हम लोग यानी कि भूकंप आया था, भूकंप से पहले अपनी गाय जितना था उनका रस्सी काट दिया था, सबका खोल दिया कि तुम गाय जाए। फिर बह के जा रहा साथ में, जैसे पीछे का दरवाजे से हम बाहर निकला तो पानी उठा लिया। पानी के साथ बह, पानी के अंदर बिल्कुल किसी का ताकत नहीं आता, हम पानी के साथ बह बह के जा रहा। और मेरा जिनके नीचे का जो निक्कर था, पहन रखा था, उसको भी खोल दिया। समझे, सब ले गया खोल के, खाली ऊपर में कमीज रह गया, बाकी रह गया। हम बह के जा रहे हैं, सुपारी पेड़ आया, सुपारी पेड़ को पकड़ा, वो भी उखड़ गया। फिर और एक सुपारी आया, वो उखड़ गया। फिर बड़ा नारियल पेड़ था, उसको पकड़ के हम वहीं रहा थोड़ा देर, आधा घंटा तक था उसके साथ में। फिर एक बार पेड़ को छोड़ा तो हम पूरा डूब गया, फिर दोबारा पकड़ लिया। फिर सोचा अभी अगर इधर आया तो फिर मारा जाएगा कुलदीप सिंह। फिर सामने की तरफ देखा तो देखा चारों तरफ, उस समय देखा तो चारों तरफ पानी है, कहीं भी ज़मीन नज़र नहीं आता, सब पानी पानी नज़र आ रहा है। उस समय थोड़ा दिल को झटका लगा भी इधर से कैसे निकलेगा। तो शुरू में हम बचने में लगा रहा। जब बह के जा रहा तो एक गाय का झोंपड़ी था, वो छूट के आ रहा। हम दूर है इतना, तो सामने गाय की झोंपड़ी वो आ रहा। और एक कचरा पूरा कम से कम 200 स्क्वायर मीटर एरिया कचरा में लकड़ी फकड़ी सब फंसा हुआ आ रहा साथ में। और हम उसके सामने, कचरा मेरे एकदम थोड़ा सा दूर। हम बोलो भैया कचरा के नीचे फंसेगा तो गया भैया कुलदीप सिंह। फिर पानी तो घूम रहा था एकदम, लहर ऐसी ऐसी जाता था, तो पानी मेरे को अंदर खींच लिया। हम बने कि अपना हाथ खाली मारता था, हाथ ही मारता था, क्योंकि तैरना तो हाथ में आ रहा था इसलिए हम अंदर गया नहीं जल्दी। उसके बाद पानी फिर भी मेरे को अंदर कर ही लिया। अंदर किया था, हम रोज़ पूजा पाठ करता था, ओम नमः शिवाय जपता था, तो उसी समय फटाफट मुँह से ओम नमः शिवाय का जाप शुरू, ओम नमः शिवाय चालू। तो थोड़ा देर में फिर हम कैसे भी बाहर आ गए, पानी फिर ऊपर आ गया। फिर वहाँ आके फिर बैठा, फिर नारियल पेड़ को पकड़ा था, वहाँ आधा घंटा खड़ा था, पकड़ के फिर देखा अभी कहाँ से जाएगा, सोचा कहाँ से निकलेगा। फिर बगल में उल्टा सामने समुंदर है और उल्टा साइड में लिंक रोड था। फिर वहाँ से तैर के पार हो गए, लिंक रोड तक गया, यानी कि बीच में बार बार वायर सब लगा हुआ था, अपना अपना खेती में संभाल के रखे थे, तो बार बार वायर में थोड़ा कट पट के कैसे भी लिंक रोड पहुँचा। तो वहाँ से आगे गया, आगे जाके फिर एक लहर आ गया और फिर मेरे को बहा दिया। और फिर एक नारियल पेड़ था, नारियल पेड़ का पत्ती थोड़ा देखा कि सामने पत्ती लटका, उसको कैसे भी हम पकड़ा और पकड़ के फिर नारियल पेड़ को पकड़ के खड़ा रहा। फिर वापस फिर निकल के गया, तो अंदर का कपड़ा तो नीचे है ही नहीं, फिर थोड़ा उधर पूरा लेडीज भी गया था, मेरे को शर्म आ रहा था कि आगे कैसे जाएगा, फिर हम बोले शर्माते रहेगा तो मारा जाएगा आज। फिर हम चला गया, अपना खेती में गया, नीचे लेबर मिल गया, लेबर मिला तो लेबर को बोला भैया जाओ फटाफट अपना लुंगी लेके आओ, और लुंगी लेके आया, फिर ऊपर चला गया। ऊपर में देखा मेरा खेती के झोंपड़ी में 4-7 आदमी सब था, वो जितना उसका चावल था लेबर के पास में, एक ही टाइम में खाना पीना बंद। और रेडियो में न्यूज़, रेडियो भी था लेबर का, रेडियो में न्यूज़ सुनते तो खाली निकोबार का नाम ले रहा, और निकोबार में इतना आदमी मार रहा है, ये अंडमान हमारा कैंपल वे का कोई नाम नहीं लेता था। तो इस तरह से तुरंत 2 बच्चा, यानी कि कैंपल वे का 2 बच्चा भी था किसी का, वो हमारे भाई के बच्चों के साथ खेलने की रात बिताने आ गए। और वहाँ दूसरा दिन सुबह उसका माँ बाप आ गए ढूंढते ढूंढते, तो उनके आने की वजह से हमको पता चला कि कम से कम चलो भाई रोड ठीक है, कहीं कहीं रोड तोड़ दिया सुंदर, और जो कलबट था 14 किलोमीटर का उसका भी सामने का मट्टी उखाड़ दिया था, लेकिन आदमी पार हो सकता था। और फिर हम लोग जितने से सब वहाँ से निकले और वापस एकदम कैंपल में जो प्रॉपर था वहाँ पे चले गए। और फिर सुनामी जो कैंप से शेल्टर बना दिए, उसमें शेल्टर में गवर्नमेंट ने रख दिया सबको, जिनके सामान खाना पीना सब देना शुरू कर दिया। तो इस तरह से और सुनामी में एक ही काम करना है कि आदमी को अपनी जो हिम्मत है वो नहीं खोनी है, कि अपना दिमाग चालू रखना चाहिए। यानी कि अगर हम लोग कोशिश करेंगे तो बच सकते। तो ये नेचुरल डिज़ास्टर है, इसको कोई रोक नहीं सकता, यानी कि जो ऊपर वाला करता है उसको रोकने की शक्ति किसी के अंदर नहीं है। तो उसका एक ही कि बचाव ही हम लोग कर सकते हैं, जितना हम लोग बचाव कर सकते हैं उतना ही फायदा है, रोकने की हिम्मत किसी में नहीं है। इसलिए यहाँ पे आपने मुझे बोलने के लिए मौका दिया, उसके लिए धन्यवाद।
सर आपको बहुत बहुत धन्यवाद आपका एक्सपीरियंस शेयर करने के लिए। I now invite the another tsunami witness, Mr. Sri Kumar from Kerala, to share his experience. I requested Dr. Hari Kumar to translate this.
എല്ലാവർക്കും നമസ്കാരം. ഞാൻ കേരള സ്റ്റേറ്റിലെ കൊല്ലം ജില്ലയിൽ ആലപ്പാടെന്ന് പറയുന്ന പ്രദേശത്തു നിന്നാണ് വരുന്നത്. സുനാമി ദുരന്തത്തിൽ കേരളത്തിൽ ഏറ്റവും കൂടുതൽ പേരുടെ ജീവൻ നഷ്ടപ്പെട്ട പ്രദേശം. വെറും 17 കിലോമീറ്ററിനുള്ളിൽ 142 പേരുടെ ജീവനാണ് അവിടെ പൊഴിഞ്ഞത്. പിന്നെ തൊട്ടടുത്ത ആലപ്പുഴ ജില്ലയിൽ 18 കിലോമീറ്ററിനുള്ളിൽ 32 പേരുടെ ജീവൻ. അതുപോലെ എറണാകുളം ജില്ലയിൽ എടവനക്കാട് 2 പേര്, അന്ധകാരനഴിയിൽ 2 പേര്. അപ്പോൾ ഈ സ്ഥലത്തിൻ്റെ ആലപ്പാടിൻ്റെ ഒരു പ്രത്യേകത എന്ന് പറയുന്നത് കായലിനും കടലിനും ഇടയിൽ ഒരു വരമ്പ് പോലെയുള്ള പ്രദേശമാണ്. അതിനു മുമ്പ് എനിക്കൊരു കാര്യം, ഞാൻ ആരാണെന്ന് പരിചയപ്പെടുത്തില്ല വേദിയിൽ. എൻ്റെ പേര് KC ശ്രീകുമാർ എന്നാണ്. ഞാനൊരു മത്സ്യത്തൊഴിലാളിയാണ്. ഈ സുനാമി ദുരന്തം നടക്കുമ്പോൾ ഞാൻ കടലിലായിരുന്നു. ഏതാണ്ട് 22 നോട്ടിക്ക് മേലിനപ്പുറം മത്സ്യബന്ധനത്തിൽ ഏർപ്പെട്ടുകൊണ്ടിരിക്കുമ്പോഴാണ് ഈ ഡെപ്തിൽ വ്യത്യാസം വരുന്നത്. അതായത് എക്കോ സൗണ്ടറിൽ ആഴം കാണിക്കുന്നത് ഭയങ്കരമായിട്ട് കൂടുകയും കുറയുകയും ചെയ്യുന്നു. സാധാരണ ഇല്ലാത്ത വിധം കൂടുകയും കുറയുകയും ചെയ്യുന്നു. പരസ്പരം അന്ന് ഞങ്ങളുടെ കൈവശമുള്ള ടെക്നോളജി എന്ന് പറയുന്നത് ഇത് മാത്രം, വേറെ പരസ്പരം സംസാരിക്കുന്നതിനുള്ള സംവിധാനങ്ങളൊന്നുമില്ല. കയ്യിലുള്ളത് എക്കോ സൗണ്ടറും ഗ്ലോബൽ പൊസിഷനിങ് സിസ്റ്റവും മാത്രമാണ്. അപ്പോൾ ഈ വ്യത്യാസങ്ങളിങ്ങനെ കാണുന്നതിൻ്റെ അടിസ്ഥാനത്തിൽ എന്തോ സംഭവിക്കാൻ പോകുന്നുള്ള തോന്നലിൻ്റെ അടിസ്ഥാനത്തിൽ പരിഭ്രമിച്ചാണ് ഞങ്ങൾ മത്സ്യബന്ധനം നിർത്തി കരയിലേക്ക് മടങ്ങാൻ പ്രേരിതരായിത്തീരുന്നത്.
Yeah, he's Sri Kumar from Alappad region of Kerala, and he was witnessing tsunami, that's what he's saying. And it was affected badly at 3 states according to him as per his knowledge. One is Alappuzha and another one is Goyel and Kollam now, and also Ernakulam. Altogether he has told a toll of 180 almost. And he introduced or would like to introduce himself as a fisher, and now he is working on a business aspect of the fishing. And when the tsunami was happening, he was out at the sea, and he has been experiencing the change in the signals in the echo sounder, and it was too anomalous compared to any other occasions. Please.
പെട്ടെന്ന് ഞങ്ങളുടെ ഫിഷിങ് നിർത്തി വല ബോട്ടിലേക്ക് എടുക്കാൻ ശ്രമിക്കുമ്പോൾ അത് വളരെ പ്രയാസപ്പെട്ടാണ് അതിനെ ഉയർത്തി എടുക്കാൻ കഴിഞ്ഞത്. സാധാരണഗതിയിൽ മത്സ്യബന്ധനം നടത്തുമ്പോൾ ഫിഷിങ് കഴിയുമ്പോൾ വല എടുക്കുന്ന രീതിയിലല്ല, അതിൽ കൂടുതൽ ബുദ്ധിമുട്ടിയാണ് അതെന്ന് ഞങ്ങൾ കരയ്ക്കെടുത്തത്. അതിൻ്റെ കാരണം ഒഴുക്കിൻ്റെ വേവ്സിൻ്റെ രീതി അതായിരുന്നു കടലിൽ, അത്ര ഭീകരമായിരുന്നു.
It was very tough to take back the fishing net during that time, and the current was felt too much that time, and they were unable to take out the net, and they felt there is something odd happening.
കരയിലേക്ക് വളരെ വേഗം വരുമ്പോൾ ഇത് 11:30-12 മണിക്ക് മുമ്പായിട്ടാണ് ഇത് കടലിൽ ഇത് അനുഭവപ്പെടുന്നത്. അവിടെ നിന്ന് കരയിലേക്ക് വരുമ്പോൾ അഴിമുഖം വഴി അതിഭയങ്കരമായിട്ട് വേഗതയിൽ കടലിലേക്ക് പ്രവഹിക്കുന്ന സാധാരണയല്ലാത്ത ഒഴുക്കാണ് ഞങ്ങൾ കാണുന്നത്. അതായത് കടലിൽ നിന്ന് കരയിലേക്ക് മറിഞ്ഞ ജലം 2 അഴിമുഖങ്ങളിലേക്കായിട്ടാണ്, അതായത് നീണ്ടകര അഴിമുഖത്തും കായംകുളം അഴിമുഖത്തും കൂടാണ് കടലിലേക്ക് പ്രവഹിച്ചുകൊണ്ടിരുന്നത്. അതുകൊണ്ട് അത്രയും ശക്തിയായിരുന്നു, അതിലേക്ക് പ്രവേശിക്കാൻ കഴിയുന്നില്ല. ഞങ്ങളുടെ ഭയങ്കരമായ സ്പീഡ് വെച്ച് വന്നിട്ട് പോലും ബോട്ടിന് ഹാർബറിനുള്ളിലേക്ക് പ്രവേശിക്കാൻ കഴിയാത്ത രീതിയിലുള്ള പ്രവാഹം അഴിമുഖത്തുനിന്ന് പുറത്തേക്ക് വരുന്നുണ്ട്. അപ്പോൾ കരയിലും എന്തൊക്കെയോ സംഭവം നടന്നിരിക്കുന്നൊരു തോന്നൽ ഞങ്ങൾക്ക് മനസ്സിലായി. വല്ല പരിഭ്രമിച്ചാണ് വരുന്നതെങ്കിലും ഞങ്ങൾ അത് വളരെ സൂക്ഷ്മതയോടുകൂടി ഹാർബറിലൂടെ പ്രവേശിക്കാനുള്ള ശ്രമം നടത്തി.
Actually, he is mentioning that the region he is talking about is embedded between ocean and lake, in fact. So when they were trying to come back to the shore through the estuary, it was very difficult to get back to the shore, and they felt too much current there. In some cases it was from the ocean in the beginning, and then later I understand it is towards the ocean.
അഴിമുഖത്തിന് കുറുകെയുള്ള പാലത്തിന് താഴെയൂടെ വേണം ഞങ്ങളുടെ ബോട്ടൊക്കെ ലാൻഡ് ചെയ്യുന്ന സ്ഥലത്തേക്ക് പോകേണ്ടത്. പക്ഷേ അങ്ങോട്ട് പോകാൻ കഴിയാതെ സീ സൈഡിൽ തന്നെ ഉള്ള ഹാർബറിൽ ബോട്ട് കെട്ടിയിട്ടതിന് ശേഷമാണ് ഞാൻ വീട്ടിലേക്ക് വരുന്നത്.
He has anchored his boat somewhere else, unlike other occasions, and he has come back home.
വീട്ടിലേക്ക് വരുമ്പോൾ കാണുന്നത് ആ പ്രദേശത്ത്, ആലപ്പാടെന്ന് പറയുന്ന പ്രദേശത്ത് ഈ ദുരന്തം നടക്കുന്ന സമയത്തുണ്ടായിരുന്ന ഒറ്റ മനുഷ്യൻ പോലും അവിടെ ഇല്ല. ബാക്കി രക്ഷാപ്രവർത്തനത്തിൽ വരേണ്ട ആളുകൾ ഭയന്ന് കായലിന് കിഴക്കുവശമുള്ള ഭാഗത്ത് അവിടെ നിൽക്കുകയാണ്, ഭയന്ന് നിൽക്കുന്നൊരു കാഴ്ചയാണ് നമ്മൾ കാണുന്നത്.
Yeah, when he was coming back, there were nobody who is supposed to be there, that means the residents. But there were rescuers. They were so scared, and they were standing near the lake. I think they don't know what to do.
തകർന്നു കിടക്കുന്ന വീടുകൾക്ക് അടിയിലൊക്കെ കുട്ടികളുടെയും സ്ത്രീകളുടെയും അത് പ്രായമായവരുടെയൊക്കെ ജഡങ്ങളാണ് കൂടുതൽ കാണുന്നത്. കാരണം ഏറ്റവും കൂടുതൽ ദുരന്തത്തിന് ഇരയായത് മുഴുവൻ പ്രായമുള്ളവരും സ്ത്രീകളും കുട്ടികളുമാണ്. വെള്ളത്തിലൊരു പരിധിവരെയൊക്കെ നീന്തിയും ഒക്കെ രക്ഷപ്പെടാൻ കഴിയുന്നവർ ഒക്കെ രക്ഷപ്പെട്ടു. പിന്നെ മരങ്ങളിലൊക്കെ പിടിച്ച് നിൽക്കാൻ കഴിയുന്നവർ അങ്ങനെ രക്ഷപ്പെട്ടു. 6 അടി ഉയരത്തിലാണ് വെള്ളം നിന്നിട്ട് കുറേ അധിക സമയം കടലിലേക്ക് പോകണോ കായലിലേക്ക് പോകണമെന്ന് വെള്ളം തന്നെ ശങ്കിച്ച് നിൽക്കുന്ന പോലെ കുറേ സമയം നിന്നു എന്നാണ് എൻ്റെ കുടുംബത്തിലുള്ളവർ പറഞ്ഞത്.
Yeah, the most affected people were ladies and children. And moreover, when it was happening, some of the people were trying to climb onto the trees or holding to the branches and try to escape. And their family members were explaining him a lot of experience, what they experience in the land actually.
ദുരന്തത്തിൻ്റെ ആ സ്വഭാവം വെച്ചിട്ട് നോക്കുമ്പോൾ ഈ കായൽ ഈ ബാക്ക് വാട്ടർ ഇല്ലായിരുന്നെങ്കിൽ ഒരുപക്ഷെ ഈ കടലിൽ നിന്നും വന്ന ജലം കുറച്ച് കൂടുതൽ ആളുകളെയും കൊണ്ട് കടലിലേക്ക് തന്നെ തിരിച്ചു പോകുമായിരുന്നു എന്നാണ് നമ്മൾ മനസ്സിലാക്കുന്നത്. ആ ബാക്ക് വാട്ടർ അടുത്തുണ്ടായിരുന്നുകൊണ്ട് ബാക്ക് വാട്ടറിലേക്ക് മാറുകയും ബാക്ക് വാട്ടറിൽ എത്തിപ്പെട്ട കുറച്ച് പേരെ രക്ഷിച്ചെടുക്കാനും കുറേ പേരുടെ ജഡങ്ങളായി കിട്ടാനുമുള്ള സാഹചര്യം ഉണ്ടായി. അതുപോലെ കൂടുതൽ ഏരിയ ദുരന്തത്തിൽ നിന്ന് രക്ഷപ്പെടാതെ ഒരു ഷോക്ക് അബ്സർവറായി ഈ ബാക്ക് വാട്ടർ പ്രവർത്തിച്ചു എന്നുള്ളതാണ്. 17 കിലോമീറ്റർ നീളത്തിലുള്ള ബാക്ക് വാട്ടർ അങ്ങനെ പ്രവർത്തിച്ചു എന്നുള്ളതാണ് അതിൻ്റെ ഒരു അനുമാനം. മത്സ്യത്തൊഴിലാളി എന്നുള്ള എൻ്റെ അനുഭവമാണ് ഞാൻ പറയുന്നത്.
As he explained earlier, there was a lake on the other side, and that was stretching around 17 kilometers, and it supposed to be acted as a shock absorber. And many were thrown out into the lake, and that is the reason they were not taken away into the ocean again, and it has reduced the impact as per him.
ദുരന്തത്തിൽ പെടാത്ത ആളുകൾ വന്നതിന് ശേഷം തൊട്ടടുത്ത ദിവസമാണ് രക്ഷാപ്രവർത്തനം ആരംഭിക്കുന്നതും നമ്മുടെ ജീവൻ നഷ്ടപ്പെട്ട ആളുകളുടെ ജഡങ്ങൾ ജലാശയങ്ങളിൽ നിന്നും ഇടത്തോടുകളിൽ നിന്നും അതുപോലെ തന്നെ തകർന്നു വീഴുന്ന വീടുകളുടെ ഇടയിൽ നിന്നുമൊക്കെ രക്ഷിച്ചെടുക്കുന്നത് തൊട്ടടുത്ത ദിവസം മാത്രമേ കഴിഞ്ഞിട്ടുള്ളൂ. കാരണം ആർക്കും ഇങ്ങോട്ട് വരാൻ ഭയമായിരുന്നു. ഞാനും അതിൽ അവിടെ പെട്ടിട്ടില്ലാത്തതുകൊണ്ട് രാത്രി വരെ അവിടെ നിന്ന് മറ്റുള്ളവരെയൊക്കെ വിളിച്ചു കൂട്ടാനും ഇത് എവിടെയൊക്കെ ജഡങ്ങളുണ്ടെന്നുള്ളത് കാണിച്ചു കൊടുക്കുന്നതിനും നേതൃത്വം കൊടുക്കുന്നതിനും അത് കഴിഞ്ഞു എന്നുള്ളതാണ് അതിൻ്റെ ഒരു സാഹചര്യം എന്ന് പറയുന്നത്.
Yeah, notably the rescue operations were started next day, and there were a lot of dead bodies were taken from water bodies and from the devastated homes, etc. And he also started helping the rescue operations and lead most of the things there.
9 പൊതുവിദ്യാലയങ്ങളാണ് അവിടെ ഉണ്ടായിരുന്നത്. 9ൻ്റെയും ഏകദേശം 5 കെട്ടിടങ്ങൾ സമ്പൂർണ്ണമായി തകർന്നു. കുടിവെള്ള പദ്ധതികൾ തകർന്നു. നമ്മുടെ റോഡ് സമ്പൂർണ്ണമായി നഷ്ടപ്പെട്ടു. പിന്നെ പ്രാദേശിക സ്രോതസ്സായിരുന്നു കുടിവെള്ള സ്രോതസ്സുകളെല്ലാം, അതെല്ലാം ഇല്ലാതായി. സ്കൂളിലെ കുട്ടികളൊക്കെ മരിച്ചു. ഇതൊക്കെ ഉണ്ടായിട്ടും വളരെയേറെ അടിസ്ഥാന സൗകര്യങ്ങൾക്ക് വേണ്ടി ജനങ്ങൾ വളരെയേറെ ബുദ്ധിമുട്ടേണ്ടി വന്നു എന്നുള്ളതാണ് പിന്നീട് കണ്ടത്.
Yeah, out of 9 schools, 5 were damaged completely, and there were a lot of kids died in the school itself, and also there were lot of issue in the drinking water aspect as well, and it is found to be lot of the measure of effect is too much.
ഞങ്ങളോട് അന്നത്തെ ജില്ലാ ഭരണകൂടം പറഞ്ഞത് കുട്ടികളെ കൊണ്ട് മറ്റ് ഗ്രാമങ്ങളിലേക്ക് മാറാനാണ്, സമ്പൂർണ്ണമായി മാറാനാണ് പറഞ്ഞത്. ഞങ്ങൾ അവിടെ നിന്ന് എയ്ഡഡ് സ്കൂളുകൾ നിങ്ങളെയൊക്കെ കൊണ്ടുപോകാൻ, നിങ്ങളുടെ കുട്ടികളെ കൊണ്ടുപോകാൻ തയ്യാറാണ്. നിങ്ങൾ സമ്പൂർണ്ണമായും കുട്ടികളെല്ലാം അങ്ങോട്ട് മാറ്റാൻ ശ്രമിക്കണമെന്നാണ് അന്നത്തെ ജില്ലാ ഭരണകൂടം, ജില്ലാ കളക്ടർ വി ശ്രീനിവാസ് ഞങ്ങളോട് പറഞ്ഞ അങ്ങനെയാണ്.
The district administrator then has suggested them to move from the affected area and go to some other location, and some private schools were offering some seats for the kids to continue their studies in a different region.
പക്ഷേ അതിൻ്റെ പിന്നിലൊരു സ്ട്രാറ്റജി ആയിരുന്നു. അതിവിടെ ഷെയർ ചെയ്യേണ്ടതുണ്ടോ എന്ന് എനിക്കറിയില്ല. അത് ഈ ഗ്രാമം ഞാൻ പറഞ്ഞല്ലോ, കായലിനും കടലിനും ഇടയിൽ വരമ്പ് പോലായി മാറിയൊരു ചരിത്രമുണ്ട്. 5 കിലോമീറ്റർ കായലിനും കടലിനും ഇടയിൽ ഉണ്ടായിരുന്ന പ്രദേശമാണ് ഈ 300-400 കിലോമീറ്റർ ഡിസ്റ്റൻസായി മാറിത്തീരുന്നത്. അത് ബ്ലാക്ക് സാൻഡ് മൈനിങ്ങിൻ്റെ ഫലമായിട്ടാണ്.
Yeah, some of the aspects I don't need to disclose here. Rather, I would like to explain that there was a strip of land in between the lake and ocean that was expanded as well, and there were some black sand mining aspects as well to be pointed out.
വളരെ സ്ട്രാറ്റജിക്കലായിട്ട് അടിസ്ഥാന സൗകര്യങ്ങൾക്ക് ഒന്നും ഫണ്ട് അനുവദിക്കാതെ വ്യക്തിപരമായ ആനുകൂല്യങ്ങൾ കൊടുത്തുകൊണ്ട് ജനങ്ങളെ സംതൃപ്തരായി നിർത്താനാണ് ഭരണകൂടങ്ങൾ ശ്രമിച്ചത്. പക്ഷേ അടിസ്ഥാന സൗകര്യങ്ങൾക്ക് വേണ്ടിയുള്ള സമരങ്ങൾക്ക് നേതൃത്വം കൊടുക്കാൻ അവിടുത്തെ യുവതലമുറ മുന്നോട്ട് വന്നതുകൊണ്ടാണ് സ്കൂളുകളും ആശുപത്രികളും ഗതാഗത സൗകര്യങ്ങളും പുനഃസ്ഥാപിക്കാനായത്.
Rather than basic aspects to be revived, they were trying to have some political angle to it, and there were a lot of youngsters. They were trying to improve the condition of basic education and water facilities as well.
അതുകൊണ്ട് എനിക്ക് ഈ ശാസ്ത്ര സാങ്കേതിക വിദ്യാഭ്യാസ രംഗത്ത് പ്രവർത്തിക്കുന്ന റിസർച്ച് സ്കോളേഴ്സിനോടും സയൻറ്റിസ്റ്റുകളോടും പറയാനുള്ളത്, ഇന്ത്യയുടെ തീരം സംരക്ഷിക്കണമെങ്കിൽ അതിനുള്ള മുൻകൂട്ടി, അതായത് ഡിസാസ്റ്റർ വരുന്നതിനേക്കാൾ മുമ്പേ, ആ ഡിസാസ്റ്റർ വരാൻ സാധ്യതയുണ്ട് ഇനിയും, അത് ഭൂകമ്പങ്ങൾ ഇനിയും ഉണ്ടാകാം, സുനാമികളുണ്ടാകാം. അങ്ങനെ ഉണ്ടായാൽ ഈ പശ്ചിമഘട്ടത്തിന് പടിഞ്ഞാറുവശം കിടക്കുന്ന ഈ ഏത്തയ്ക്കാപ്പത്തിൻ്റെ രൂപത്തിൽ കിടക്കുന്ന കേരളത്തെ രക്ഷിക്കണമെങ്കിൽ ആ കേരളത്തിൻ്റെ തീരം തുറക്കുന്ന നടപടി അവസാനിപ്പിക്കുന്നതിന്, അത് നിർത്തിവെക്കുന്നതിന് ശാസ്ത്ര സാങ്കേതിക സ്വഭാവത്തിൽ എന്തെങ്കിലും നിർദ്ദേശങ്ങൾ വയ്ക്കാനുണ്ടെങ്കിൽ അത് പഠിക്കുന്നതിനും അതിനുള്ള നിർദ്ദേശങ്ങളും ശാസ്ത്ര സാങ്കേതിക രംഗത്ത് പ്രവർത്തിക്കുന്നവരുടെ ഭാഗത്തുനിന്ന് ഉണ്ടാകണമെന്ന് അഭ്യർത്ഥിക്കുകയാണ്.
My request is, or request to the youngsters, young scientists and other people working on the field is to make strategies to, save the strip of Kerala, which is like a banana shaped on the other side of the Himalaya, and the western side is Western Ghats, and there should be strategies to save such a land strip.
നിലവിൽ ഉള്ള മിക്കവാറും അനുഭവങ്ങൾ കാണുന്നത് ശാസ്ത്ര സാങ്കേതിക രംഗത്തിരിക്കുന്ന ആളുകളൊക്കെ, സയൻറ്റിസ്റ്റുകളൊക്കെ ഡിപ്പാർട്ട്മെൻറ്റിൽ ഇരിക്കുമ്പോൾ ഭരണകൂടങ്ങൾക്ക് വേണ്ടി, മൈനിങ്ങിന് വേണ്ടി, കോർപ്പറേറ്റുകൾക്ക് വേണ്ടി റിപ്പോർട്ടുകൾ എഴുതി ഉണ്ടാക്കും. അവർ റിട്ടയർഡായി കഴിഞ്ഞാൽ സത്യസന്ധമായ കാര്യങ്ങൾ പുറത്തു വന്ന് പിന്നെ പറയുന്നതാണ് ഇതുവരെ കണ്ടിട്ടുള്ളത്. അപ്പോൾ അങ്ങനെയാകാതെ ഇൻഗോയ്സിനെ കൊണ്ട്, അല്ല ഇതുമായിട്ട് സഹകരിക്കുന്ന വിദ്യാർത്ഥികളുണ്ടെങ്കിലും റിസർച്ച് സ്കോളേഴ്സ് ഉണ്ടെങ്കിലും സയൻറ്റിസ്റ്റുകളുണ്ടെങ്കിലും ഭരണകൂടത്തിൻ്റെ ഭാഗത്തുനിന്നുള്ളവരും ഇതിൽ ശ്രദ്ധ കേന്ദ്രീകരിച്ചുകൊണ്ട് ഈ ഇന്ത്യയുടെ തീരഗ്രാമങ്ങളെ ദുരന്തങ്ങൾ അനുഭവിക്കുന്ന മത്സ്യത്തൊഴിലാളികളെ രക്ഷിക്കാനുള്ള ഒരു ശാസ്ത്രീയമായ പഠനവും നിർദ്ദേശങ്ങളും ഉണ്ടാകണം അഭ്യർത്ഥിച്ചുകൊണ്ട് നിർത്തുന്നു. അഭിവാദനങ്ങൾ.
What is happening so far is those who are in service will work on reports and make lot of studies, but when they retire they will say about the real facet. But his request is to have realistic studies and research on these aspects and bring out the effective methodologies to safeguard the people who are fishers. In his case it is from Kerala, and with that he concluded his talk.
Thanks.
Village which we selected as the tsunami ready community, we are actually in the process of making it tsunami ready. ശ്രീകുമാരേട്ടാ, നിങ്ങൾ പറഞ്ഞതൊക്കെ നമ്മൾ വളരെ വ്യക്തമായിട്ട് കേട്ടിട്ടുണ്ട്. പിന്നെ അതുപോലെ തന്നെ നമ്മൾ ഇവിടുത്തുള്ള സയൻറ്റിസ്റ്റുമാർ നമ്മൾ കൂടുതൽ കോൺസെൻട്രേറ്റ് ചെയ്യുന്നത് ഈ സയൻസിനെ ജനങ്ങളുടെ ഉപകാരത്തിന് വേണ്ടി എത്തിക്കുക, അതിനു വേണ്ടിയാണ് ഞങ്ങളിവിടെ വർക്ക് ചെയ്യുന്നത്. താങ്ക് യു.
Thank you, sir. I now request Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to quickly summarize this session. To some.
She has an old problem, so she is taking revenge on me, I think. Okay, I think it is, first of all, I thank you all for sharing your thoughts and your reflections. And especially first three, I think Dr. Silas Nayak has mentioned about how this tsunami warning system was built from the scratch and how it has been developed. So So he has talked about is the development aspect. And Dr. Sanai was mentioning about how it has sustenance and little bit how we have improved over the initial built-up of tsunami. Then I think Dr. Srinivas has mentioned about how we have interacted with the collaboration with the various other institutions, not only in India, but also in the other side, how we learned experience and how we have built a robust system. Of course, he was from the scratch, he was there, and he started from the initial phase to up to now, he was contributed the system. And most importantly, two of the reflection has been shared, and it is very important because it is internationally how it has been not only from India, not only this tsunami warning system or anything, it is local things. We need to have a global, as a global south, we need to contribute many things instead of not only local but also global, or maybe what they call is a local. So local aspect also we need to consider when we want to build this system. And finally, I think before that, Dr. Radhakrishnan shared his experience, how in field, how they have acted and how we need to do. I think this presentation, everybody has to go through once again, because each one we need time to understand and to take what was going on, so that we can have a better preparedness in the coming future. Maybe some of the nuances we can get from each slide of what he has told, and maybe we can go through later, so that definitely we can learn the practical experience, so that whether we can do something differently still further, that we can think about it. And lastly, most importantly, two of the what is called eyewitnesses of tsunami things, they have shared their experience. I think it is very important. It is not only to share to experience here, but also it is important for us, somebody like you, to share your experience to other local communities, and how do we better prepare to among your friends and families and villagers, so that it will be useful, so that what we are giving, it is reaching in the last milestones. For that, it will be greatly will be benefited. So once again, I thank you all for sharing your thoughts and experiences. I'm sure that maybe the next maybe afternoon session, you will be able to take what is the way forward and how we can go from now. Thank you very much.
Thank you very much, sir. Now, it is a time to celebrate the achievements. Today, we are proud to recognize 26 tsunami-ready villages and honor the community leaders for their exceptional commitment and proactive efforts toward achieving UNESCO IOC Tsunami-ready recognition. I request our Secretary, Dr. M. Ravichandran, to hand over the certificates to community leaders. I will announce the names of the districts and the villages. I request one by one to come here to receive these certificates. From the district of Baleshwar, the village is Jaidev Kasaba. Jagannathpur, Kanyanagari, Sahapur, Mohanpur, Adwan village, Sana Krishnapur, Bada Habeli Sahi, Kaitha, Kantillo, Baghaipur, Dhanu Harbeli Lari, Bhuyanapala, Nolia Sahi, Kautajanga, Narasingapatna, Kalakatapatna, Chotipada, Chichiri, Tantiapala Sasan, Prayagi, Kantiagada, Uppulaputi, Markandi, and Venkat Raipur. I request Secretary Dr. M. Ravichandran to kindly felicitate our guests. First, Ms. Tijiana Bonapes. Dr. S.S. Shenoy, Dr. T. Srinivasa Kumar, Dr. J. Radhakrishnan, Dr. Kamal Lochan Mishra, I now request Dr. Balakrishnan Nayak, Director INCOIS, to felicitate our Secretary. For their significant contributions, so just 2 more minutes. For their significant contributions to the establishment of tsunami warning system, we would like to honor the directors of the partner institutions. I request Dr. Balakrishnan Nayak to present the mementos. Dr. M.E. Ramanamurthy, Director, National Center for Coastal Research. Dr. O.P. Mishra, Director, National Center for Seismology. Shri Naval Prakash, Joint Advisor, National Disaster Management Authority. Shri Pravan Kumar, Joint Advisor, National Disaster Management Advisory. As we approach end of this session, I request all dignitaries and Odisha community leaders to gather for a group photo. Please. Yes, down. Ladies and gentlemen, we have now reached the lunch break. Lunch will be served in the plenary hall of the ground floor of the ITCO Ocean building. We request all participants to proceed to the designated area, which is inside this campus, but in a different building, which is a 5 minutes walk away from here. Our INCOIS colleagues will lead you. Please be noted the technical session will start at 3:30. I request you all to come back to the auditorium on prompt time. Thank you. 3:30.
when you
You're confident now, no?
Next month, I'm again coming.
We're actually expecting. ఆల్రెడీ చాలా లేట్ అయిపోయింది
మ్యామ్ ఈ ల్యాప్టాప్ ఇక్కడ ఇంకా కావాలా నెక్స్ట్
కావాలి నెక్స్ట్
ఛార్జింగ్ డౌన్ ఉండే
పెట్టారా
సైడ్లో
అవుతుంది అవుతుంది
My presentation, I would like to
Welcome back. As we move into technical session, we will explore the advancements and the challenges in tsunami preparedness and mitigation. This session is co-chaired by Mr. E. Pattabi Ramarao and Dr. Pawan Kumar. I request our guest, Dr. Sri Srinivasa Kumar, Ms. Tijiana, Mr. Naval Prakash, please take your chairs on dais.
Good afternoon and welcome back to the afternoon session. We are going to have a technical session. Actually, we have scheduled 5 presentations, but one presentation I think we are not going to take because of the time that we have. We are already running 1.5 hours late, and that one presentation is already covered by many of the speakers in the morning. Then we decided we will not take that. Otherwise, we have 4. One is the first presentation is by Dr. T. Srinivas Kumar. Is going to talk on Ocean Decade Tsunami Program. Yeah.
Okay, thank you, Pattabi. So I'll kind of try to be brief. So this is just a recap of where we are right now, 20 years down the line after the 2004 tsunami. So we have made progress. That's what we have heard since morning, and then we have some challenges. So there are 4 regional systems operating in 4 different ocean basins. For those of you who are new to what happens under the UNESCO IOC global system of systems, so there is one in the Indian Ocean region, of which India and these countries are a part of. About 27 member states and territories within the Indian Ocean region are part of IOTWMS. And then we have similar systems established after the 2004 tsunami under the UNESCO IOC framework. One is in it's the NEAM TWS, it's called the Northeast Atlantic and Mediterranean Warning System. And then there is the Caribbean WS, which operates within the Caribbean Ocean Basin. And then of course the PTWS, which was erstwhile, it was called the ITSU. That was initially set up in 1965, but it was rechristened as an ICG after the 2004 tsunami. So this is a huge event, and then it actually works as a global system of systems. Like for example, the IOTWMS has 3 tsunami service providers providing tsunami forecast information to the National Tsunami Warning Centers. They are authorized National Tsunami Warning Centers, which are nominated by the member states. So that 27 member states which I mentioned, they actually nominate through the IOC very high level process on who should receive this information. So it's a network of providers and receivers, and similar networks are there in the other basins as well. So they receive information from 1 or more TSPs. In the case of Indian Ocean, it is 3 TSPs. And then it's the sovereign responsibility of the member states to provide warning watches and advisories to their citizens. It's not the business of the TSPs to provide warnings. It is the responsibility, sovereign responsibility of the member states. So all that has been working well. I mean, there were several events that were actually that this system responded to, global system. Globally, now there are about 13 tsunami service providers in all of these 4 ocean basins, covering vulnerable coastlines of close to about 140 member states actually and territories. So we have sea level, seismic and sea level observing networks and models that have been put in place. Like for example, if you take the Indian Ocean, there are only a handful of seismic stations and sea level stations that were reporting in real time before the 2004 tsunami. So after the 2004 tsunami, there has been a lot of advancement in all the member states within the region. And then there's a huge amount of data sharing that is happening. Now, like for example, the CTBTO network is shared with all the TSPs in the region through an MOU between UNESCO IOC and the CTBTO. So those iris networks are there, which are actually being shared across. So if you see the warning center at INCOIS, when you have the opportunity, you'll see that there are hundreds of seismic stations being analyzed, data received in real time, and then being able to detect earthquakes. And this is the same case with several TSPs. And you have sea level observing systems, tsunami buoys, and you have tide gauges, again hundreds of them. Now they are actually reporting in real time. Communication systems, there are data support systems and stand operational procedures, so on, for actually people to receive warnings and then respond to the warnings. And there is Tsunami Ready community. You have heard so much about Tsunami Ready since morning. And then, so these are some success stories actually, but then there are several challenges, so which we need to identify. This is a good opportunity to actually reflect on those challenges. So tsunami warning is always a race against time, that, and then that brings in an amount of uncertainty. The faster or you need to detect an event or provide a warning, you have lesser data, which means that your uncertainties are larger. So that's there. And then there are gaps in warning and response capabilities, especially for non-seismic tsunamis. Again, you have heard about this since morning several times. And then also near field complex sources, where, for example, you take events like Palu, tsunami, or the Sunda State tsunami. The tsunami washed ashore just within 3 to 5 minutes after the earthquake, large earthquake. And then that was the result of a secondary landslide under the, Palu Bay. So those kind of events, they put in a lot of complexities. So there's source complexities that you need to resolve. So those are the things that we need to work around. What do we do in such cases? And then, gaps in SOPs and warning chains, and then preparedness and response. And right now, this is a graph here, small one, which shows that, about 75% of the tsunamis globally have happened due to earthquakes. Now, that 25% is what we need to actually focus on going into the future, the non-seismic stuff. So that's just one slide on, where we need to go. And then this is a governance framework of the UNESCO IOC system. So I'll not get into the details of it. Pattabi, who is sitting here, he happens to be the new chair of ICG IOTWMS, elected at the last meeting in November. And then the IOTWMS and other warning systems work around 3 pillars. The first thing is this tsunami hazard assessment and risk assessment. You need to know, first of all, from where or hazard is coming from, whether it's just earthquake just in the Sunda Strait and Makran, or is it somewhere else? So those kind of hazard assessments are done by a working group. And then there is detection, warning, and dissemination done by another working group. Awareness and response, which is done by another working group. And then there are task teams working on new technologies and so on and so forth. Now, how do we address the challenges that I mentioned before? What are those, so that has actually been undertaken within individual ICGs and even within member states. I'm aware India, for example, is working on, a cabled, tsunami detection system of Andaman. And then there are several other member states working on other technologies. Now, why they're doing what they're doing is because they want to improve upon the accuracies, warning accuracies. So the IOC UNESCO has put together a program under the UN Ocean Decade, which is currently being undertaken between 2021 and 2030. We are almost midway now. So under that, there are several programs that are being kind of, people are working on. And one major program is called the Ocean Decade Tsunami Program. So in the next 5 to 7 minutes, I'll try to just show what are the major components, and then where there are actually, platform. It's a platform where all of us can collaborate, all stakeholders can collaborate. So what are those kind of opportunities is what I'll tell you. So here the goal is to develop the warning systems capability to issue actionable and timely tsunami warnings from tsunamis from all identified sources. Now these sources mean all sources, not just earthquake sources, and then be able to provide warnings to 100% of the coasts at risk. So you need to get a global coverage. And the next thing is actually 100% of communities at risk be prepared and resilient to tsunamis by 2030 through structured programs like the UNESCO IOC Tsunami Ready. You have seen 26 communities receive this certification today. And there are 22 more in Indonesia. So that actually takes it about 48 communities in the Indian Ocean, just in 2 countries. And even in India, it's just 1 province which has actually taken up this program, which is very important. Now, how do you scale this up to, across the, not only India and the region, but globally? Now, that's something we need to achieve. And then all those things are addressed around risk knowledge, detection, analysis and warning, forecasting, warning dissemination, preparedness, and then capacity building, which actually cuts across all these pillars, and then the governance. So that's actually the research, development and implementation plan, which was developed and just released and approved by the IOC Assembly in 2023. So a scientific committee built this, a committee of global expert, which I had the honor to chair when I was at INCOIS. So this plan is actually, these are some of the elements of this plan. So there are certain gaps that have been identified. I'll not get into the detail, but then all of us know tsunami risk knowledge. It actually, you need to know you need to define your inundation areas. You need to identify the sources. You need to actually assess what are the flow depths. So all of these things requires historical catalogs of tsunamis, or you need to model the sources. You need to actually have very accurate digital elevation and bathymetry and digital elevation models, topographic models. All of this is required. Now, there are huge gaps there. We are talking about countries with huge capacity, differences in capacities. Now, how do you bridge those capacities and ensure you have proper risk knowledge amongst the member states? And then vulnerable infrastructure, and then what are the methods you use to calculate risks? And then using the results of these studies to kind of update your risk assessments at the regional level, and then also take it down to the community level or your country level. Some work has been done, a lot of work is pending, so this is something we need to do. And then on the detection, analysis and forecasting part, colleagues from INCOIS and then other technical agencies might be very interested in this. So this is actually a cartoon which shows where we were in 2004, the top one. And this is actually, sorry, this is not very clear, but I'll just explain quickly. This is uncertainty, and then this is actually the time. So the uncertainties in tsunami warning, it used to be actually, at a very high level. It used to be very uncertain until about a day in 2024. You remember, we didn't even know what was the event, where the waves were coming and going, and so on. But then in 2019, if you see, we have made several developments. You have new sensors, seismic sensors, sea level sensors and all. In the first 15 minutes, your uncertainty has come down by half. Now, this is what we want to achieve by 2030. You have a lot of other techniques. You have sea level stations, you have GNSS measurements, you make all that, and then you actually are able to characterize your source much more accurately. And then you want to be able to give a warning with utmost certainty within about 10 minutes. Now, that's the goal. Now, if you need to do that, there is several things that you need to do. And you actually need to expand international cooperation. You need to be able to provide, the target is to provide warning confirmation within 10 minutes as part of this ODTP, which means that you need to maximize and expand current capabilities of sensing equipment like seismometers, tsunameters, tide gauges, GNSS, dedicated observatories like smart cables and supporting capabilities. You need to also implement existing capabilities but not being used for watch operations right now. Right now, if you go to the Tsunami Warning Center, you will not see any data from smart cables or coastal radars. NIOT runs 5 pairs of coastal radars. You don't see it operationally being used for tsunami warning today, though you get the data. So you need to build those techniques actually to be able to use that. Active passive remote sensing. There are altimeters right now flying as we speak. But then do we operationally have access to those altimeters and then use that in tsunami warning? That's a good stream of data. So that can be done. And then new candidate capabilities like ionospheric tomography, total electron count, measurements, fiber optic, distributed acoustic sensing, and so on. So you can do several kind of things, build, capabilities around sensing, and put those sensors, in a way, you design an optimal notional network, and then all countries come together and contribute to this notional network so that you fill the gaps. India puts a few, Australia puts a few, or Sri Lanka puts a few, so then you need to come out with this. So this is a grand plan, and then you need to come up with new forecast methods, use probabilistic forecasting techniques, or use AIML kind of techniques. Once you become from data poor to data rich, then you can do lots of things actually. Now, dissemination, I'll not get into the detail again, just a minute or half a minute. Once you have a very good warning, say for example, but then unless you communicate it very clearly, in a way that people can consume that information at the disaster management level as well as the community level, we are going to still lose lives. Now that's the important point here. Whether you use CAP, whether you use anything else, or you use a graded color combination of messages with certain action items, you call them warning, watches, alerts, whatever you want to do it in a way that people can consume that information and respond appropriately. Now that's the big component here. So there's a lot of work that is here that is to be done. Preparedness, again, Tsunami Ready is one program. Different countries, like different states within a country also have their own preparedness program. Like Odisha does is Tsunami Ready. In Tamil Nadu may be doing something else which is similar to, these kind of preparedness programs. Now, getting into some of those discussions on the equivalency of those preparedness program, the idea is, like for example, you can measure the performance of upstream part of the warning system by very, clear indicators. Like for example, can I detect an earthquake in 10 minutes? Can I actually have the magnitude accurately detected within plus or minus 0.2 magnitude, moment magnitude? So those are the kind of indicators you have for upstream. But then downstream, you don't have that structured indicators to define the preparedness of communities. Now, Tsunami Ready is a program that actually gives you that structural framework to define, preparedness and response at the community level. So that is something we need to implement, adopt and implement. And capacity building is a big thing. IOTWMS under the UNESCO has a huge amount of capacity building activities being undertaken through, again, member states in the region. UNESCO is what, or UNESCAP is what? It is, we are what our member states are, what is our collaborations are through the member states. So upcoming training, a large training that we are going to undertake on SOPs, Development of Standard Operational Procedures. Now we develop and we actually generate a warning, disseminate it. Who is responsible to receive that warning? What are the roles and responsibilities of different agencies in that warning chain? NDMA, DDMA, SDMA, or the block level. And then which step of the warning they should actually do. Like for example, evacuation can be done only by the district collector. He's the incident commander. INCOIs cannot say that I'm given a warning, you go and evacuate. Now, defining those detailed SOPs, taking into consideration the social and administrative setup of each of those countries in the region is a big challenge. All of that actually is being dealt with under capacity development and several other things. So I'll kind of try to, I've come to the end of my presentation, just maybe my last but one slide here. So there are several pathways to, implementing this grand plan. It's very ambitious. 2030 is not very far away. Can we achieve 100% of communities, tsunami ready? Or can we actually have all that fancy kind of, observing systems to be able to bring down the uncertainties to near zero in the first 10 minutes? This is actually what we need to contribute to. It has to be a jointly contributed program by all the member states, all the stakeholders. This plan is actually providing us that framework. A single tide gauge installed by a country in a place where we don't have sea level observations is going to enhance your warning, accuracies phenomenally. So there is no contribution that is small or no contribution that is very large. So that's the kind of, framework this provides for everybody to become partners in implementing this, kind of framework. So there is also a working group 6, which actually talks about increasing community resilience to ocean hazard. Now we spoke about one hazard, which is tsunami. There are other hazards like swell waves, Bala spoke about it and Secretary spoke about it. There are other things like high currents and coastal inundation caused due to storm surges. So that actually all contributes to coastal resilience. So there is a white paper which actually has 2 goals, again under ocean decade. So tsunami contributes again to this white paper in achieving, people-centered multi-hazard warning systems and so on. So under the Ocean Decade Tsunami Program, there is an opportunity for countries to actually pitch their initiatives or design an initiative against one of those gaps that I've shown you before. It's a nice document. Patabi can actually give you the links. You can download and see where actually you'll find several hooks where you can actually contribute to. And this is just an example of smart cables, huge capability that actually you can actually, if you are able to make these smart, capable, all the telecommunication cables, you'll have huge amount of ocean bottom pressure data that is going to be reported to the warning centers, which you can use for not only tsunami, you can use it for climate and those kind of applications. So right now the number of projects that have been submitted under this Challenge 6 is it is very minuscule. People are worried about ocean and climate and things like that, but then we need to actually pull up our socks and say that, okay, these are some things, simple things, but we can contribute to prepare a project around the challenges of the Ocean Decade Tsunami Program or on a Challenge 6 and then say that this is, because lots of work is being done in the countries. Now, how do we actually link it to some of these initiatives, broader scale initiatives, because all the countries in the region are actually part of the UNESCO IOC, they're part of, agencies, UN agencies like UNESCAP. So I'll not get into detail of this slide. This is just shows how the notional network design could be and then how we can contribute. Now this is a viewer, tsunami ready viewer. You can see the countries, communities here. Right now there are about 100 communities from 34 countries as on date. But then this is something which the UNESCO IOC is working on to actually keep it updated, promote this program and so on. So under IWMS, again, I would like to mention here, while Tiziana is here on the stage, we have been doing a lot of work on UNESCAP, through the trust fund on the Makran subduction zone. Now that's something which adds hugely to our understanding of the hazard, the first pillar that we are talking about, hazard and risk assessment. So these are initiatives that we need to work around, use the collaborative platforms and then work with the countries, work with the centers, work with the scientists, both nationally, regionally and globally, and then make sure that 100% of the communities are prepared and ready to respond to tsunamis, both from the warning perspective, technical perspective, and from the community perspective. Thank you.
Thank you, Srinivas, for the very brief and comprehensive presentation on Ocean Decade Program. Because of want of time, I think maybe we can take questions after all the presentations. May I now request Ms. Tiziana Bonapes, Director ICTDR UNESCAP, to make a presentation on the role of UNESCAP Trust Fund in tsunami preparedness.
Just press to move forward. I press here. Okay, thank you. Okay, thank you. Okay, thank you very much, moderator, and a very good afternoon to everyone again. So I have the pleasure now to give you some information, some insights into the role of ESCAP's trust fund. It's a trust fund on tsunami, disaster and climate preparedness. And what have we done to advance the progress in tsunami preparedness. My presentation is a little too long for the time available, so I'll try to be quite brief. I'll be skipping some of the slides as we go along. But I did want to just start off by presenting to you what we call the regional riskscape. So this is basically the regional disaster riskscape. And the key feature here is that across Asia Pacific, as it continues to urbanize, risk is accumulating. There are 170 cities that are located in extreme risk, 314 in high and 154 in medium risk categories. And this is because the risk hotspots are either intensifying with climate change, or we are seeing new risk hotspots emerging. So areas, cities that never experienced disasters that are suddenly experiencing more and more disasters. Asia Pacific remains the most disaster impacted region. Since 1970, over 2 million people have lost their lives. Least developed countries, small island developing countries account for mortality that is 5 times the rest compared to the average for Asia Pacific. Economic damages are on the rise. Fortunately, lives lost are declining unless there's a big event, and the big event is usually a seismic event or a tsunami. But over decades, lives lost are decreasing. And by 2030, we expect more than half of the region's population to be in the 26 cities in extremely high-risk areas. And these 26 cities are almost exclusively coastal cities. Nevertheless, it's not all bad news. Transformative adaptation can actually help us to accelerate implementation of the Sustainable Development Goals. We know we are receding on the implementation of the Sustainable Development Goals. Increasingly, climate-related disasters are impacting our ability to implement the goals, but we have estimated that if we invest 1.8 trillion globally in 5 adaptation areas over the next decade, we could generate $7.1 trillion in total net benefits. And early warning systems are a key component of this investment. It may sound a lot, but when we look at the percentages of this transformative adaptation under the 1.5 warming degree scenario, the highest in terms of average percentage of GDP is the Pacific, and it amounts to 1.42%. The Pacific includes Australia and New Zealand. And then where it's relatively less costly is in East and Northeast Asia, where it's less than 1%. So doable if early action is taken. Okay, so that's basically the riskscape. Now, in terms of our trust fund, as I think you all know, it was set up in 2005. This top part over here, 2005, set up after the tsunami hit. It was set up, we think, with a very generous and visionary contribution of the government of Thailand. They gave 10 million to the trust fund. Of course, Thailand was heavily hit by the trust fund, but for a country, developing country, that really invested in the trust fund to set up an early warning system based on South-South cooperation. It was visionary, it was generous. And since then, some of the key features, RHIMES was set up under the trust fund. This is the Regional Integrated Multi-Hazard Early Warning System for Africa and Asia. So it expanded to include the Indian Ocean, African countries. And then I think a little later on, 2011, we contributed to the operationalization of the Indian Ocean Tsunami Warning System. Srinivas was mentioning, a lot about that earlier. And then there was, guidance we got from our advisory council, because the donors to the trust fund are the ones who also determine how the trust fund should evolve, rightly so. They give the funds, they should determine the directions. And the guidance we got is that we should broaden, we should expand. Not only tsunami, because tsunami are infrequent. Of course, they're deadly when they occur, but typically every once in a century, these systems are expensive. Let's follow the multi-hazard early warning approach. So use one system, similar systems, end to end, to tackle many different types of risks and disasters. And then Japan joined the trust fund, and then Japan was interested in expanding the geography. So not only Southeast Asia, but also the Pacific Island countries. That was the main interest of Japan. And then I'm also pleased to inform you that in 2016, the government of India was very generous with us and contributed $1 million. And then that made India an advisory council member. And of course, India had an interest in expanding to the Makran subduction zone. And that's really under the leadership of India that we started the work on Makran. And very much, I think, something that we are hoping to take forward in the next decade or so. In 2022, Secretary General Antonio Guterres established the Global Early Warnings for All initiative. He wants early warnings to be available to everybody by 2027. Don't quote me, but I don't think it's going to happen. But you said the same thing, Sanjay. We wish it could happen. But the important thing about this global initiative is that it gave the momentum. It gave the political momentum. It mobilized the interest. It mobilized the action. It mobilized the attention. And so, you know, I think the story of this UNESCAP Trust Fund is that for over 2 decades, it has had early warnings at its center, and early warning for all is a key transformative adaptation initiative. And so this is really how we see the future strategic alignment of the Trust Fund. We see it aligned to the 4 pillars of the global early warnings for all initiative. The global one consists of 4 pillars: the disaster risk knowledge, then pillar 2 is detection, observation, monitoring. Pillar 3 is on the ICT, reaching the last mile of connectivity, and pillar 4 is on the response. So there we have indicated more or less how much the Trust Fund has gone into each of the 4 pillars. 17% for pillar 1, 33% for pillar 2, pillar 3, 16, and pillar 4, 34%. And then in terms of the achievements, I think we have being one of the contributors of the IOTWS. We have also the ongoing work on the Makran subduction zone. This year we have done a tsunami preparedness capacity assessment. So I think there's some good things that are coming out of this. There are a number of recommendations that have emerged. For example, the need to densify international seismic station networks. This, I think, is also part of further enhancing and further, accelerating the achievements of the Trust Fund. So, as I mentioned, the Secretary General's early warning for all, and then in terms of the recommendations, at the sub-regional level, one of the key recommendations is the eyes on the ocean. So we plan to have the Trust Fund focused on the eyes on the ocean. In my discussions with Commander Srivastava earlier in the month, we all, we agreed that we know more about outer space than we know about the depths of the ocean. So there really is a lot more work that we need to do in terms of real-time observation networks. And I'm really very happy that this smart cable initiative is now under pilot implementation. in the Andaman, Nicobar Andaman. So, you know, I've been in the UN a long time. And for me, the Smart Cables initiative was always almost like a no-brainer, right? If you can put environmental sensors in repeaters in cables, you can actually build redundancies for the buoys, which are expensive, they are prone to various vulnerabilities. And here, you know, you have thousands and thousands of kilometers of submarine fiber optic cable used for telecom. For relatively little extra cost, you can put the environmental sensors and generate a wealth of data, seismic data, acidity, water pressure, so many things. And there's a joint task force of the WMO, IOC, and ITU, led by ITU. The work has been ongoing for 15 years, I think. Much more should have been done by now. I'm really sorry to say. Why has it been so slow? I think it's the telecom operators. The private sector telecom operators. I hope there are none in the room. If there are, please identify yourself. We're going to run after you. Apparently, you know, what we're hearing is UNESCAP has been supporting this initiative throughout. We've done a lot of work at the intergovernmental level. So I like to sort of think we contributed a little bit to the initiative of the government of India, but it's all soft contributions. You know, it's just awareness raising, convincing, and so on. But I think maybe the momentum is building, because what I hear from the technical experts, and I'm not a technical expert, is that there is no disruption to the telecom. Because the telecom providers are very concerned that by putting environmental sensors, you may mess up, you know, their signaling system and their telecom, smooth flow of telecom communications. Apparently, no. But the real thing now is to do the proof of concept. So put down the cables, experiment with them. There is a Vanuatu to Caledonia cable that is under experimentation. Indonesia is investing in a big way, and these are all experimental. In Italy, we have a cable off the coast of Sicily. There's a cable off the coast of Portugal. So I think things are moving, and I'm really hoping that we will get some progress there. Community engagement in the medium capacity countries, I think more work can still be done there, and in the low capacity countries, there is still a need for more fundamental basic monitoring to be set up. So once again, I just wanted to end with the coastal ecosystems, because this is definitely going to be one of our key areas of work for the future of the trust fund. Large population exposure in South Asia in particular, economic stock exposure as well. But the coastal ecosystems really are critical. They are critical in protecting lives, in livelihoods, and then they also have a very important role to play in terms of carbon capture. Bluegrass has a much higher carbon capture potential than forests, land-based forests. And then they also offer nature-based solutions, the mangroves. Nature-based solutions that can absorb and reduce the impact of tropical cyclones, storm surges, coastal flooding and erosion. And we know that these are going to be on the increase. And South and Southwest Asia has lost 6% of mangrove cover over the past 2 decades as a percentage. It's highest in Bangladesh and Islamic Republic of Iran. But there are benefits that are greater than the costs if we focus on protecting the mangroves and enabling mangrove cover to do what nature has set out for it to do, which is capture the carbon and protect people and economic stock. Thank you very much.
Thank you, Tijuana, for a very brief presentation on the UNESCAP Trust Fund in tsunami preparedness. So, may I now request Pawan to take over?
Thank you. Thank you. Good afternoon, everyone. So, in this session, we are left with two more presentations. The first one is on the national plan, which will be done by my colleague, Mr. Naval Prakash. And then we will be having a tsunami-ready implementation plan by the states. But before I hand over the floor to my colleague, I just wanted to make two quick observations. As has been pointed out by Dr. Srinivas, the first thing, we have got 12 preparatory indicators in the tsunami-ready program list. So, and the states having their SDMPs and DDMPs, the states are here. I saw Gujarat, then Kerala, and Odisha. So, how states can inculcate those preparatory indicators into their SDMPs and DDMPs? Because if you want to make your community more responsive, you want to make your community more trained or more prepared towards tsunami, then it should be basically reflected, because efficacy of any plan can only be proved once it is tested. Unless tested, it can't be proved. So how it can be included in the SDMPs and DDMPs? Because Odisha alone, as I understand, has got 381 plus prone villages for tsunami. So we have only till now 26 villages or 26 communities. So how we can enlarge the program? So for that, I probably would request INCOIS to have more number of workshops, like what we had before we went for Nolia Shahi and Venkat Raipur in 2019. We had a major workshop with the states. All the states, coastal states were there, both on the western side and the eastern side. So that can be done, and then we can have more number of workshops. It can be done jointly or it can be done independently by INCOIS. NDMA will be ready to help. And one more important point which I wanted to make, which I requested Secretary MOES also, was how INCOIS, under the overall support and guidance of Ministry of Earth Sciences, can basically contribute towards the regional dimensions, regional settings. Now, every regional mechanism we have, be it IORA, Indian Ocean Rim, be it SCO, be it Quad, be it I2U2, any regional mechanism we have, all the mechanisms have disaster management as one of the major component to secure the blue water economy, to secure the infrastructure, to secure the economic interest of the member nations. So how it can be done, because recently this National Center for Medium Range Weather Forecast has been designated as the BIMSTEC Center. So that center also is coming up with a new dimension. So BIMSTEC can be a one area where we have got Myanmar, we have got Thailand, how we can more involve with them, because then it will open up the issues, having more interaction with other stakeholders, the civil administration, the armed forces, and the other players also, like what we heard with Dr. Radhakrishnan. He gave altogether different dimensions to the issue and how it can be explored. So these are two observations. With this, I would like to invite my colleague, Naval Prakash, to deliver the talk. Thank you.
Thank you, sir. In fact, my colleague had left me in a situation where I don't have to say anything. He has taken all the point. He has covered the policy dimension, the planning dimension at the very grassroots level, and how we can come together and take our plan to the international forum, whether it is IORA, it is BIMSTEC, or whatever front. So he has made my task very, very simple. But before I just talk about the National Disaster Management Plan, which came out in 2016 first, then we came out with the revised National Disaster Management Plan in 2019. I will just share one experience which I had in Hawaii. I got this opportunity to visit Pacific Tsunami Early Warning Center in Hawaii in February 2020, just before the COVID, I was there. So there, the head of Pacific Tsunami Warning Center, that was some lady, I'm not remembering her name. She came to me and she asked me, "You are from India?" Then I, of course, so he was all praised for INQUAS and Indian Ocean. Yes, yes. So that was really a proud moment for me, that in Pacific Warning Center in Hawaii, I'm having this appreciation of our center there. So with this, I would just like to start my presentation. I won't take much time. So usually what we in NDMA, we just try to say that, okay, we are so much vulnerable. Our country is vulnerable. So this is the vulnerability profile of various countries. We have just discussion about Haiti earthquake today, Chile. So, but yes, we are vulnerable. One thing I must say, all of you are sitting here, our vulnerability profile is changing. What we used to tell that, okay, it's, this much land mass is prone to earthquake, this much land mass is prone to landslide, all this vulnerability profile are changing due to anthropogenic activities. So, Wayanad is the recent example. We have created, in fact, in 2011, the World Bank came out with a very good book. The book title was Unnatural Hazards, Natural Hazards and Unnatural Disasters. So hazards are basically natural, but our unnatural activities have created a situation where we have termed that hazard into disaster. So these are some of the mandates. All of you are aware. So we basically come out with the policies, guidelines, plans, and even take some measures for prevention, mitigation, preparedness, and capacity building. We have also one arm, which is National Institute of Disaster Management, which is basically the capacity building arm of NDMA. Another arm is sitting over there, that is NDRF, that is the response arm of NDMA. So we have two arms, but our eyes and ears are INQUAS, IMD, NRSC, say all technical institutions are the eyes and ears of NDMA. We have two arms, NIDM, NDRF, but our eyes and ears are all the technical institutions in this country which are contributing towards the disaster management. They are basically the eyes and ears of us. So everybody talked about DM Act, the background of DM Act. Then in 2005, we had DM Act. 2009, we came out with the National Policy on Disaster Management, which is, I think, still a hidden document. I've talked to many stakeholders, many people. Have you heard about National Policy on Disaster Management? Then most of the time I've received the negative answer. No. We know that there is plan, but any policy is there, we don't know. But we came out with the national policy in 2009, and in that particular policy, we have focused the approach of community capacity building in that policy. So later on, we have several guidelines covering all the hazards, all the cross-cutting issues, and even some reports. And latest in 2019, we came out with the revised National Disaster Management Plan. We have several ministries and departments which can be termed as the nodal ministry for that particular hazard. So for tsunami, yes, the disaster is being handled by Ministry of Home Affairs, but the nodal ministry is Ministry of Earth Sciences. Similarly, for forecasting and early warning for tsunami, the nodal agency is NQuas. So I talked about this national plan. In fact, this is the first ever national plan. In 2015, if you recall, in March 2015, we came out with this, this world came out with the Sendai Framework for Disaster Risk Reduction. It was March 2015. And the next year, in June 2016, India was the first country. In fact, NDMA and India, NDMA put together all the agencies, and we came out with the first disaster management plan, which was completely oriented towards the Sendai Framework for Disaster Risk Reduction. And later on, this plan again revised in 2019. So what are the highlights of this plan? It's an all-inclusive plan which addresses all the 17 disasters, or rather I should say, I must apologize, I should not have written here disaster, it should be hazards. Addresses all 17 hazards, which includes natural as well as man-made disasters, be it forest fire, urban fire, or biological disasters, whatever you call, we have covered in this plan. This plan also focuses on mainstreaming all the sectors, all the stakeholders, and coherence within itself. And this plan also highlights the importance of capacity development, disaster risk governance, and international cooperation. This is an inclusive plan which includes time frames. This is the first plan which has given short-term activities, medium-term activities, and long-term activities. So our long-term activities, according to this plan, ends in 2030, which is the period of Sendai Framework for Disaster Risk Reduction. So by whatever we had in this plan, we are targeting to achieve this by 2030. So now coming to, as I mentioned, we have covered all the hazards. So what is there in this National Disaster Management Plan for Tsunami Management? Again, as you know, the Sendai Framework for Disaster Risk Reduction has 4 priorities. The one is understanding disaster risk. So we, as I told you, we have prepared our plan based on this Sendai Framework for Disaster Risk Reduction. So under this understanding disaster risk, which is the first priority of the Sendai SFDRR, we have enlisted some of the activities like research and developmental efforts, which needs to be undertaken under this plan, observation networks, information system monitoring, research, forecasting, and early warning. I think I'm in the safest place, which is doing all these tasks for NDMA, for the nation. Then zoning and mapping, again being done here. Dissemination of warning data and information, again being done here, and with some new initiative, as Dr. Srinivas told about CAP, that Common Alerting Protocol. This inquires early warning system has already been integrated, and I must say it was the first first service provider or first alert generating agency, which we call in CAP. But it was the first AGA to integrate it with this CAP platform. Again, hazard, risk, vulnerability, and capacity assessment, it is being done here. Then comes second priority of the Sendai framework for disaster risk reduction, which is inter-agency coordination. So we were talking, Tiziana was also talking about intergovernmental coordination. Here in this plan, we are also talking about intergovernmental coordination and inter-agency coordination. Within the country, we have several agencies which needs to be coordinated. And as I mentioned the mandate of NDMA, several items were listed. But I forgot to tell one thing. We in NDMA, we don't consider ourselves as National Disaster Management Authority. We don't consider ourselves as authority. We consider ourselves as a coordinator, as a facilitator between different stakeholders, between different ministries, between states, districts, whatever, all stakeholders, NDMA consider itself as a facilitator and coordinator. So overall disaster governance is also there. Then response part, because as Radhakrishnan sir was telling, responding to any disaster situation, it requires a tremendous amount of coordination between and outside different agencies. So organizing and coordinating central assistance, and it will be at national level, organizing and coordinating with central agencies. But at the state level, at the grassroots level, at DM district level, what Radhakrishnan sir was telling, in Nagapattinam, he must be coordinated with different agencies, whether it is central agencies, whether it is philanthropic institutions, or like this. So we have taken into consideration, and we have given due weightage of inter-agency coordination in our plan also. Next is the third priority is investing in disaster risk reduction as per Sendai framework. Here we have enlisted some of the activities in our National Disaster Management Plan for Tsunami. But most of the points, I must admit here, you will find for different hazards, some of the points or most of the points are overlapping. So we have investing in DRR categorized it into two parts. One is structural measures and another is non-structural measures. For structural measures, strengthening of lifeline structures and high priority buildings, implementation as per recommendation of safety audit, and so forth. And at these blue points are basically for the states. So implementation in compliance with relevant building codes, states have to do it, and collaboration with technical agencies and implementation. For investing in DRR non-structural measures, basically mainstreaming disaster management into developmental planning, what Dr. Pawan was telling, regulation and enforcement of relevant laws, techno-legal regime, non-structural source stabilization measure, all these activities, since I put it in blue because I consider that all these activities needs to be done at the grassroots level. It is district level, taluka level, and guided by the state governments. And last slide also, and last priority of this Sendai framework was capacity development. So since morning, many things have been talked about the capacity development. So I won't take much time, but I'll just read it out. Training and capacity development of professionals is also important. Since morning we were talking about training and capacity development of community, but training and capacity development of professionals is also very important. Curriculum development at the school level, colleges level, universities level, awareness generation, mock drill, mock exercises, documentation, what Dr. Radhakrishnan was also talking about this. Documentation of any activity, any project, or even any incident is very important. In NDMA, we had several projects. We are running CAP, we are ERSS. We had Abda Mitra scheme, but we are not focusing on documentation of those projects. If we focus on documentation of those projects, we can have some lessons to learn in future. Then empowering women, marginalized, and persons with disabilities. Here, on this point, I would also focus that all these tsunami-ready communities must take into consideration the third bullet point, persons with disabilities. Yeah. No, no, so, persons with disabilities, you must take care of this aspect. In fact, in 2019, NDMA also came out with a guideline which is called Disability Inclusive Disaster Risk Reduction. The guideline is there. So if state governments and district administration take into consideration while going for tsunami ready, or in fact, yes, it is very good that we are going for tsunami ready program, because this, if we are tsunami ready, I'm 200% sure. If any community is tsunami ready, he can withstand any other disaster. Because tsunami gives you the least lead time, any other disaster like cyclone or even so-called floods, except earthquake, of course. So if any village, any community is ready with tsunami to mitigate or to fight with tsunami, he can withstand any other disaster. So with this, I think last point I've covered the first, and in fact, Dr. Pawan has also highlighted that international initiative and multilateral forums, we should take our initiatives to these levels also. Thank you very much.
Thank you, Mr. Noel. So, in order of their mention, I invite the states to present their tsunami-ready implementation plan. So, do we have the state of Kerala? Yeah, please.
This one.
Yeah, good afternoon. Myself, Pradeep. I am hazard and risk analyst from Kerala State Disaster Management Authority. And as far as the Tsunami Ready program Kerala is concerned, we started long away from 2022 itself. That time we gave training and capacity building, mock drill, etc. And right now in 2024, we have 9 coastal district, and we selected 9 coastal Grama Panchayat for implementing the Tsunami Ready program. These are the 9 coastal Grama Panchayat. And the selection is purely based on the coastal susceptibility and the historical data. So I think you know very well that we have 12 indicators to fulfill for the Tsunami Ready. So based on that 12 indicators, we chart out a detailed plan starting from planning phase to mock drill. So one of the most important thing is that apart from these 12 indicators, we also take NDMA, school safety, hospital safety also, and we give a training and school and hospital safety plan also updated. Then one more important thing is that the third state-specific factor is the local self-government DM plans. So 2018 extreme weather event, after the 2018 extreme weather event, we already prepared local self-government level DM plans. We have 1,036 local self-government institutions, including Panchayat, municipality and corporation. Every local self-government have now DM plans. So we updated these 9 coastal Grama Panchayat DM plans also during this program. Then another important thing is that we always believed in community-based disaster risk reduction. So apart from SDMA and DDMA, we also included community-based participation, which is like, say for example, fire and rescue is the first respondent as far as the state is concerned or disaster is concerned. But within the fire and rescue service, we have civil defense and Abda Mitra. So that also included. Then coming to the Grama Panchayat, we have ERTs, RRTs, etc. And each and every ward we have emergency response task force, even 10 persons is there. Then again, ward members also included. Then we have a 13th working group is there for the climate change, disaster management, and biodiversity, that also included. Then we also participated, we have a very good system in IAG, interagency group, and that also NGOs and are also part of this program. Then local club like Karayogams, then church committees, again Anganwadi, Kudumbasri, ASHA workers, MGNRGA, etc. Then academicians, research institution, etc. also included to fulfill this Tsunami Ready program. So for the implementation of the PRA, we identified 3 universities, 1 college and 1 training institute, Kerala Institute of Local Administration. These 4 institutes are working together for the PRA activities. Then these are some photographs. We started our this year Tsunami Ready program from the May onwards. We did a state level stakeholder consultation, NDMA representative inquiries, then SDMA, then these 9 local self-government, Panchayat, President, etc. were participated. After that, the stakeholder consultation meeting, we conducted pre-planning meeting in the 9 Grama Panchayat itself. That is on June, July, we completed pre-planning meeting. These are the dates and locations where these pre-planning meeting were conducted. So again, this is I already told you that we already identified for 3 universities, 1 college and 1 training institute for the PRA. So we did a detailed consultation meeting with all those institutions. These are the photographs. Then we prepared 3 detailed documents. One is for school safety, another is for hospital safety, and local self-government disaster management plans. These are some pictures for the hospital training programs. These are some photographs of school safety training programs. Then, based on these trainings, we prepared a school safety training report, and I think that report already communicated to the NDMA. Then I skipped the aim of the project. Then they developed the project based on the four basic pathways. One is tsunami inundation mapping. That tsunami inundation map we already got from INCOIS. So based on that map, we went into the field, and now the evacuation mapping is almost completed with the help of already I mentioned 4 institute. Now the tsunami response planning is on board, and that is also almost completed. And tsunami mock drill, we already completed 3 Grama Panchayat, we already completed the tsunami mock drills. So when we consulted the pre-planning meeting, we understood that they need some handbooks in Malayalam. So based on the manuals, that 72 and 82, we consolidated the major things, and we prepare a manual, and that is published in Malayalam and regional language, and we distributed to the each and every stakeholders. And for the UNESCO, we just translated into English also. So these are some signages we prepared for this program. See, look, we have a large migrant laborers, and we have a lot of tourists came there. That is why we put all those signs in Hindi and English also. So this is some photograph for the planning meeting, field level interactions. Then briefing about the TEP and TEM preparation. So this is what the final updates. See, we have a little bit issue during August to November. I think you know very well that we received extreme weather events and leads to some landslides, major landslide in Wayanad and Calicut. So a little bit delay is there, but anyway, we will complete our entire task before February. That is the recent update. So this is the district-wise update. I think due to time, I skip all those things, sir. These are the newspaper reports about the program. Yeah, thank you.
Thank you, Kerala. Do we have Gujarat?
Good afternoon. This is Dharmik Purohit from Gujarat State Disaster Management Authority. Recently in September, we got our state level meeting within COIS to how to implement this in our Gujarat state. So initially we selected 2 districts. First in Okha, it is in Devbhumi Dwarka. And second is Pingleswar Beach. It is nearby Abdasa block. It is in Bhuj district. So initial stage, we doing meeting with the district collector, with the board district, and also the branch officer with additional collector of that Tahsil, that block. And we are implementing that the tsunami preparedness program in that 2 villages. We also done the training program of villagers, awareness program, also giving first aid training, search and rescue training, also evacuate map of the 2 villages, and also how to identify shelters and all that. We do 2 mock exercise in last month. And now Gujarat State Disaster Management Authority trying to implement 40 more villages to prepare this TRP program. So this is from Gujarat side. Thank you.
Thank you, Gujarat. Odisha again we will be having? No. Odisha we have done, no? Okay. Please. Yeah, sure, please.
Thank you very much. I will be taking less time of speaking and so more time of showing something which we have done, because ultimately disaster management percolates down to what we have done. So we have already made 26 villages tsunami ready, which has been certified by IOC UNESCO. We have prepared a small documentary film on this for benefit of all, because me speaking a lot of things you could see in your eyes, and INCOI's team was along with the IOC UNESCO team was there in Odisha. So I will take 6 minutes of your time to show it. Then I have 4 slides to share, and some of the critical things I will be correlating with our prophecies and what is going to happen or may happen, and I will be seeking your technical advice on that, because there are certain very interesting episodes why Odisha and Andhra Pradesh coast were not affected in 2004 tsunami. So please run it. This one.
20 years ago, on 26th December 2004, the world witnessed one of the worst marine tragedies in history, the tsunami. Giant tidal waves caused by a devastating earthquake in the Andamans and Sumatra subduction zone of the Indian Ocean region swept across the coast, killing over 10,000 people. The disaster was a major lesson for nations along the Indian Ocean. In an effort to save humankind from such disasters in the future, the Intergovernmental Tsunami Ready Recognition Program. As part of the program, the Indian National Centre for Ocean Information Services, INCOIS, under the Ministry of support to coastal states of the country to make them tsunami ready. India is the first among the 56 countries in the Indian Ocean region to implement the Tsunami Ready program. As you all know, Odisha, a role model in disaster management, is also the first tsunami ready state. In the year 2020, 2 coastal villages of Odisha, Venkat Raipur in Ganjam district and Nolia Sahi in Jagat Singhpur district, were recognized as the first tsunami-ready villages at international level. Odisha has a sprawling 480-kilometer long coastline. There are 381 villages and habitations located within 1.5 kilometer of the coastline spread across the 6 coastal districts in Odisha which face the threat of tsunami. In an effort to make these villages and habitations tsunami ready, Odisha State Disaster Management Authority is laying emphasis on the required preparation, building the necessary infrastructure, effective use of local resources, use of the latest technology, and empowering the community time and again to save the lives of the people residing within that community. The Tsunami Ready Recognition Certification, as conferred by UNESCO, is given based on the 12 indicators set by UNESCO. Soon after receiving the tsunami alert message from INCOIS, the State Emergency Operations Center at the state level gets activated and it passes the alert messages to District Emergency Operations Center. Besides, alert siren towers have also been installed at 122 locations along the coastlines of Odisha, which alert people living in the nearby villages within 1.5 kilometer of the coastline about the threat of impending tsunami. After receiving the warning through alert siren, the people living along the coast are evacuated to safe shelters on their own and by the help of community volunteers or community tsunami champions as practiced during the tsunami mock drill conducted from time to time. The travel time of Tsunami to Odisha coast is around 3 hours. To complete the evacuation process within this short time, OSDMA is emphasizing community-based preparation and planning. Volunteers from village help in identifying tsunami-prone evacuation routes for safe and quick evacuation and conducting awareness programs on tsunami and alert sirens. A thorough analysis is done on the people at risk, which includes vulnerable population like women, children, older population, people with disability and critical infrastructures beforehand. Utmost priority is given to the rescue and evacuation of these vulnerable people when a tsunami warning is received. People are trained in such a way that they can move to safe shelters using the pre-identified evacuation routes within minutes of a tsunami warning is received. Every tsunami-ready village has a pre-designated safe shelters. The local people and school children are made aware well in advance about the science behind tsunami, the magnitude of devastations it could cause, and also on safe evacuation routes. Tsunami signage boards have also been installed. Tsunami IEC materials like posters and wall painting have been displayed at various places in the villages. The aim of the state government is to ensure zero casualty. OSDMA is fully prepared to fight the menace of tsunami using technology, planning and educating the community. Constituted in the wake of the devastating super cyclone in 1999, OSDMA has set an example in disaster management. The preparation and mitigation plan put together by OSDMA has earned Odisha a name as Tsunami Ready State. 24 more villages in the 6 coastal districts have been added to the list of tsunami-ready villages recognized by the National Tsunami Ready Board. OSDMA is committed to make all the 381 villages and habitation as tsunami-ready communities. This effort will undoubtedly set trend for other coastal states to follow the path in saving lives and property and get their community as tsunami-ready communities.
Yeah, thank you very much for your present watching. One thing just I want to add, the pictures, situations, buildings, routes, people of the Mitra volunteers are not stage managed. They are all existing in life and in flesh and bone and have been operating for the last almost 20 years, what we have shown here. When the team visited there, our people, even school children, they explained to the community, to the scientists about the geology associated with undersea earthquake causing tsunami. So thank you very much, Dr. Srinivas, for your cooperation and inquiries. I am really indebted to you. I was, in the morning I was trying to say, a national level institution has gone to the extent of going to the field, interacting with the community, and telling them what we are doing. So that's what inquires is. Thank you, sir. Thank you very much for this. So, sir, it has a very 4 slides only. I will only cover. Already we have identified 381 villages along the coastline of Odisha, which is 480 kilometers. and we have identified them within 1.5 kilometers, because that is the 2004 tsunami we saw in Tamil Nadu and Kerala. That is the maximum extent water had gone there, bearing the estuarine river systems. So we have identified 381 villages along the coastline to be tsunami prone. So we have prepared the GIS maps of all the 381. After 381, we have covered 26. This year we have kept the target of 100 more villages to be declared as tsunami ready. So these are the 6 coastal districts, and we'll be doing the plan. Phase 1 we have done, 2 plus then phase 2 we call 26, 24 more. Then we will be doing rest in the coming month, because this is the area where we have identified. But out of the 480 kilometer coastline, there are many areas which are covered by reserve forest. Technically, we don't have habitations there, but we will try to identify habitations there existing, and we will try to cover that. That will increase the number to some extent. This is the phase 2. And that is the phase 3 we are planning, 100 villages by December 2025. Villages selection already in process, and it will be done in next 15 days time. Hazard zone mapping will be there already. Our village disaster management plans are available for all the coastal villages, so that won't be taking much time to identify the hazard zones. And we have already planned out the time frame to take up step 1, 2, 3, 4 stages and cover all the 12 indicators. This time it will be much easier. I think we have learned the tricks of the trade and try to convince people to do that. People are oriented, because already for last 25 years we have been conducting mock drills time and again. At least for 25 times each villager has gone through the mock drill himself or herself, from the children to the elderly persons. So it will be much easier on their part to understand what disaster management is. This time the cyclone Dana was there, and our though it was not a very high intensity cyclone, but our evacuation was almost 8.5 lakhs because we did not want to leave anything to chance, and people cooperated. Even if in some places we had to use some hard coaxing, but there was no iota of any resentment from the people, because people of Odisha, they know that when we ask them harshly to evacuate, we are trying to protect their lives, so they don't get angry with us. So that is our strength. And once again, I thank INCOIS for all the cooperation. My point, last 1 minute, sir. Mahapurush Achyutananda, he is a great professor, prophecy-making personality, like Nostradamus, much before that. He has written one book called Malika, that is predictions or prophecies for the future. In vernacular Odia, it is written, Uttare sajibo, dakkhine gajibo, purbe n rahibe kehi, charo bar dhari je kehi rahibe, vihano hoibe sahi. The exact translation is like that. Uttare sajibo, dakkhine gajibo. North will be heavily rained, south will be again devastated. There won't be existing anybody in the east. He has taken perhaps the geographical position of Odisha. Whoever will survive will be the seed for the future. That is his. Another connotation is Baisi Pavache Mina Khalive. If anybody of you have seen Jagannath temple in Puri, there are 22 steps from the Singhadwar to the platform where the main building is standing. There are 22 steps. It is almost on a hillock. The prediction is fish will swim on the 22 steps of Lord Jagannath's temple. Puri is not a very high flood prone area, so far Puri city is concerned. So we are anticipating extending our imagination that it could be a very bad tsunami that will be resulting to this type of phenomenon. So we have converted all the cyclone resistant features into tsunami preparedness measures. The cyclone shelter, the cyclone siren systems which are implemented under NCRMP, National Cyclone Risk Mitigation Project. National Cyclone Risk Mitigation Project. And now they are being used for tsunami, because we know that cyclone we have 5 days time, tsunami we have only 2 hours. My question to the scientific community, in 2004 tsunami, the genesis point was known. Out of the total eastern seaboard of India, the West Bengal coast, Odisha coast, and 50%, north 50% of the Andhra coast was not affected. We have tried to get this answer, and some of the answers we have received, but I will like you to explain why this happened, because tsunami waves were also coming even up to the western coast of India. They have gone, they are affected. So I will be happy if I could highlight some of the technical aspects. Thank you very much for your time and patience.
No, Kamal sir, thank you very much for your presentation film. It was very educative actually. And your question, I just wanted to answer very briefly actually. So that's the whole reason we need to actually do a proper, the process of hazard assessment itself. You have to be, very methodical with how we kind of identify those sources and then address those sources. The Banda Aceh earthquake, the starting point was actually off Banda Aceh, and then the rupture actually propagated towards the north, which is about 1200 kilometers actually. So it actually stopped somewhere around Andaman Nicobar Islands. If you've heard, so the directivity or the nature of the rupture and then the directivity, that will actually decide which way the tsunami waves propagate, which is the maximum, direction of the maximum energy. So that was the reason, it actually hasn't impacted every coast in an equal way. That's one part. The other part is actually also on the coastal area itself, the coastal bathymetry and then the coastal, geomorphology also decides, once the tsunami reaches a particular area, what will be the impact of that. Like for example, Banda Aceh, very close to the source, tsunami waves were close to 30 meters in certain areas. But even in equally closer areas, it was not 30 meters. Now that is defined by the coastal geomorphology and the coastal bathymetry. And you heard in the morning Dr. Sailesh Nayak mentioning actually the Myanmar, the Burma actually an arc which actually runs until, north of Andaman. Now that's something which is not known to have ruptured, very, lately, in the historical kind of, past. So if that is something which ruptures, then the directivity of the waves may be totally in a different direction. Similarly, Makran, the project that we are doing, together with UNESCAP, IoT WMS, INCOIS is a big part. That is trying to assess what is the hazard that is possible from the Makran, because the last event was in 1945. So after that, actually, what is the maximum earthquake that could be triggered, and then which part? That part is actually in 2 sections. East and the west. So a lot of hazard assessment studies are required to really assess, what will be the impact on which part of the coastline. So this is what I would say.
Thank you. I'll be happy if
Of course, Mishra
Thank you.
I think you have already covered that. Yeah. Another part is the bathymetry and relations of the topography. Yeah. It was different in, you can say, in the southern part and the northern part. Even if you go for the Arabian Sea and the Bay of Bengal lock part. So that was actually acts as a triggering of the wave. So suppose just like you are standing here, water is coming and there is a barrier, then water tries to push up. So there is a lot of barriers in the southern part, but there is no barrier in the northern part of that. That's why the Odisha coast, even your Maldives also. You can ask that why Maldives there the wave was not propagated. Though it was in the very closer to that, but it was propagated little bit to the Sri Lanka. So I think it's right. Directivity is one thing and topography of the ocean bottom is one of the aspects.
Thank you. I think due to paucity of the times, we are not going to take any more questions. You would like to? Okay. We had 3 presentations, and we have also TR plans from Kerala, Gujarat, and Odisha. So the first talk by Dr. Srinivas Kumar has mentioned about Ocean Decade Tsunami Program, which is part of UN Ocean Decade, that is Ocean Decade for Ocean Science for Sustainable Development. ODTP is part of that one, and I consider it as a once-in-a-lifetime opportunity, because since morning we have been reflecting on the progress, the gaps, and the challenges. Now this is an excellent opportunity where ODTP has taken the gaps. They have the scientific committee, which is chaired by Srinivas. They have considered all the gaps, the challenges, and they have come up with what should be the main objectives, and what are all the things that we need to know, the opportunities. So the main objectives are like, as part of ODTP, we are going to have actionable and timely warnings. To provide that one, we need to adopt the new technologies in addition to what we have right now. Now I think India, now we are planning to have the smart cable observatory. That is one thing, and also we are going to enhance our coastal sea level network. We're going to expand the tide gauges, and also we're going to have the GNSS. That's what I think we are going to adopt the new technology. He also talked about other technologies like using the remote sensing, and also some other new technologies that are coming up, and also for data processing, AI, ML techniques, and other things. These are the things that probably we have to look forward to address these gaps and challenges. And another important objective is like identifying the communities at risk, 100% communities at risk, and prepare them to meet this, the tsunami ready things. That again, you have witnessed today that Odisha has been in the forefront to implement this tsunami ready program. Again, we are the first. Odisha is the first in the country, and India is the first in the region where we have implemented, and the number is quite big, and I'm sure with the kind of numbers that Dr. Kamal Mishra has mentioned. Now again, as I mentioned in the vote of thanks, that it is going to be an exemplary modeler for other states to adopt this TR thing. So again, this is a wonderful opportunity which Dr. Srinivas Kumar has mentioned about ODTP and its objectives, and also now pitching some of the activities where these nations are taking as part of ODTP program, which now I think INCA has already submitted our cabled observatory as part of this ODTP, and we will be coming up with more activities. And the second presentation is by Tiziana. She has given a brief on the UNESCAP trust fund, various activities, and addressing the all 4 pillars that have been identified as early warning for all. I'm glad to see that now they are looking towards the multi-hazard early warnings. Again, I can say that INCA has already started providing multi-hazard early warnings, but you also mentioned that now you are looking into the climate, which is, so I'm happy to mention here that Government of India has launched Deep Ocean Mission. There is one vertical called Ocean Climate Change Advisory Services, which INCA is leading. Probably that's out now. We are going to add this element into the now the multi-hazard early warning framework, like including the climate resilience and other things. And of course, as Srinivas has mentioned, now India is an active part of understanding the risk in the North-Western Indian Ocean region, where we have this Makran subduction zone probabilistic hazard assessment, which we have done with the help of ESCAP projects. We have successfully completed 2 phases, phase 1, phase 2A, 2B, and 2C is almost in the final stages. And again, as is mentioned, now I'm the new chair of the IOTWMS, and now we have completed the capacity assessment of the member states here, and now we are going to come up with the plans and midterm strategy. And definitely now we are also thinking of submitting a 3rd phase proposal, that is particularly for implementation of Tsunami ready. That where we are going to have again ESCAP supporting these member states from this region. And then 3rd presentation, Naval Prakash has mentioned about the National Disaster Management Plan, and the new one, that is the revised one, 2019, which he has mentioned policies. And again, I'm happy to see that the one important thing is community capacity building, which he has mentioned. Of course, he also mentioned about the tsunami related things in the National Disaster Management Plans, and probably member state, the coastal states which you are going to implement these programs, probably should consider these things. And the final thing is like, we have this tsunami ready implementation plans by 3 different states. Kerala, I'm happy that now they have almost, they're in, I think, finalizing that one, and we are happy to see that now quickly we come up with the submission your proposals to the national board, and then hopefully we'll see that now Kerala will be the next state to implement this. And happy to see that Gujarat has plans to implement these things in 2 villages, and INCAIS is there to support whatever the technical requirements that are required from Gujarat. We are always there with you, and we would also like to expand this TR program in other communities too. And of course, you see that plans of Odisha, where in a phased manner they are moving. They're going to have 100 more villages. But the ultimate thing is that now we had November 5th, I think, we had a meeting in Odisha. State government chief minister himself has mentioned that the entire coastal villages will be made tsunami ready. Is one very welcome initiative that definitely it is going to impress the other coastal states to follow Odisha, and then probably I think we are going to achieve the important objective, that is 100% at-risk communities will be tsunami ready. I think these are the few important points from this session, and I would like to thank all the speakers as well as my co-chair Pawan for successfully completing this session in time. And again, thanks to all of you, and now go back to Sunanda. Thank you.
Thank you, sir. Now we'll transit to the final item in the agenda, the panel discussions, focusing on actionable recommendations for advancing tsunami preparedness and risk reduction. So I request Tijana to be here, please, and Director Srinivas Kumar, Dr. O.P. Mishra, sir, please join us, and Professor Balaji Ramakrishnan, sir, please join us, and Kamal Lochan, sir, please be here. Yes. And Pawan Kumar, sir, please be here. And Dr. Balakrishnan Nayak, who will be moderating this. I will change this.
These panel discussions will be it is not that we are presenting, we are requiring some kind of a very actionable advice from these experts who was actually as a part of this program from the today morning onwards. So this is mainly required to make a document for implementation of our disaster, the early warning systems and the multi-hazard ready communities. So this is actually a kind of a plan for our actions. So, we have different stakeholders from here, from scientists, administrators, community leaders, all those. So we will be first focusing with the administrators. We'll go to Dr. Kamal Lodge and Mishra Saab. Sir, actually this capacity building at community level is a critical aspect of disaster preparedness. What measure can be taken to ensure that local knowledge, especially the traditional wisdom, is integrated with the modern disaster management practice? You have heard that the survivor from Andaman, he was mentioning some of these aspects actually. What is your opinion on this?
Thank you very much. There is a disaster subculture available in every community. And that disaster subculture has developed over a period of hundreds and thousands of years. Administrations many a time ignore that. We have not tried to commit that blunder. So my suggestion to all my fellow administrative service officers, we have to take into consideration the disaster subculture that guides their food preparation, their capacity building, their anticipation, and also their very inherent gut feeling of meteorology. So we want to preserve it, and we have tried to preserve it in our capacity building programs. Whenever we take up any training and capacity building programs, we try to identify their problems with their wisdom. So they make it more, that makes it more understandable to them. This is number one, sir. Number two, it is very easy to teach a village person who is not so much literate. The maximum problem lies with the literate persons and especially the officers who are working in government and the intellectuals who are operating in the political field. Since this is an intellectual discussion, I dare to speak certain things, which I hope will not be quoted outside this auditorium. So that actually, it becomes tough to train them. But they are the persons who are to train. Unless they understand, that will not be percolated into or translated into action. So capacity building, we have divided into different sectors. One set of activities for the officials who are operating at different levels of administration, policy making, mid-ranking, and of course the lower level. And another complete set of training capacity building programs for community members. We have already trained persons in Abda Mitra nomenclature or civil defense or in community volunteers, they are trained. Another third is the professional response forces, that is Odisha Disaster Rapid Action Force, Fire Service, Civil Defense, and of course NDRF is already, they are trained. So in these three different verticals, we have our programs, and each vertical has its induction type of course, specialized training, and refresher courses. And you will be happy to know that for ODRAF, we have created one skill matrix, a very simple numeric skill matrix, which was identified as one of the potential regions for awarding OSDMA ISO 9008-2008 certification. And DG NDRF had appreciated that, and he has taken that skill matrix. That skill matrix is like this. We have identified different disasters, like relief line clearance, medical fast responder,
collapse structure search and rescue, like this, in 7 different parts. Each skill set has some identified machines. And each constable or the order of Jawan is required to be trained in each type of equipment. So that skill level, his skill level is classified into 0, 1, 2, 3. 0, he doesn't operate. He doesn't know how to operate a machine. It's always a man-machine combination. So 0, he doesn't know. 1, he can operate with somebody's assistance. He cannot operate it alone. 2, he can operate alone. 3, he is a pro. He can operate it alone. He can repair it. He can take up minor repairs in the field himself. So he knows the machine as his bone and flesh. So in these 4 levels, so we have classified that in each boat, if somebody say inflatable rubber boat is sent for operation, there must be 1 3-level official or Jawan. 1 3-level, maybe 1 2, 2 1. 0 should not be sent. So we know who is having this what level. We have pre-disaster, pre-training assessment and also post-training assessment. So in that way, every Jawan's skill set is known. So in that way, we have tried to develop it.
Thank you, sir. Thank you. We have one more question for you, but because of specific time.
No, sir, I can one more two questions and then I can.
Okay. Sir, actually then, the next question is how can the Tsunami Ready program be effectively integrated with the existing disaster management initiative at the local level? I think you already answered that in your presentation, but I think you can.
Actually, we are in the process of integrating the disaster management plan at the Gram Panchayat level in the development plan of the Gram Panchayat. Because as per the Indian Panchayat Raj system, every Panchayat has a Panchayat level Gram Panchayat development plan. We are now trying to integrate that disaster management plan into a development plan. So every Panchayat has some villages, and some villages may be having some habitations. So those the tsunami ready activities are now becoming already they are part of the village disaster management plan, and also they are going to be made a part of the GPDP, Gram Panchayat Development Plan. So that will be institutionalized and documented, and that will be playing a part in the future.
Thank you very much. So next we will. Next, we will go to Dr. O.P. Mishra, Director, National Seismology Center. Sir, actually, how has the seismic monitoring for tsunami early warning system evolved over the past 2 decades?
I think 2004 when tsunami happened, Geological Survey of India is the only government authorized institution to visit that, because Andaman, Nicobar and everything was under control of GSI. And I was in GSI, just returned after Japan. I came and joined as a project leader and found that there is only 1 analog station in the Andaman. That is in Port Blair, now called as Sri Vijayapuram. From September 2024, the name was changed. And that analog equipment was erratically recorded all the noise. And there was the panic because we are dependent on the only the USGS data and the other IRIS data. But IMD has taken in that time Sasmo group was under IMD of the MOES. They took a strong step, and the 3 days they converted it into a digital station. That is only 1 station. You will be really surprised to know in that time there was only 62 stations in the entire country. And entire coastal areas, coastal states of the country have a total of 6 stations. Total of 6 stations only. And now after the 2004 tsunami, there is a drastic changes that country network of the seismographic network as well as acceleropgraph changed from 62 to 168. And in that time they are all analogs, now there is all digitals. In that time only the monitoring was done in the manual, but now it is the VSAT real-time monitoring. And we have now, in that time only 1 station in Andaman Nicobar, now we have this total 5 stations in Andaman Nicobar, Tamil Nadu 7, Andhra Pradesh is 6, and Trivandrum has 3. And again we are increasing. So there is a lot of the enhancement, densification of the network of the country as well as in the coastal belt, and round the clock monitoring taking place. And you know that INQUEST is our very important partners, that where we are required the data, we are keeping the data in a dual system, that our data and INQUEST data we are working together, and locations wise, algorithm wise, authenticity wise, there is no also the wrong detection and wrong location of the earthquake, particularly in these 5 years, you can see that. So this is a lot of the leap and bounds improvement in the installations of the equipment observation systems. And not only that, algorithm, that is auto locations program, we are giving the information in the hours, but now we are able to give the information in 2 to 5 minutes. So this is another achievements. And also we took a lot of the catalogs of the data in the phase data given to the public. There is a lot of the, now the researchers using our data, even the USGS consulting all the Indian continental earthquakes informations from the NCS site, from the Ministry of Earth Sciences. So this is another success story. And a lot of the data has been given by aftershocks monitoring. People wanted to know that whether another tsunami will come or not. In that time we worked hard and we installed the temporary networks. In that time 10 stations given up to the Indira points, and we given the stations locations of the earthquake was very tedious because all the stations are in the line. So you cannot locate the earthquake if your station is in the line. It should be a cordoning of the earthquake. So we did a special technique what Japan I developed in my DSc, that is called SP minus P phase technique, and then we take the 3 station technique. It was as accurate as the OBS. So you can find out that how, and then we determined the magma chamber depth of the Barron, and we predicted that in 2005 March, that if cycle of aftershock taking place, then there is the eruption of the Barron, and it happened in the June 28. And that's why the team of mine and my work, they got the National Mineral Award. For that, it was really very good science, we have done it. And Rangat volcanic mud volcano eruption taking place. The people are afraid that whether this mud volcano will going to be there or not. We monitor it and then give the information that this can be a boon for the oil and gas reserves. Then ONGC is now exploring, and they found that there are the symptom for the presence of the gas and oil reserves there. So there is a lot of the seismic instrumentation, inferences and locations there.
Sir, one more question for you. What are the challenges and gaps still need to be addressed to enhance efficiency? If you go to this INOPS lab on top, you get today our Minister Saab also was asking, there is some black the triangles. It means that some of the seismic stations are not functional. So how will actually, what is your plans for enhance the efficiency actually on this?
Actually, that is a very challenging task. Actually, in the morning, Dr. Srinivas Kumar has told that in our cases, there is a locked zone in the Makran or in the other shoulder in the eastern part. And we know that this is the locked zone going to do. And most of the tsunami occurred in the Indian Ocean by the thrust faulting or reverse faulting. But the challenge is that how to do the proper accurate location of the source depth, and it's the radiation pattern, means it's fault mechanism. Because the false alarm given by the tsunami, Pacific tsunami warning or Japan, when I was in Japan tsunami system, when I worked up to there, we found that they are the magnitude based their warning. But in our cases, there is a lot of the parameters, right? Yeah. So all the thrust fault and all the reverse faults of the magnitude 7 is supposed to give the tsunami-genic behaviors and all. But if it was the strike slip component more, and if it is even in Japan you can see the normal fault, there is a tsunami in Toki, Sendai Oki earthquake. There is a 7.9, 8.1. This is the normal faulting near out of the trench, and there is tsunami. So we have to have now challenging tasks of doing the imaging of the seismic tomography of the each and every locked zone, that how it is really locked or not. In Makran coast, I am already doing the research. If you take, I have no chance to see you the slide, but the slide clearly says that the series of the moderate or the micro earthquakes has occurring in the Makran coast. And if you take the summation of the energy budget, it will be equivalent to 3 times of the tsunami-genic earthquake. So that means the leakage of the stress is taking place in already locked zone of the Makran. That is one important point. Second point, if the Martaman basin there in the Bay of Bengal going to the top, and you can see that is also a locked part when syntactic zone is joining to Himalaya. That is the more dangerous, as Shailesh Nayak was telling. we are also using the dense seismic network challenge that we have to do the dense network to find out how big asperity is there. What was the source dimension they can use to broken and what type of the energy release for tsunami and all. These are the actually challenging of the imaging. Second, as you were telling that all the cables patterns are there in the suboceanic, but at the same time we need to have a permanent OBS stations because location of the earthquake in the suboceanic earthquake is very important because you cannot locate the remote stations on the land and earthquake occurred in the ocean outside of the network. Its depth location was very, very poor. So that's why sometimes we cannot get a bouncing point like the SP minus P depth technique. That's why OBS control is needed. So my suggestions is that each and every places of the Bay of Bengal and Arabian Sea means Indian Ocean, we choose some locations to put the OBS so that we can have proxy on the master location that earthquake source depth as well as its magnitude correctly. So these are the actually challenges, and I think we are able to do that. Continuous monitoring around the corner with all our coordinations between INCOIS and all. Whatever the stations of the GNSS there, each and every stations of GNS must be associated with the seismograph 3 component because we have only 5 seismographs in the Andaman Nicobar and that is not sufficient, and you have 32 GNSS stations. So we want to put the GNSS station co-located with your strong motion seismograph as well as your seismograph. These are the challenges I think taken care, and more extensive work can be done by INCOIS and NCS.
Okay. Thank you, sir. I think we will have collaboration. The next questions for the Professor Balaji Ramakrishnan. Sir, actually, what are the challenges in ocean observation technologies and what innovations are being explored to address the gaps for real-time monitoring?
Okay, good evening to everyone, and thanks to INCOIS team to have me on board of this panel discussion, first of all. It's exciting to visit INCOIS with a different cap. First time after I took over as director of NIOT, I'm visiting here. I've been here for a few times, but then I could see exhausted faces in front of us. So let's make this very short and crisp. I'm also a modeler, but then I always advocate that, observations, the in situ, actual observations are the backbone of any modeling, as simple as like that. So that means you need to measure continuously, irrespective of the the technology advancement in terms of the computational infrastructure and the modeling tools. Observations are again backbone. I think the modeling predictions are still requiring a large number of support from the in situ observation. So anything that we try to measure in the open ocean is quite challenging. I think by this time you would all be aware through the web portal informations, and NIOT is mandated to do the job. This is now part and parcel of our operational program. We have the responsibility of not only maintaining the mid-ocean wave buoys in Arabian Sea and Bay of Bengal, but we have also been mandated to do the deployment of the tsunami buoys, basically. So these buoys are exclusively to detect and also transmit the information about the tsunamigenic possibility of the pressure record changes and so on. So, yep. So the challenges are very simple and straightforward. Like I said before, anything that you would like to do in the open ocean is always going to be facing the open ocean challenges. And we have challenges in terms of technology. We need to design the battery life. These are completely off the coastline, far away from the coastline. Especially I'm talking about the tsunami buoys that I'm talking about. More than thousands of kilometers away from the coastline. They're independent, stand alone in the middle of nowhere. And you can imagine they'll be on their own. So you need to design, and they are going to be there for about at least a year unattended. So which means we go only once in a year to attend these buoys. So you need to design the battery life, I think the efficiency of the battery, how well we are utilizing. So, you need these data, right? Very critical data. It is unlike the mid-ocean data. This tsunami data is very important for us. You cannot actually compromise at any cost at all. So all of this goes into our design, right from the specification of the sensors, testing it extensively in our laboratory, and then we go out and deploy. And then apart from the battery life I'm talking about, there are sensors which are very crucial. I think it has been mentioned since the morning. The bottom pressure recorder, there is no way you can actually compromise the quality, and no way you can actually expect any failing of these sensors and so on. So all this quality assurance is guaranteed from our institution side, which means there is a stringent protocol that we follow. And that is already been in place, and we are improving all the time to see how well we can communicate that in quick time. I think the next question also I'll try to cover. I'll tell you that, Dr. Bala has already released the question yesterday. So I know the second question too. So, and by the way, so I think, we work towards the innovation from various fronts. One is that, how well the sensor technology can be improved, and how well we can utilize the latest state-of-the-art batteries so that, the time frame can also be expanded. And third one is, you can also talk about the the communication. I'm talking about the data. Once it detects, it has to go on a very high time resolution, communication to the base stations, both NIOT as well as INCOIS. And we are talking about the satellite communications. We used, of course, Inmarsat, and then we also thought of, INSAT. Our team has, in fact, now has a hybrid usage of both INSAT as well as Inmarsat. At the normal days, you use INSAT, and then on the other days, the emergency state, I think it actually switches back to Inmarsat and so on. So all of these innovations are actually happening in-house. And, in terms of the buoy side, I think we are working, I think this has already been mentioned by our secretary this morning. Now we started importing these bottom pressure recorders. We have our own indigenously, completely in-house designed, developed bottom pressure recorders. This is a crucial component of any tsunami warning system, and that has been indigenized now. So we have our own cabling system. We have improvised. We have innovated some kind of a communication cable system between the buoy as well as the BPR and so on. And probably I'm talking about, the new, innovative tsunami warning system that we are working on right now. These buoys, right now we have only surface buoys. Then the buoys will still be floating on the surface, and then it will be communicating to the satellite. But now we are working on an innovative concept where the buoy will be below the subsurface, below the water level most of the time. The moment you get the tsunami-genic signal from the bottom pressure recorder, the buoy will actually surface upon its own, communicate, send the signals, and then it actually roll back to its original position below the surface level. With that, we can avoid the vandalism, especially I'm talking about even the barnacles, being capturing all along our important sensors, the marine biofouling I'm talking about here. So all this could be minimized the moment you have the buoys rolling back to more than 50 meters of water depth from the surface, and then it can come up only when it is really required. But the demonstrative part was done, but then we are trying to scale it up to see whether it can be really deployed in the open ocean conditions and so on. Second question is also out. I know that.
Sir.
I'll talk about that. I think the cable network, I think I'm in for it. In fact, I am strongly supporting that. But there are some challenges I would like to address. I think these cables would be running, several hundreds and thousands of meters of water depth I'm talking about. So the sensors have to be, first of all, designed to accommodate these hyperbaric situations. The current tsunami buoy that we have deployed is of the order of 3,000 meters water depth we're talking about. So these sensors has to withstand such hyperbaric pressures, the 300 bars, 400 bars, and so on. So that is one thing. And of course, the communication would be quite faster compared to what we are talking about through the satellites. That is one advantage. And probably the bottom topography should also allow us to do so. I think it's not that easy unless you have a very well understood mapping of the bottom topography under the seabed. Probably this is also going to be a big challenge in my opinion. But nonetheless, it is always better to explore something new technology-wise, and it can probably supplement, if not complement, in the years to come. That's my opinion. Thank you.
Thank you. Thank you, Dr. Balaji sir. So next question will go to Mr. Pavan Kumar. So this climate change is increasing unpredictability of ocean-related hazards. That I think you will be agreeing with me. From the perspective of multi-hazard warning system framework, how should national disaster management strategies adapted to evolving this risk landscape?
So actually what was discussed by my colleague Mr. Naval Prakash, so we have divided the 4 priorities of Sendai with an additional priority of climate risk management in the national plan. So national plan basically delineates into vertical and horizontal modes. These 4 priorities of Sendai are running vertically, and climate risk management cut across each of the priority in a horizontal mode along with all the deliverables and perils both at the national level and at the state level to be done in a who, what, how, when mode, identifying the agencies and the actions. That is one. Secondly, if we talk about the Coastal Vulnerability Index, we had a program under NCRMP, the Cyclone Risk Mitigation Program, which was being discussed in the morning. Under that, we have basically done a DSS support tool and also the vulnerability mapping of 6 coastal states as a pilot in Maharashtra, in Karnataka, in Goa, that were taken up in Andhra. Also, one was there, Visakhapatnam. So, how they can be a better prepared for coastal inundation issues. So that is one. So the priorities, like what I was telling, be it the national level, the national plan, be the state level, be the district plan, those plans have to work in a vertical manner, in an integrated manner, and the actions identified in the national plan have to be taken care by the state plan, and the state plan should be basically a culmination of the district plan. So it is a bottom-up approach at the state level, and then the state plan is basically guided by the national plan. This is how it should be done. Then all these plans will be talking to each other and not be working in isolation.
Thank you, sir. Perfect answer. So what the national policies for disaster management align with the global initiatives such as the Sustainable Development Goals and the Ocean Decade Tsunami Program in enhancing the disaster resilience? If not, what are the plans to integrate them?
So we started with the, because SDGs have got basically 17 goals with 200 plus targets. So SDGs out of 17, we have focused on 1, we have focused on 11, we have focused on 13, and we have focused to some extent on 16. So 1 is no poverty, 11 is resilient cities, 13 is climate action, and 16 is displacement. So NDMA, what NDMA did, because SDGs are being monitored by MOSPI, Ministry of Statistics and Program Implementation at Government of India level. They have got a DEMO, which is basically a digital dashboard and digital mapping of all the SDG goals by all the ministries. So SDGs has to be taken care by all the ministries. So you can understand like this: SDG is a big umbrella. Then under that umbrella you have got SFDRR, and also you have got COP21 or the Conference of Parties Agreement. Recently we had COP29. So the Conference of Party Agreements agendas, the SFDRR priorities are basically coming under the broad umbrella of SDGs, the goals of SDGs. So SDGs are monitored by MOSPI, SFDRR is being monitored by MHA, and COP is being monitored by MOEFCC. So Government of India and especially NDMA, we have basically targeted and we have aligned our action plans to focus on SDGs. Once we start focusing on SDGs, so based on that we have tried to develop, and it is still under process, the National Database Disaster Management Information System. So NDMIS is being developed. NDMIS has got 2 parts. Part A is basically the SDRF and NDRF, which is basically release of money, the fund. And Part B is talking on the Sindhi priorities and the action taken by the states. Part B is voluntary, Part A is required to be filled, it is mandatory. So once the data is fed into the NDMIS, that NDMIS is on a disinventar platform. NDMIS is basically force the data into SFDRR platform, that is called Sindhi Framework Monitor. That monitor we have to report, and we have to go and tell our progress in every November. Voluntary commitment, but Government of India is very serious with SDGs, focusing on SDGs with MOSPI in the large umbrella, and then simultaneously taking the Conference of Party Agreements by the MOEFCC and the SFDRR agreements, which under the guidance of MHA. This is how it is being done.
Thank you, Pawan. Thank you very much. My question next is Dr. Tiziana. So how does UNESCAP engage with the Asia Pacific member states and contribute to global tsunami preparedness efforts? Do you have any strategic plans for enhancing preparedness in the region in future?
Thank you very much, Bala, for that question. And I think I'll start off by saying that ESCAP is regional. So our interventions are always Thank you. So I'll start again. So we are regional, so our interventions are always based on promoting the cooperation among member states. And here I would like to, so early warning for all. This is really for the foreseeable future, at least foreseeable at my old age is 2030. Younger people in the room, 2040, 2050, but 2030, I think early warnings for all is going to continue to accelerate. And under early warnings for all, I think pillars 1 and pillars 2, pillar 1 and 2, basically on the forecasting and the risk monitoring is going to be more and more important, because it really, the more accurately we can get pillars 1 and 2 done, the more effective and meaningful our last mile early warning will be. Because the last mile early warning is not only about getting the information to the people in time, it's about getting the right information to the right people in a way that they can understand and that they can react to. But getting the right information to the right people is complex. And it relies very much on pillars 1 and 2. And pillars, it's great to hear about the innovative early warnings for all that is taking place in India. New technologies, new methodologies, redundancies being built into the system in terms of how you collect the data and then how you analyze the data, how you process it, how you monitor it. And it's all aimed at, that pinpoint accuracy, that, that track that the cyclone is going to take, and suddenly it turns and it goes away that it's never gone before, all linked to the uncertainties, to the climate change effects, all of that. Now that data, that pinpoint accuracy of the tracks needs to also be combined with not only the track that the cyclones will follow, but what it will do at the ground level. So what we call the impact-based forecasting. And then that also becomes quite complex, because you need to delve deep into the characteristics of communities and people. And in some countries, privacy and all of that becomes an issue. Nevertheless, this integration of the socio-economic with the scientific data is going to be crucial in terms of really making early warnings effective and meaningful for the last mile connectivity. So that's one thing. Very briefly, because I know everybody's exhausted, so I don't want to exhaust people more. But very briefly, in terms of the various options for collecting data, particularly ocean-based data, which everybody agrees is tough, it's difficult, notwithstanding the wonderful things that you spoke about. There was at one point a suggestion to co-opt the private sector. There are many suggestions about co-opting private sector, but one of them was to use the oil exploration companies and the oil rigs in the oceans. And we had done some work on it, more in Southeast Asia than South Asia, but we had quite good feedback, and they seemed to be quite keen on sharing data, because they are out in the high seas and in the various parts of the ocean, and they seem to be quite interested. So I just thought I would mention that. I'm not, promoting it or against it. I'm quite neutral. What I can give you is the feedback we were receiving from the private sector. And finally, and I really don't mean to exhaust anyone. In ESCAP, we have a space-based program, space applications. We are the only regional commission that has a space applications program. One of the interesting things that came out of our ministerial conference, which was hosted by Indonesia in 2022, was the creation of a virtual constellation of satellites that would share high-resolution, commercially valuable satellite imagery among countries. And once again, satellite imagery can be quite invasive, quite intrusive. So what we're working on now is the detail. The devil is in the detail. So one of the key things here is that in terms of setting up an agreement on sharing of satellite imagery pre-disaster, not post. We have that mechanism, the charter, what's it called? The charter, right? Post-disaster, we have it set up already. This would be pre-disaster for monitoring risk in vulnerable areas by inter-country sharing of satellite data. The key thing here is to respect national sovereignty and territorial integrity. And so we would base this sharing of satellite imagery only on receipt of the coordinates that each member state would give us, and it would have, of course, the endorsement of the member state before we share any satellite imagery. But the important thing there is that by sharing satellite imagery pre-disaster, once again, you're building redundancies into the system, huge amounts of data that can be generated, and the preparation of the disaster, preparation for a possible disaster, the risk mitigation happens all before the disaster actually hits. And so that really helps in terms of preparedness, in terms of much more effective management of a disaster from its beginning to its end. Thank you.
Thank you. One more question. In my capacity as a chair of the Global Ocean Observing System, so now we are planning all for the multi-purpose observation system. So you mentioned that we can have also the partnership with the private sectors. So what is actually your the view that how the UNESCAP can support for this kind of a regional collaboration with a global observation system, local partners for the multi-purpose observation system like tsunami monitoring?
Thank you. Thank you for that question. And I think it's an important one. And, you know, ESCAP is a member-driven organization. So we will do anything that our member states ask, as long as it meets UN principles, as long as it's in accordance with our UN charter. But we're member-driven. So if the ideas come from our member states, we are secretariat and we implement. So now, what I think in terms of maybe a little more practical and down to earth, in terms of your question, I do think there's a lot of scope for, and I know we use this word a lot, public-private partnerships, but I think there's a lot of scope for the public, the policymakers, and the private sector operators to sit down together, to talk to each other. The language that the public officials and the private and the UN were a little bit different. We talk, our language is not exactly the same, but there is tremendous amount of goodwill. And I think, you know, we can, the ESCAP can facilitate. We can sit down together and we can really figure out a mechanism where this data is, you know, shared in a more systematic way than it's currently done. And shared, you know, by systematically, I mean across countries, because that's where we need, you know, that's where we need more work to be done. and perhaps shared in a way that's more interoperable and common formats and things like that. But it's a great idea.
Thank you. Thank you. So next, the final to Srinivas. Actually, this how that the IoT-WM must evolve over the past 2 decades, and what gaps still need to be addressed to enhance its efficiency. I feel that you have many of the aspects you covered, but anything actually it is to be covered more, I think you can.
Yeah, you're right, Bala. I spoke in my presentation, so I don't want to take too much of time. Only thing is actually to look at some of these plans, the global plans prepared by the experts, and then try to see where our programs that nationally member states, whatever they're taking up, can really dovetail into those larger regional and global plans. And then look at what is the low-hanging fruit actually, because it's very important to prioritize things. Like for example, if you on say hazard assessment, we need to certainly improve hazard assessments. So if there are projects already being done within the countries or within a group of countries, how we can really take those results and then take it up a notch upwards to be applicable to the broader region. I think that's something we need to do. And say, for example, we are talking about enhancing the accuracies. So while we continue to improve our knowledge of the hazard and risk, like for example, seismic, how do we improve the characterization of the source? How do we improve, have some OBS, like Dr. Mishra was saying, or Balaji was mentioning about improving the, bottom pressure recorders and all, and smart cables and so on. We also need to actually look at, source agnostic kind of measurements. Like if you can expand, that's also something that the Ocean Decade Tsunami program talks about, for example. So what are the networks that we have right now? And the low-hanging fruit would, for example, be how efficiently or effectively data are being shared currently. There might be already existing networks, so start with that. Start, enhance data sharing, and then look at making more, sea level observations. Look at a national, optimal network of sea level observations that you need to have. Say, for example, you want to detect a tsunami from any source in, say, 10 minutes. So it might need, say, about, I'm just putting out numbers. You need to do that analysis first, and then say that, okay, I need 300 tide gauges or 100 bottom pressure recordings. Now, how do we achieve that in a very collaborative way? I think these are some things if we look at, within each member states and then regionally, and then contribute to that. Yeah, so.
Srinivas, only one more question actually. On Ocean Decade Tsunami Program visions, Universal Tsunami Ready Recognition by 2030. What are the key challenges in achieving this ambitious goal, and how can they overcome? What are the challenges mainly we want?
Yeah, so again, the Tsunami Ready, we need to really make an assessment of which are those communities. Like Kamal before was asking about, why a certain number of, states were hit by the tsunami and why some not. And that again boils down to how well we have our hazard and risk assessments. So we need to have those assessments first, and then know how many are those vulnerable coastal communities. Is it, like for example, Odisha says it's 361. They have had some assessments made. So if you actually translate it to the entire country, in India itself it would be close to a few thousands. Now you want to achieve, say for example, universal kind of applicability of tsunami ready recognition globally, it would run into few hundreds of thousands or maybe lakhs. So making that assessment is the first step actually. So do it at the member state level, take it up to the regional level. There are some initiatives being done by the UNESCO IOC right now, trying to make some broad brush assessments to see, okay, if there are, villages or communities within 3 kilometers from the coastline or within a, low elevation coastal zone within less than 10 meters or 20 meter elevation. So how many are those communities, So some simple broad brush kind of assessments, that's where we should start with regionally, and then try to identify those communities, go with scientific studies, inundation models and all, identify and then start implementing. The next thing is actually really, India and Indonesia have implemented right now.
So take those learnings. What are those success stories? Why did things work in Odisha, and then why it has been slow in some other regions? But the engagement of National Disaster Management Authority, and the technical agency hand-holding, like INCOI's hand-holding, and then the coastal communities itself. See, because it's a community-based program, it has to champion should be within the communities. We have identified several of them today, 26 community leaders. So I think that engagement end-to-end, having a scientific basis for assessing what is at risk, and then providing the technical hand-holding by a technical agency to the communities, and then having the provincial disaster management authorities hand-holding those communities, and then a national disaster management authority like NDMA coming up with guidelines. So that's a model which worked in India. There might be a different model which worked in Indonesia or some other countries. So learning from each of these successful models and then seeing where we can actually apply these things. Other thing is Tsunami Ready. There might be other programs which are being, implemented in other countries or other states within India. Say, for example, I mentioned before in my presentation. How can we actually, draw some similarities or parallels between what is being implemented in other countries, like, for example, cyclone. A lot of countries have been dealing with cyclones and storm surges, but they may be, dealing with that preparedness under a different framework. Now, so equating or drawing some parallels with these frameworks and then putting all of this in a multi-hazard perspective, preparedness from a multi-hazard perspective, I think those are some things that we need to kind of think about to really make sure. And then, of course, Tiziana spoke about public-private partnerships, engaging a lot more stakeholders, bringing in a lot of resources. Can we bring in the hotels, actually? Can we bring in infrastructure? Can we bring in the tourism industry? Because hotels, if they are tsunami ready, then actually it's good for tourism. Similarly, infrastructure like airports, ports, they could be tsunami ready. So how do we actually, I think this is a, it's a end-to-end thing that we need to sit and address and, find the right solution for the right, setting actually. Thank you.
Srinivas, one more unleaked question for you. This is actually now we are thinking about tsunami ready. So, but our vision is actually make a multi-hazard ready, then climate resilience. How to combine this one and make more indicators like we have it all now? How actually, what you suggest, what way we should go ahead, at least to see another 1 or 2 years, we can make at least some multi-hazard ready communities. Of course, the OSTM is doing with the cyclone, but if you go to other states, there is some more. For example, Kerala, we have the Kalakadal events, and Tamil Nadu, there is something other thing like that. What is your suggestions on that?
So, see, again, if a community is prepared for tsunami, which is such a short fuse hazard, I think they are more or less prepared, from the perspective of any coastal hazard that can cause inundation, because what we are looking at, see, even for tsunami, we are looking at the hazard, we are actually assessing the, inundation, we are producing a hazard map, inundation map, and then what we are actually trying to see is actually within a certain amount of time, people need to evacuate. You need to have signages, you need to do drills, you need to have, dedicated publicity material, you need to have awareness programs in schools. So the indicators, if you see, generically they are applicable to more or less any other hazard again. So like I mentioned before, these preparedness programs where we need to draw these parallels, you need to actually, you could take these 12 indicators and explore whether, say, for example, you're, preparing a community based on a tsunami hazard, you are actually having an inundation of, say, 2 meter, which is actually 1 kilometer into the coastline. I'm just giving out a number, a low-lying coastal area. Whether that is the maximum extent of hazard for that community from a cyclone perspective, these are some of the scientific questions that we need to ask ourselves. Okay, if a tsunami, if a storm surge is going to be, for any worst case, is going to be less than that 2 meter for that community, they are easily, they're naturally prepared for it. So I think there is some scientific amount of work that needs to be done from the hazard perspective to see whether the particular hazard, multi-hazard when we talk about, whether that particular hazard is actually being covered in this broad envelope of tsunami preparedness that we're doing, and then, try to, just try to equate those indicators and see, I'm sure most of those indicators will be, common actually. Yeah.
Thank you, Srinivas, and all the panelists. I think we got almost expected the replies and expected response from all the panelists. I think it will be much useful for us actually for our future endeavors to make a multi-hazard ready community and improving our the early warning systems. Thank you very much for all the panelists for their taking it my leaked questions yesterday and preparing for it. Thank you very much.
Thank you, sirs. Now, as the National Institute of Ocean Technology is our active partner in the Tsunami Early Warning System, so I request Dr. Balakrishnan, Director in INCOIS, to felicitate Shri Balaji Ramakrishnan. Dr. Prakash Chauhan, Director NRSC, Dr. M.V. Ramanamurthy, Director NCCR, Dr. Prakash Kumar, Director NGRA, was couldn't be here, so we will be sending their mementos later. So, yes. Close this. Yeah. Do you want to say something?
So thank you very much for all taking their time here and preparing for the presentations, preparing for the panel discussions, and all our colleagues who are actually made this event very successful. Thank you very much to all of you. Thank you, sir.
Though it is a solemn day to reflect upon, it is also a day to remember the resilience of humanity and the advancements we have made in disaster preparedness and the response over the years. As we conclude, I invite, if the participants are still interested, if still have patience, may visit our Synops lab and experience our early warning system. Thank you all for making this conclave a meaningful and insightful event. Let us contribute our efforts to build a safer and more resilient future. Thank you all. Thank you for your patience.